Across deserts, oceans, mountains, and frozen wastelands, humanity has dared to build what once seemed impossible. Towers pierce the clouds, bridges span oceans, and machines reshape entire landscapes, leaving nothing untouched by ambition. These megaprojects are more than structures. They are testaments to vision, ingenuity, and the relentless drive to defy nature. From engineering marvels that challenge physics to urban landscapes that stretch imagination, every colossal creation tells a story of risk, innovation, and human audacity. Prepare to witness the world's most insane megaprojects, where scale meets spectacle and ambition knows no limits. The Hoover Dam rises like a fortress carved from stone and concrete, spanning the chasm of Black Canyon, where the Colorado River roars below. Immediately, its sheer scale overwhelms the senses. 379 meters across, 221 meters tall, an architectural giant bridging two states, Nevada and Arizona. The sun glints off its massive curved face, reflecting a history of vision, courage, and engineering audacity. Constructed during the height of the Great Depression, Hoover Dam demanded more than concrete and steel. It demanded the relentless effort of over 21,000 workers. In summer heat exceeding 38 degrees Celsius, laborers scaled dizzying heights, directed molten concrete, and tamed raging river currents, pouring over 3 million cubic meters of concrete that would stand as a testament to human determination for centuries. Music, the dam wasn't built merely to awe. It was built to transform a region. Its massive reservoir, Lake Mead, stretches 180 kilometers, providing water, power, and irrigation to millions. Each of the 17 turbines inside hums with kinetic energy, generating over 2,000 megawatts of electricity, feeding cities across Nevada, Arizona, and California. Standing near the spillways, visitors hear the deafening roar of unleashed water, a symphony of engineering mastery and nature's raw power colliding. From above, the dam appears as a monumental arc against rugged canyon walls, perfectly balanced, precise, and almost impossibly massive. Walking across its observation deck, feeling the concrete vibrate underfoot, one senses a dialogue between humanity and the natural world, an audacious statement that ingenuity can bend rivers, harness energy, and transform landscapes. Beyond its function, the Hoover Dam carries stories etched into every bolt and beam. It embodies the spirit of an era, the triumph over adversity, and the courage to imagine solutions larger than life itself. Visitors can feel history in the air, the sweat of construction, the whispers of engineers, the dreams of a nation determined to rise. As sunlight dances across the glimmering surface of Lake Mead and shadows of canyon cliffs stretch across its walls, Hoover Dam stands eternal, a colossal anchor of ambition, resilience, and ingenuity. Here, human imagination meets raw nature, creating a landmark where courage, technology, and beauty converge, reminding us that some dreams are truly larger than the earth itself. The Yashi Expressway winds through the rugged mountains of Yunnan like a silver ribbon, cutting across deep valleys, steep ridges, and mist-shrouded cliffs. From the first glance, it's clear this isn't just a road. It's a daring statement of human determination, engineering mastery, and the desire to connect places that once felt unreachable. Constructing this expressway was no small feat. Engineers faced treacherous terrain, unstable geology, heavy rainfall, and a mountain fog that clings to the cliffs for months. They carved tunnels through solid rock, built towering bridges that hover above clouds, and designed sweeping curves to maintain safety along hair-raising drops. Every beam, pillar, and curve was the product of meticulous planning, innovative design, and years of relentless work. Traveling along it, the experience is nothing short of breathtaking. Below, valleys disappear into a sea of clouds, while jagged peaks rise sharply into the sky. The wind whistles through tunnels, the mist swirls around towering bridge supports, and the view reminds you how small we are against the power of nature. And yet, in the middle of all this raw beauty and danger, human ingenuity has carved a path that connects communities, trade routes, and cultures. Beyond its technical achievements, the Yashi Expressway is a bridge between worlds. Remote villages, once isolated by mountains, are now linked to cities and opportunity. Farmers can bring crops to market faster. Travelers can glimpse landscapes previously hidden from view, and life flows more freely along its twists and turns. The road is alive with movement, yet it seems to rise naturally from the mountains, harmonizing with the dramatic terrain rather than overpowering it. Standing on one of its observation points or crossing one of its high bridges, it's impossible not to feel awe. The scale, precision, and vision are overwhelming, but what stays with you most is the human story. The engineers, workers, and planners who dared to imagine a connection where nature seemed impassable. The Yashi Expressway is not just infrastructure. It is a monument to ambition, courage, and the unyielding human desire to overcome obstacles. The Delta Works rise along the southwestern coast of the Netherlands like a fortress against the sea. At first glance, it's impossible not to be impressed. Dams, storm barriers, locks, and sluices stretch for miles, holding back one of nature's most powerful forces. This isn't just engineering. It's a lifeline, a fight against floods that could swallow entire towns. It all started after the devastating North Sea flood of 1953, when water swept across the land and thousands of lives were lost. The Delta Works became the answer, a bold plan to protect the low-lying country. Engineers designed massive gates that can rise and fall with the tide, concrete walls that hold back roaring water, and locks that let ships pass safely. For decades, workers labored under wind, rain, and storms, turning a dangerous coastline into a controlled, safe, and awe-inspiring landscape. Walking along the Oosterschelde barrier, you can hear the waves crash against steel and concrete and feel the raw power of the sea just feet away. It's humbling but also thrilling. This is proof that humans can bend nature, not by destroying it, but by understanding it. Saltwater flows are managed, wildlife thrives, and communities sleep safely at night, all thanks to this incredible network of barriers. From above, the Delta Works looks like a massive web, perfectly connecting rivers, islands, and the North Sea. It's elegant, precise, and bold, a reminder that human determination can create beauty even in the face of danger. Every wave that crashes against its gates tells the story of courage, ingenuity, and respect for nature. The Delta Works isn't just a project. It's a symbol of survival, of people refusing to be drowned by circumstance, and of what happens when vision meets relentless determination. Standing here, it's impossible not to feel awe for the sea, for nature, and for the humans who dared to stand against it. The Hong Kong, Zhuhai, Macau Bridge stretches across the South China Sea like a silver ribbon connecting islands and cities, immediately leaving travelers in awe of its scale and ambition. Spanning nearly 55 kilometers, it's more than a bridge. It's a feat of human determination, engineering ingenuity, construction was a monumental challenge. Engineers had to tame the open sea, navigate strong tides, unpredictable weather, and the delicate marine ecosystem beneath. Bridges rise and fall with the water, tunnels plunge beneath the seabed, and artificial islands were built as anchors for the structure. Every beam, pillar, and cable had to withstand typhoons, earthquakes, and the ceaseless motion of the ocean. A technical ballet that required decades of planning and thousands of workers. Driving along it, the experience is electrifying. The horizon stretches endlessly, the water glimmers below, and the wind carries the faint taste of salt as the bridge seems to float between sky and sea. From above, the structure reveals itself as a continuous arc of human ambition, connecting Hong Kong, Macau, and Zhuhai in a way that transforms travel, trade, and life in the region. The bridge is more than a shortcut, it's a lifeline. It cuts travel time between the three cities from hours to mere minutes, linking economies, cultures, and communities that were once separated by water. Ships pass through the shipping channel below, fishermen glide alongside, and the modern skyline of distant cities gradually grows closer with every kilometer. The Øresund Bridge stretches across the waters of the Øresund Strait, linking Denmark and Sweden like a steel thread suspended over the sea. From the moment it comes into view, it commands attention, not just for its elegance, but for the vision and determination that brought it to life. Spanning nearly 16 kilometers, the bridge is part of a unique connection that transitions into an underwater tunnel, allowing ships to pass freely while linking two nations with a seamless transportation artery. Engineers had to master challenging geology, deep waters, and complex tidal patterns, creating a structure that is as functional as it is breathtaking. Traveling across it, you're struck by the blend of scale and grace. The bridge towers rise above the waves, steel cables glinting in the sun, while the calm waters below reflect the motion of passing cars and trains. Rising from the turquoise waters of the Arabian Gulf, where sand meets sea on the iconic crescent of Palm Jumeirah, the Atlantis, the royal resort and residences, stands like a vision of modern luxury. An architectural dream where sky, sea, and human ambition collide. Here, glass and steel reflect the light of dawn and dusk, while panoramic views stretch from the glittering Dubai skyline to the endless horizon beyond. More than just a resort, this is a landmark of extravagance and imagination. Designed by some of the world's leading architects and creators, the structure rises over 40 stories high, its silhouette brushing the skies above Palm Jumeirah like a bridge between earth and possibility. Beneath its elegant exterior, a world of experiences unfolds. Private beaches, sleek infinity pools suspended high above the city, and opulent lounges where every moment feels extraordinary. Step onto the Cloud 22 Sky pool deck, and you feel a quiet thrill as water seems to float against the skyline, offering views that stretch across the Arabian Sea and Dubai's glittering towers. Below, more than 2 kilometers of beachfront invites you to stroll along warm sands, listening to the gentle surf while the city hums in the distance. Within its walls and terraces, guests and residents find not just luxury, but a story of connection between land and water, between human vision and experience. Inside, spaces are curated for delight and discovery. 17 world-class restaurants and bars showcase global cuisine from celebrity chefs, each meal an invitation to taste art and culture. Daylight floods through floor-to-ceiling windows, illuminating elegant suites, penthouses, and private residences where every detail, from panoramic views to bespoke interiors, feels designed for wonder. For some, it's more than a holiday destination. It's a stage for memories. From sun-soaked afternoons by the infinity pools to serene evenings beneath the stars, Atlantis the Royal blurs the line between everyday life and fantasy. Whether you're sipping a sunset cocktail on the terrace or floating above the ocean in a private sky pool, The experience reminds you why this place is called royal. It isn't just built, it's dreamed, lived, and felt horizon to horizon. Rising above the sparkling waters of the Arabian Gulf on Blue Waters Island, Ain Dubai towers into the sky like a colossal eye watching over the city. At 250 meters, it's the world's tallest observation wheel, a gleaming symbol of ambition, engineering, and spectacle that transforms Dubai's skyline with every rotation. Constructing Ain Dubai was a feat of audacity. Massive steel beams, intricate joints, and precision engineering brought together thousands of tons of material, all designed to withstand the desert heat, coastal winds, and the constant rhythm of the sea below. From foundation to pinnacle, every part of this enormous structure demanded careful calculation, patience, and vision. Riding inside one of its 48 glass capsules, visitors are suspended between sea and sky. The city unfolds beneath like a living map. Palm Jumeirah stretches to the horizon. The glittering towers of downtown Dubai rise in clusters, and the endless waters of the Gulf shimmer in the sunlight. The rotation is gentle, almost imperceptible, allowing moments of reflection, awe, and exhilaration. But Ain Dubai is more than a view, it's an experience. Each capsule is a private theater of the city, where guests witness sunrises and sunsets, fireworks, and the pulse of Dubai's modern energy from a vantage point few have imagined. Every rotation tells a story of human ambition meeting art, science, and architecture in one breathtaking landmark. At night, the wheel transforms into a luminous spectacle, lights dancing across its frame, reflecting in the water below, and creating a sense of motion even when it stands still. From every angle, Ain Dubai captures the imagination, a testament to what humans can achieve when bold design, technical mastery, and daring vision unite. Ain Dubai is not just the world's tallest observation wheel. It's a monument to possibility. Rising above the waves, the skyline, and the city itself, it reminds every visitor that even the sky is no limit when creativity and determination take hold.
The Fuxing high-speed train surges across China's vast landscape as a symbol of velocity, precision, and modern mobility, gliding between cities with a quiet authority that reflects the country's commitment to advanced transportation. From dense urban hubs to distant regions, its streamlined form cuts across distance, redefining how quickly people and economies connect. Operating on an expanding network of dedicated high-speed rail lines, the train reaches commercial speeds of around 350 kilometers per hour, supported by aerodynamic engineering, intelligent control systems, and reinforced track infrastructure designed for stability and safety. Its interiors balance efficiency with comfort, integrating digital monitoring, energy-optimized components, and vibration reduction technologies to sustain reliability over long distances. Introduced during the 21st century as part of a broader national rail modernization effort, the Fuxing series represents domestically developed high-speed technology aimed at improving capacity, reducing travel times, and strengthening regional integration. Continuous upgrades in materials, signaling systems, and operational coordination reflect an ongoing evolution in transport engineering. As passengers watch cities blur into countryside through panoramic windows, the experience becomes more than transit. It is a moment suspended between departure and arrival, where acceleration and stillness coexist, revealing how innovation can reshape perception of distance while carrying millions toward opportunity, connection, and motion.
Imagine a land where human ambition stretches farther than the eye can see, where rivers are bridged with engineering marvels, mountains are carved to lay roads in the sky, and entire cities rise from the earth like steel and glass giants. This is China, a nation of mega projects that defy imagination, challenge nature, and push the limits of engineering. From record-breaking bridges to tunnels that pierce mountains, from ultra-modern railways to gravity-defying skyscrapers, each project tells a story of vision, precision, and sheer determination. Get ready to journey into the heart of some of the most extreme, daring, and awe-inspiring constructions on the planet. These are the feats that don't just connect cities, they redefine what's possible. Welcome to China Mega Projects, engineering the impossible. Piercing the skies of Dubai, Burj Khalifa is more than the tallest building in the world. It is a vertical monument to human ambition, engineering precision, and architectural audacity. Standing at a staggering 828 meters, Burj Khalifa dominates the skyline, its tapering spire reaching into the clouds and redefining the very limits of what is possible in urban construction. Every aspect of the building, from its Y-shaped floor plan to its sleek exterior cladding, is meticulously designed to optimize stability, resist extreme winds, and create an unmistakable silhouette visible from miles away. Constructing Burj Khalifa demanded ingenuity on an unprecedented scale. Engineers used a high-strength concrete core, reinforced with a buttress system of wings, to distribute the immense vertical loads while controlling sway caused by high-altitude winds. The exterior is clad in reflective glass and aluminum panels that reduce heat absorption in Dubai's harsh desert climate, while advanced mechanical and elevator systems whisk occupants across more than 160 floors with remarkable speed and safety. Each component, from structural steel to curtain walls, was precision engineered to work in perfect harmony, ensuring the tower's resilience against both environmental forces and the test of time. Beyond sheer height, Burj Khalifa is a masterclass in blending functionality with aesthetic brilliance. Its observation decks, luxury residences, corporate offices, and hospitality spaces coexist seamlessly, while the exterior's tiered design creates elegant setbacks that evoke the form of a desert flower reaching toward the sun. Engineers and architects had to overcome challenges that included foundation settlement, wind vortex shedding, and material performance under extreme temperatures, all while maintaining a visual elegance that made the building iconic. Burj Khalifa is more than a skyscraper. It is a symbol of what humanity can achieve when ambition meets innovation. It transforms the skyline of Dubai into a stage for bold engineering and creative vision, reminding the world that with determination, meticulous planning, and cutting-edge technology, we can reach heights that were once unimaginable, quite literally touching the sky. Rising from the heart of Shanghai, Intercontinental Shanghai Wonderland is a monumental vision where ambition and imagination collide on an unprecedented scale. It is more than a city. It is a universe of engineering marvels, where towering skyscrapers redefine the skyline. Massive bridges span impossible distances, and intricate urban landscapes weave together culture, technology, and innovation. Every element has been meticulously designed to push the boundaries of what humans can achieve, combining futuristic architecture with sustainable technologies and cutting-edge materials. Thousands of engineers, architects, and builders work in unison to transform this dream into reality, creating a space that blends functionality with awe-inspiring grandeur. Beyond its structures, the Wonderland offers immersive experiences, interactive attractions, and cultural hubs that engage, inspire, and captivate every visitor. It is a testament to human ingenuity, a symbol of what can be achieved when vision meets determination, and a bold statement that in Shanghai, the future is not imagined. It is being built before our eyes. Every corner, every detail, every innovation embodies the relentless drive to achieve the impossible, making intercontinental Shanghai Wonderland not just a project, but a new standard for what a city and a civilization can accomplish. Rising from the frozen landscapes of northern China, the Harbin Opera House is a breathtaking fusion of art, architecture, and nature, designed to reflect both the icy surroundings and the flowing curves of the Songhua River. Every line and contour of this monumental structure embodies a harmony between human creativity and the raw beauty of the environment, blending organic forms with cutting-edge engineering. Inside, performance spaces are crafted for acoustics of the highest precision, allowing music, dance, and theater to resonate with crystal clarity, while exterior surfaces shimmer with fluid elegance that mirrors the surrounding snow and ice. The Opera House is more than a building. It is a cultural landmark, a hub where creativity meets innovation, and where international artists and audiences converge to celebrate human expression. From the seamless integration of natural landscapes to its daring architectural vision, the Harbin Opera House stands as a testament to ambition and imagination, proving that even in the harshest climates, beauty, art, and engineering can rise in perfect harmony to inspire generations. In the vibrant Longhua district of Shenzhen stands the remarkable Meeresfrau Pavilion, an architectural project that took 15 years to complete and serves as the expressive headquarters for the fashion brand Meeresfrau, embodying a rare fusion of art, nature, and engineering on an immense scale. Designed by the New Zealand firm Architecture Van Brandenburg, this building breaks away from conventional forms by drawing inspiration from the natural world. Biomimetic shapes influenced by the spiky exoskeletons of insects and fluid organic geometries, resulting in a structure that feels alive and dynamic, as though it has grown rapidly. Spanning roughly 120,000 square meters on a 5.5 hectare island site, the pavilion blends steel and reinforced concrete with a mosaic exterior composed of tiles, brick fragments, and stones, a surface that recalls both tribal art and futuristic fantasy, while also echoing the early influences of architects like Antoni Gaudi and Santiago Calatrava in its flowing, artful complexity. It has attracted international attention, including at the 14th Venice Biennale of Architecture, for its visionary approach that challenges traditional corporate headquarters design, transforming what could have been a static corporate campus into a monument of creative expression and cultural ambition. More than just a headquarters, it represents a bold statement of identity from Meeresfrau, a brand rooted in fashion, yet striving to merge aesthetic, natural, and engineered systems into a cohesive architectural narrative that pushes the boundaries of form, sustainability, and artistic ambition in the built environment. Rising as one of the most ambitious feats of modern engineering, Beijing Daxing International Airport is more than just a transportation hub. It is a bold statement of human vision, efficiency, and innovation. Designed to handle over 100 million passengers every year, the airport's starfish-shaped terminal redefines the very concept of space, combining futuristic architecture with an unparalleled flow of movement that seamlessly guides travelers from check-in to boarding without congestion. Every curve, corridor, and concourse has been meticulously engineered for maximum efficiency, reflecting a harmony between aesthetics, functionality, and cutting-edge technology. Advanced systems manage everything from luggage handling and security checks to climate control and energy efficiency, creating an experience that is both effortless and astonishing. Beyond its technical prowess, Daxing International Airport stands as a global gateway, connecting China to the world while embodying the nation's ambition to lead in infrastructure, design, and innovation. From the sweeping interior spaces that feel simultaneously grand and intimate, to the intricate orchestration of operations that keeps thousands of flights on schedule daily, the airport represents a triumph of precision and planning. It is a place where architecture and engineering merge with vision, where every detail, from the natural lighting that guides travelers to the sustainability measures built into the structure, reflects foresight and ingenuity. Beijing Daxing International Airport is not just an airport. It is a living testament to what human creativity and determination can achieve, a symbol of connectivity, progress, and the relentless drive to build infrastructure that inspires, amazes, and sets new global standards for the future of air travel. Standing tall in the heart of Shanghai's futuristic Pudong district, Jinmao Tower is one of China's most iconic skyscrapers and a defining symbol of the city's rapid rise on the global stage. Completed in 1999 after construction began in 1994, this mixed-use tower soars 420.5 meters above the ground with 88 stories above its base, a height and design purposefully tied to the number 8, considered highly auspicious in Chinese culture for prosperity and wealth, and reflected in its octagonal core and rhythmic tiered setbacks that echo traditional pagoda architecture. Designed by the renowned Chicago-based firm Skidmore, Owings and Merrill, Jinmao was once the tallest building in China and remains a centerpiece of the Lujiazui skyline alongside the Shanghai World Financial Center and Shanghai Tower, embodying a fusion of cultural heritage and advanced engineering. Its lower floors house offices and major commercial spaces, while the middle levels are home to the luxurious Grand Hyatt Shanghai, which, at its opening, was the world's highest hotel, featuring one of the tallest atriums on Earth. At the very top, the 88th floor observation deck offers panoramic views of the city's vast expanse and the winding Huangpu River, while adventurous visitors can experience the Skywalk, a glass-edge path that pushes the limits of height tourism. More than a building, Jinmao Tower stands as a testament to Shanghai's transformation from humble farmlands into a global economic powerhouse, a structure where tradition and modernity meet and where engineering ambition reaches skyward. Nestled in the rolling hills of Cornwall, England, the Eden Project emerges like a futuristic oasis amid a reclaimed clay pit, its gigantic biomes gleaming beneath the sky. Each dome, a lattice of hexagonal and pentagonal panels, houses entire ecosystems, transforming human ambition into a living, breathing celebration of nature. Walking among the tropical rainforest biome, you feel the humidity rise, hear the rush of hidden waterfalls, and smell the rich scent of exotic plants. Towering trees, some reaching the height of a 5-story building, stretch toward the ceiling, while rare birds flit among flowers, creating an immersive reminder of the planet's biodiversity. Step into the Mediterranean biome, and the climate shifts instantly. Olive trees, grapevines, and lavender bathe in soft light, evoking sun-drenched shores thousands of miles away. Every pathway, every plant, every curated ecosystem is a testament to careful planning, innovation, and the human desire to preserve and understand the natural world. The Eden Project is more than a greenhouse. It's a story of transformation. Built in a former China clay pit, the site itself tells a tale of environmental renewal, where desolate land became a living laboratory and a global destination. Visitors ascend boardwalks, bridges, and terraces that weave through the biomes, feeling a sense of awe at both nature's scale and human ingenuity. At night, subtle lighting illuminates the translucent domes, giving the biomes an ethereal glow. From above, the Eden Project appears as a constellation of geometric forms, a reminder that architecture and ecology can coexist, creating spaces that educate, inspire, and connect people to the planet's fragile beauty. Here, every step invites reflection. It is a place where science, sustainability, and wonder converge, a modern monument to the Earth itself, celebrating what humans can achieve when creativity and care meet nature's boundless complexity. Rising above the winding hills and clustered skyscrapers of southwest China's megacity, the Huangzhuan interchange unfolds like a concrete labyrinth suspended in the air, a place where steel, roadways, and human ambition collide in breathtaking complexity. At first glance, it looks almost unreal, as if engineers had spread a city's worth of highways over 5 levels and woven them together like strands of silk. This isn't just another highway crossing. Here in the Nannan district of Chongqing, more than 20 ramps twist, curve, and branch into 8 directions, connecting major expressways, urban arteries, and strategic transport corridors. Some of its elevated roads rise nearly 37 meters above the ground, the height of a 12-story building, making it one of the most intricate and ambitious interchanges anywhere in the world. Building it was a puzzle of immense scale. From 2009 until its opening in 2017, planners and workers grappled with the demands of mountainous terrain, the needs of one of China's fastest-growing cities, and the engineering challenge of routing traffic efficiently through a landscape that seems to defy order. Ramps intersect like threads in a giant web, each one a pathway linking distant neighborhoods, the airport, major bridges, and the heart of the metropolis. Yet navigating it can feel like entering a maze by design. From observation points around the interchange, the scene is almost dizzying. Layers of roadways stack above one another. Cars drift through sweeping curves, and the city's hills rise and fall around the structure, blurring the line between landscape and infrastructure. Some describe it as a spaghetti junction, a nickname meant as much for admiration as bewilderment, while others say it resembles a living organism, its lanes pulsing with the flow of urban life. But this is more than a tangle of roads. It's a testament to planning under pressure, a solution to congestion built for a city that defies easy engineering answers. For Chongqing's millions of residents, it stands as a vital hub that moves people and goods across daunting topography, shrinking distances and connecting lives. And for visitors and engineers alike, it's a place that inspires awe, a reminder that sometimes the greatest feats of human design emerge where challenge and necessity meet. Rising above the Pearl River in Guangzhou, the Canton Tower twists gracefully into the sky like a giant ribbon caught in the wind. At 604 meters, it commands the skyline with elegance and audacity, immediately marking itself as one of China's most iconic modern landmarks. From its base to the observation decks, the tower is a marvel of engineering and design. Its twisting, hyperboloid shape not only creates a striking visual signature, but also reduces structural stress from wind, blending form with function in a perfect harmony of architecture and physics. Every curve, every line was calculated to create a landmark that could both dazzle and endure. Visitors riding the high-speed elevators are whisked upward in seconds, leaving the bustling city behind as they ascend above the river. From the top, the view is mesmerizing. The Pearl River glimmers like liquid silver, the city stretches to the horizon, and the modern skyline of Guangzhou unfolds below in a dazzling mosaic of light, movement, and energy. Canton Tower isn't just a viewing platform, it's a stage for adventure. Thrill seekers can ride the Skydrop, where cabins glide along the exterior for an exhilarating descent, or step onto the bubble tram at the pinnacle, circling the tower in a floating capsule with panoramic vistas that blur the line between sky and earth. At night, the tower transforms into a luminous spectacle. Thousands of LED lights dance across its twisting frame, reflecting in the Pearl River and turning the structure into a beacon of innovation, culture, and ambition. From every angle, it tells a story of human imagination and determination, a monument where technology, aesthetics, and the urban spirit converge. The Cannon Tower is more than steel and glass. It is a symbol of Guangzhou's rise as a global city, a celebration of daring design, and a reminder that in China, engineering and creativity can reach heights as breathtaking as the sky itself. Rising like a sail above the turquoise waters of the Arabian Gulf, the Burj Al Arab dominates Dubai's skyline with unmistakable elegance. At 321 meters, this iconic hotel isn't just a building. It's a symbol of ambition, luxury, and human imagination, where architecture becomes art and engineering meets fantasy. Set on its own artificial island, connected to the mainland by a sweeping bridge, the Burj Al Arab is immediately striking from every angle. Its sail-shaped silhouette reflects the sun by day and shimmers against the city lights at night, a beacon of modern Dubai and a monument to bold vision. Step inside, and the experience transcends expectation. Vast atriums rise like crystalline cathedrals, with sweeping staircases, gold leaf accents, and cascading waterfalls. Every corridor, every lounge, every suite has been crafted with meticulous attention to detail, blending traditional Arabian design with contemporary innovation. From the panoramic suites, visitors gaze across the Arabian Gulf, watching yachts drift along the water and the sprawling city beyond. Dining here becomes theater, restaurants perched high above the sea, offering world-class cuisine with views that make every meal unforgettable. At night, the hotel transforms into a living sculpture. Lights trace the curves of the sail, reflecting on the calm waters below, creating a shimmering silhouette that seems almost weightless against the stars. From every perspective, the Burj Al Arab tells a story of daring, vision, and luxury beyond imagination. More than a hotel, it is an experience where human ingenuity and aesthetic mastery meet, reminding every visitor that architecture can inspire awe and elevate the ordinary into the extraordinary. The Burj Al Arab stands as a symbol. In Dubai, even the sky is not the limit. Winding through some of the most dramatic mountains on Earth, the Karakoram Highway stretches over 1,300 kilometers, linking Pakistan and China across the towering Karakoram Range. Often called the eighth wonder of the world, it climbs steep valleys, crosses roaring rivers, and clings to cliffs where the mountains seem almost vertical, a testament to human courage and engineering vision. Constructed in the 1960s and 70s, the highway carved its path through glaciers, unstable rock, and extreme altitudes above 4,500 meters. Landslides, snowstorms, and freezing winds were constant challenges. Yet engineers and workers persisted, creating a road that threads together remote villages, trading posts, and breathtaking landscapes few have seen. Driving along the highway, travelers experience a constantly shifting panorama. Jagged peaks towering above clouds, rivers tumbling over boulders, and deep gorges that vanish into the mist below. Every bridge, every hairpin turn, is a delicate balance between risk and possibility, a reminder that human determination can tame even the most formidable terrain. The Karakoram Highway is not just a road, it is a lifeline. It connects cultures, facilitates trade, and invites adventurers to witness the raw power of nature while appreciating the skill it takes to move through it safely. For mountaineers heading to K2, it is the first step into the high-altitude wilderness, offering glimpses of glaciers, snowfields, and mountain lakes shimmering like jewels in the sun. Perch high on the sheer rock face of Monte Baldo in northern Italy, the sanctuary of Madonna della Corona appears at first like a dream carved from stone, a place where earth, sky, and spirit meet on a cliff above the Adige Valley. From a distance, it looks impossible, a church wedged into a vertical precipice at about 774 m above sea level, as if suspended between heaven and earth, inviting silence before words even arrive. Its origins reach back centuries. In the Middle Ages, hermits seeking solitude and prayer made their home in natural caves here, drawn by the solitude and the rush of wind at the mountain's edge. Over time, humble chapels grew into something more, anchored into rock and stone with devotion and sheer effort. By the early 1500s, what began as a tiny refuge became a sacred church, expanded and transformed over the years into the sanctuary pilgrims know today. Walking toward it, you feel both the pull of history and the scale of nature. Trails like the legendary Sentiero della Speranza, the Path of Hope, wind through forests and switchbacks, leading pilgrims and travelers alike toward the ringing bells high above the valley below. At times the climb feels like a meditation, every step a step away from the ordinary and closer to something larger than oneself. Inside the sanctuary, centuries of reverence meet the raw stone of the mountainside. Frescoes, chapels, and quiet alcoves harbor votive offerings left by the faithful. Crutches, medals, photographs, tangible echoes of prayers answered, struggles shared, and hopes held. It's a place shaped by faith, not just by architects and builders. Stepping onto the terrace, the vista opens across the Adige Valley, spilling out toward distant hills and the shores of Lake Garda. The expanse is breathtaking and unsettling, a reminder of how small we are against time, rock, and sky, yet how deeply we can connect with both place and purpose. The sanctuary of Madonna della Corona isn't simply a structure carved into cliff. It's a testament to human devotion, courage, and awe. For centuries, it has drawn those seeking peace, reflection, and a moment suspended between heaven and earth, a quiet, powerful threshold where the mountains speak and visitors listen. In the vibrant port city of Kaohsiung, where ocean air meets urban energy, the Kaohsiung National Stadium rises like a dragon coiled in motion. Its sweeping, open structure unlike any traditional arena. From above, its form curves in a semi-spiral, a design that feels alive, as if the stadium itself is breathing with the rhythm of the city. Built for the 2009 World Games, this isn't just a stadium, it's a statement of the future. Designed by renowned architect Toyo Ito, the structure blends cutting-edge engineering with environmental consciousness. Its massive roof is covered with thousands of solar panels, making it one of the largest solar-powered stadiums in the world, capable of generating much of its own electricity. Step inside, and the openness is striking. Unlike enclosed arenas, the stadium welcomes sunlight and wind, creating a natural flow of air that reduces the need for artificial cooling. The seating curves gracefully around the field, offering clear views from every angle, while the surrounding structure frames the sky, turning every event into a shared experience between architecture and nature. During major events, the stadium comes alive. Crowds fill the stands, lights shimmer across the sweeping steel framework, and energy pulses through the open-air design. Yet even in silence, the structure holds a quiet power, a reminder that innovation doesn't always mean excess, but sometimes harmony between human creation and the environment. At night, the stadium transforms into a glowing landmark. Soft illumination traces its flowing lines, emphasizing its organic shape, as if a luminous ribbon has been laid across the city. From a distance, it feels less like a building and more like a living sculpture, an icon of sustainable design in a rapidly modernizing world. The Kaohsiung National Stadium is more than a venue for sport. It is a vision of what architecture can become: efficient, expressive, and deeply connected to its surroundings. A place where technology, nature, and human ambition come together, proving that even the largest structures can move with elegance and purpose. Towering above the waters like a floating city, the icon of the seas redefines what it means to travel the ocean. Departing from the vibrant shores of Miami, this colossal vessel isn't just a cruise ship. It's a world of its own, where innovation, entertainment, and engineering converge on an unimaginable scale. Stretching over 365 meters in length and capable of carrying nearly 10,000 people, including crew, the ship feels less like a vessel and more like a moving metropolis. Neighborhoods unfold across its decks, each one designed with its own atmosphere, from tranquil retreats to adrenaline-filled zones that pulse with energy. At the heart of the ship lies a record-breaking water park at sea, where towering slides twist high above the ocean, sending riders spiraling down with nothing but sky and horizon around them. Nearby, infinity pools seem to merge with the endless Atlantic, creating the illusion of floating between sea and sky. But beneath the excitement lies remarkable engineering. Powered by liquefied natural gas, the ship represents a step toward more sustainable cruising, while advanced stabilization systems keep the experience smooth even across open waters. Every detail, from propulsion to waste management, has been carefully designed to handle the scale of a city drifting across the ocean. As day turns to night, the ship transforms into a glowing spectacle. Lights shimmer across its decks, music echoes through open spaces, and the sea reflects a moving constellation of color. From above, it appears almost unreal, a luminous island gliding through darkness. Yet beyond the luxury and spectacle, the icon of the seas represents something deeper: humanity's endless desire to push boundaries, to take something as vast and unpredictable as the ocean, and not just cross it, but transform it into a destination itself. In a world where cities stand still, this one moves, carrying thousands of stories across the horizon, redefining travel, and proving that even on the open sea, imagination has no limits. Cutting through the heart of the Japanese Alps, the Tateyama-Kurobe Alpine Route is not just a journey. It's an experience that feels almost otherworldly. Stretching between Toyama and Nagano, this remarkable route carries travelers across towering peaks, deep valleys, and landscapes that shift dramatically with the seasons. Unlike a single road or railway, the route is a seamless chain of transport systems: cable cars, ropeways, buses, and tunnels, each one designed to navigate terrain too extreme for ordinary travel. As you ascend higher into the mountains, the air cools, the silence deepens, and the scenery becomes increasingly surreal. In spring, the route reveals its most iconic spectacle: the legendary snow corridor. Massive walls of snow, sometimes rising over 20 meters high, line the road like frozen cliffs, creating a passage that feels carved from ice itself. Visitors walk between these towering barriers, dwarfed by nature's scale and power. Deeper into the journey lies the engineering marvel of the Kurobe Dam, Japan's tallest dam. Here, water crashes down in dramatic releases, echoing through the mountains, while the surrounding peaks stand as silent witnesses to both natural force and human ingenuity. Every segment of the route reveals a new perspective. Cable cars gliding over forests, ropeways suspended above valleys, and panoramic views that stretch endlessly across the alpine horizon. It's a place where movement itself becomes part of the adventure, each transition offering a fresh encounter with the landscape. Yet beyond its beauty, the Alpine route is a triumph of determination. Built in one of Japan's most challenging environments, it represents years of effort to connect isolated regions while preserving the fragile mountain ecosystem. As seasons change, so does the route. Lush greenery in summer, fiery colors in autumn, and a pristine white world in winter. No two journeys are ever the same, yet each one carries the same sense of wonder. Here, high above the ordinary world, the Tateyama-Kirobe Alpine route reminds us that sometimes the most incredible destinations aren't places we stay, but journeys we experience step by step through the extremes of nature and the limits of human possibility. Above the relentless traffic and energy of Thailand's capital, the BTS Skytrain glides effortlessly through the skyline of Bangkok, a sleek ribbon of steel cutting through the chaos below. While the streets remain crowded and unpredictable, up here, movement is smooth, fast, and almost futuristic. Built to solve one of the city's greatest challenges, crippling traffic congestion, the Skytrain transformed how millions move every day. Elevated above the roads, it bypasses the noise, the heat, and the endless gridlock, offering a clear, uninterrupted path across the city's busiest districts. As the train speeds along its tracks, passengers are treated to a constantly shifting view. Towering skyscrapers, golden temples, bustling markets, and neon-lit streets. It's a journey that reveals the contrast of Bangkok itself, a city where tradition and modernity exist side by side. The engineering behind the system is deceptively simple in appearance, but complex in execution. Massive concrete pillars support the elevated tracks, carefully designed to withstand both the weight of continuous transit and the challenges of an urban environment. Every station is positioned like a gateway, seamlessly connecting the city's commercial and residential hubs. But the Skytrain is more than infrastructure. It's a symbol of adaptation. In a city once overwhelmed by traffic, it represents a shift toward efficiency, sustainability, and forward-thinking urban design. It doesn't just move people, it reshapes how the city breathes and functions. At night, as the city lights flicker on, the trains become streaks of motion against the glowing skyline, silently weaving through the urban landscape. Below, life continues at its usual pace, but above, the future is already in motion. In a country where large portions of land sit below sea level, survival itself depends on engineering. Rising from the coast of the Netherlands is a system so vast, it's often called one of the greatest civil engineering achievements of the modern era, the Delta Works. This isn't a single dam or barrier. It's an interconnected network of dikes, sluices, locks, levees, and movable storm surge barriers, built after the catastrophic 1953 North Sea flood that killed more than 1,800 people and devastated thousands of homes. The message was clear: either control the sea or live at its mercy. Spanning decades of construction beginning in the late 1950s, the project dramatically reshaped the Dutch coastline by closing off estuaries and reinforcing vulnerable regions. Engineers shortened the exposed coastline by hundreds of kilometers, reducing flood risk and protecting millions of residents and vast economic infrastructure. The crown jewel is the Oosterscheldekering, a massive movable barrier stretching about 9 kilometers. Instead of sealing the sea permanently, giant steel gates remain open under normal conditions to preserve ecosystems and fisheries, but during storms they descend, holding back surging tides with staggering force. Designing structures like this meant confronting extreme variables: tidal energy, saltwater corrosion, shifting seabeds, and waves powerful enough to destroy conventional defenses. Every component required precision, from reinforced concrete piers to hydraulic systems capable of moving gates weighing hundreds of tons. Today, the Delta works stand not just as infrastructure, but as a national shield, a reminder that geography is not always destiny. Through ingenuity and persistence, the Dutch didn't retreat from rising waters. They engineered a way to coexist with them. It's proof that sometimes the greatest construction challenge isn't reaching the sky, but holding back the ocean itself. Cut deep into the rugged canyon of the Colorado River stands a structure that redefined what modern engineering could accomplish. The Hoover Dam isn't just a wall of concrete. It's a symbol of ambition built during one of the harshest economic periods in modern history. Completed in 1936, this colossal arch-gravity dam rises about 221 meters high and stretches 379 meters across Black Canyon, straddling the border between Arizona and Nevada. Its purpose was monumental: tame the unpredictable Colorado River, provide irrigation water, control floods, and generate electricity for a rapidly growing region. The construction challenge was staggering. Workers first diverted the river through massive tunnels carved in the canyon walls. Then came the concrete. More than 4.4 million cubic meters poured in carefully planned blocks rather than one single mass. If cast all at once, the heat from curing could have taken over a century to dissipate and crack the structure apart. To solve this, engineers embedded hundreds of miles of cooling pipes throughout the concrete. Chilled water circulated through them, accelerating cooling so each block solidified safely in weeks instead of decades, a technique that became a model for future megaprojects. Behind the dam lies Lake Mead, one of the largest reservoirs in the United States, storing tens of billions of cubic meters of water and supplying hydroelectric power to millions across the Southwest. Beyond statistics, Hoover Dam represents control over scale, harnessing natural forces powerful enough to carve canyons and redirecting them toward human needs. Even nearly a century later, engineers still study it, not just for its size, but for the ingenuity that made its construction possible. Hoover Dam proves that sometimes the greatest engineering triumphs aren't about reaching upward, but about mastering the forces flowing beneath our feet. Out in the turquoise waters of the Persian Gulf lies a project so ambitious it can be seen from space, a man-made island shaped like a giant palm tree. This is Palm Jumeirah, one of the boldest land reclamation experiments ever attempted. Constructed in the early 2000s, the island wasn't built with steel or concrete foundations, but primarily with sand and rock. Engineers dredged roughly 120 million cubic meters of sand from the seabed and reinforced it with about 7 million tons of rock to form the crescent breakwater, protecting the palm from waves and erosion. That's material on a scale comparable to building several pyramids. Creating the iconic shape required extraordinary precision. Instead of traditional surveying alone, teams relied heavily on satellite-based positioning systems to guide dredging vessels, ensuring the fronds and trunk aligned exactly with the master plan. Without accurate placement, the entire structure could have warped or destabilized. But shaping the island was only half the challenge. Sand alone shifts over time, so engineers used vibrocompaction, vibrating probes inserted deep into the seabed to densify and stabilize the ground. This process reduced settlement risk and made it possible to support hotels, roads, and luxury residences above. Today, Palm Jumeirah hosts thousands of homes, resorts, and infrastructure networks. Yet beneath the glamour lies a continuous battle against nature, sediment movement, coastal erosion, and environmental impacts that require ongoing monitoring and maintenance. Palm Jumeirah isn't just an island. It's a statement, proof that modern engineering can redraw coastlines, reshape geography, and turn imagination into physical reality on a planetary scale. stretching across one of the most unpredictable bodies of water in East Asia. The Hangzhou Bay Bridge is less a road and more a test of engineering nerve. This massive highway crossing links the cities of Jiaxing and Ningbo along China's eastern coast. At about 35.7 kilometers long, it ranks among the longest transoceanic bridges ever built. And its purpose wasn't just convenience. By carving a direct path over the bay, it slashed travel distance between Ningbo and Shanghai from roughly 400 kilometers to 180 kilometers, cutting journey time nearly in half. But the numbers alone don't capture why engineers call this project extreme. Hangzhou Bay is infamous for violent tidal forces, typhoon-driven winds, seismic risk, and waves that can climb several meters high. Designing a stable structure here meant confronting multiple natural stresses simultaneously: currents, corrosion, wind loading, and shifting seabeds. Instead of relying on traditional concrete piles, engineers drove deep steel piles into the seabed, chosen specifically for durability against corrosion and tidal stress. Massive cranes weighing thousands of tons positioned bridge sections into place under brutal working conditions at sea. Even the structural form was deliberate, a cable-stayed configuration capable of resisting complex loads while maintaining flexibility under extreme environmental forces. The result is a structure where load paths, material selection, and geometry all serve a single goal: survival. Because in a location like this, failure isn't theoretical. It's calculated against every tide, every storm, and every vibration transmitted through steel anchored beneath the ocean floor. And yet, day after day, vehicles glide across it without a second thought. Proof that sometimes the most dangerous constructions don't look dangerous at all. Clinging to the face of a sheer cliff as if gravity were optional, the Hanging Temple is one of the most improbable structures ever built by human hands. Located near the base of Mount Hung in Datong, this architectural anomaly dates back more than 1,500 years, with origins traced to the late Northern Wei Dynasty, period around the 5th century. At first glance, it looks impossible: a cluster of wooden halls and walkways suspended about 75 meters above the ground, embedded into vertical rock. But what appears fragile is actually calculated engineering. The temple isn't simply hanging from those thin-looking stilts beneath it. Those supports are partly psychological, visual reassurance. The real load-bearing system lies hidden: horizontal wooden beams anchored deep into holes carved into the cliff face. The rock itself carries much of the weight, distributing forces inward rather than downward. In placing the temple, there wasn't just aesthetic ambition. The elevation protects it from flooding and erosion. The overhanging cliff shields it from rain and direct sunlight, natural climate control that has helped preserve the structure for centuries. Positioning also reduced wind exposure compared to ridgetop construction. But engineering is only half the story. Inside, the temple uniquely blends Buddhism, Taoism, and Confucianism, three philosophical traditions typically housed separately. It's one of the rare physical spaces where these belief systems coexist architecturally, symbolizing coexistence rather than competition. Still, survival has never been guaranteed. Weathering, seismic activity, and centuries of human use constantly threaten structural integrity. Modern restorations reinforce weakened beams, yet the core design, timber inserted into stone, remains fundamentally ancient. And that's what makes the Hanging Temple unsettling. It's not just that it stands on a cliff. It's that it has stood there for over a millennium, balancing faith, physics, and risk, quietly daring gravity to disagree. Carved into the sheer cliffs above a roaring river, the Skipper's Canyon Road is a road that feels as if it defies logic itself. Winding through the rugged terrain near Queenstown, this narrow, unsealed track clings to the mountainside with barely enough space for a single vehicle. Built in the late 1800s during the gold rush, the road was never designed for modern traffic. Yet today, it remains largely unchanged. No guardrails, no safety barriers, just a raw path etched into rock, overlooking a steep drop into the canyon below. Every turn tests the driver's nerve. Blind corners appear without warning. Loose gravel shifts beneath tires, and the road narrows to the point where even the smallest mistake could be unforgiving. In many places, there is no room to turn back, only to move forward, trusting skill and focus with every meter. Below, the Shotover River cuts through the canyon, its turquoise waters crashing against the rocks, a constant reminder of the height and danger above. The cliffs rise sharply on one side, while the other falls away into open air, creating a driving experience that feels both thrilling and intimidating at the same time. And yet, despite the risk, the road draws adventurers from around the world. For those who dare to travel it, the reward is unmatched. Breathtaking views of untouched wilderness, silence broken only by wind and water, and the rare feeling of standing on the edge between control and chaos. At sunset, the canyon glows in shades of gold and amber, shadows stretching across the jagged landscape. The road, etched into the mountainside, becomes almost invisible, a reminder of how small human creations are compared to the vastness of nature. Skipper's Canyon Road is not just a route. It's a challenge, a relic of history, and a test of courage. A place where every journey demands respect, and where the line between beauty and danger is as thin as the road itself. Rising alone at the western edge of the Himalayas, the Nanga Parbat towers at 8,126 meters, a colossal wall of rock and ice that has both fascinated and terrified climbers for generations. Known as the Killer Mountain, it stands apart, isolated and unforgiving, its slopes carved by avalanches, storms, and extreme altitude. Unlike other peaks clustered in ranges, Nanga Parbat rises dramatically from the surrounding valleys, creating one of the greatest vertical reliefs on Earth. From the lush green plains below to its icy summit, the mountain climbs more than 7,000 meters, an immense, almost overwhelming presence that dominates the landscape. The mountain's most infamous face, the Rupal Face, is the tallest mountain face in the world, a near-vertical wall of rock and ice stretching over 4,600 meters. It is a place where even the smallest mistake can mean disaster, where climbers battle thin air, brutal cold, and unpredictable weather that can change in moments. For decades, Nanga Parbat earned its deadly reputation. Early expeditions faced repeated tragedy, with avalanches and exposure claiming lives long before climbers could reach the summit. Even today, despite modern gear and experience, it remains one of the most dangerous 8,000-meter peaks to climb. Yet the mountain also possesses a haunting beauty. Glaciers shimmer under the sun, clouds wrap around its peak like a shifting veil, and at dawn, the summit glows in shades of gold and crimson. From a distance, it appears almost peaceful, masking the extreme challenges hidden within. For the people living in the valleys below, it is both a guardian and a mystery. For climbers, it is a test of endurance and courage. And for the world, it stands as a reminder that some places on Earth remain beyond easy conquest. Nanga Parbat is not just a mountain, it is a force of nature, a place where ambition meets reality, and where only the most determined dare to stand at its summit, looking out over one of the wildest landscapes on the planet. Rising from the windswept plains of southern England, Stonehenge is a structure that continues to mystify scholars, engineers, and visitors alike. Built over 4,000 years ago, its massive sarsen stones, some weighing up to 30 tons, were transported from quarries miles away, a feat that would challenge even modern machinery if attempted without cranes or trucks. The purpose of Stonehenge remains a subject of debate, but the precision with which its stones were arranged, aligned with solstices and celestial events, suggests a sophisticated understanding of astronomy and geometry far ahead of its time. Constructing Stonehenge demanded incredible ingenuity. Ancient builders used wooden sledges, ropes, and sheer manpower to move and raise the stones into place, creating post and lintel formations that have survived millennia. The foundation and placement were calculated carefully to ensure stability, even as the site endured centuries of erosion, shifting soil, and weather extremes. The engineers of that era managed to create a structure that is both monumental and enduring, despite the complete absence of modern technology. Stonehenge is more than a prehistoric curiosity. It is a testament to human ambition and organizational skill. Its precise alignment with the sun, its harmonious proportions, and the sheer scale of the undertaking make it a marvel of ancient engineering. Standing among the stones today, one feels the weight of history and the audacity of those who dared to construct something that could withstand both time and nature, leaving a legacy that continues to inspire awe and wonder. Carving a path through the narrowest point of Central America, the Panama Canal stands as one of the most audacious feats of human engineering in history. Connecting the Atlantic and Pacific Oceans, it transformed global trade by drastically shortening maritime routes, eliminating the need for ships to navigate the treacherous waters around South America's Cape Horn. The canal was never just a waterway. It was a battle against geology, climate, and disease. Construction required moving millions of cubic meters of earth through tropical jungles and mountainous terrain. Workers contended with heavy rainfall, unstable soils, and relentless tropical diseases such as malaria and yellow fever. The early 20th century technology available made excavation stabilization, and water management extraordinarily challenging. Yet engineers overcame these obstacles with ingenuity, inventing lock systems that could lift ships hundreds of feet above sea level and then safely lower them to the next waterway. The canal's locks are marvels of precision engineering. Massive gates, some as tall as an 11-story building, operate with minimal friction, moving enormous ships in a matter of minutes. To conserve fresh water, regulating basins adjacent to each lock recycle water for the next cycle, an innovation that allows the canal to function efficiently despite its tropical environment. The system is so finely tuned that a single misalignment or mechanical failure could bring global shipping to a halt. Over a century after its completion, the Panama Canal continues to astonish engineers and travelers alike. Modern expansions have accommodated the largest vessels on Earth, demonstrating the foresight of its original designers. Every ship passing through this waterway is a testament not just to human ambition, but to the precise orchestration of geology, hydraulics, and labor. The Panama Canal proves that when humanity confronts natural obstacles on a monumental scale, determination and engineering can bend the landscape to our will. Rising proudly above the skyline of Kuala Lumpur, the Merdeka 118 is not just a building. It is a statement of ambition and engineering audacity. At over 644 meters tall, it is the tallest building in Malaysia and the second tallest in the world, piercing clouds and redefining what is possible in urban vertical design. Its sleek, tapering form is inspired by the national motif of the hibiscus flower, blending cultural symbolism with cutting-edge engineering. Constructing a structure of this magnitude presented extraordinary challenges. Wind forces at extreme heights can twist and sway even the most rigid towers. So engineers designed a high-strength reinforced concrete core surrounded by an outer frame of steel and composite materials to provide stiffness and resilience. The foundation alone required thousands of piles driven deep into the ground. anchoring the tower securely on Malaysia's soft soil while mitigating the risk of settlement or tilting. The building's facade is equally impressive. Reflective glass and aluminum panels reduce heat gain in the tropical climate, while giving the tower a luminous, futuristic appearance. Inside, double-deck elevators travel at blistering speeds to service offices, observation decks, and luxury residences, while mechanical systems are meticulously engineered to handle the immense vertical distance and density of occupants. Merdeka 118 is more than a skyscraper. It is a vertical city, a triumph of design, construction, and ambition. Standing above Kuala Lumpur, it reminds the world that modern engineering can not only reach for the sky, but also embed cultural identity into the tallest structures on Earth. It is a testament to human ingenuity and the audacity to build where the limits of possibility meet the clouds. Towering over the turbulent waters of the Yenisei River, the Sayano-Shushenskaya Dam is a monument to human ambition and industrial scale. As the largest power plant in Russia and one of the most powerful hydroelectric facilities on Earth, it generates nearly 6,400 megawatts of electricity, enough to supply millions of homes across Siberia. Its sheer size and capacity are staggering. But what makes it truly remarkable is the extreme environment in which it was built. Located deep in the Siberian wilderness, engineers had to contend with icy temperatures, strong currents, and a remote location that made transporting materials and equipment a logistical nightmare. The dam itself is a gravity arch structure designed to redirect and contain the river's immense force while withstanding both seasonal flooding and seismic activity. Every cubic meter of concrete, every steel reinforcement, had to be precisely calculated to endure pressures that would crush lesser constructions. The facility's turbines and generators are feats of mechanical ingenuity, designed to operate under continuous load while remaining accessible for maintenance in one of the harshest climates on the planet. In 2009, a catastrophic accident caused massive flooding within the dam, highlighting the extreme risks associated with controlling such colossal natural forces and underscoring the ongoing vigilance required to maintain the structure safely. The Sayano-Shushenskaya Dam is more than a hydroelectric station. It is a demonstration of how engineering can harness the raw power of nature at scales almost beyond comprehension. Rising from a Siberian landscape, it embodies both the promise and peril of human ambition. A stark reminder that controlling nature demands respect, precision, and ingenuity. Rising like futuristic trees from the heart of Singapore's urban landscape, the Super Tree Grove, within the Gardens by the Bay, is more than a park. It is a bold experiment in merging nature with cutting-edge engineering. These towering vertical gardens, some reaching up to 50 meters in height, are designed to mimic the ecological functions of real trees, harnessing solar energy, collecting rainwater, and supporting a living skin of thousands of plants from around the world. Connected by the elevated OCBC Skyway, a suspended walkway winding through the tops of the super trees, visitors experience the city from an entirely new perspective. Constructing these massive structures required engineers to balance form with function. The steel frames had to support both the weight of the plants and the dynamic load of thousands of visitors, all while withstanding tropical storms and intense heat. Innovative irrigation systems and smart sensors ensure each vertical garden thrives, combining aesthetics with sustainability in a single seamless design. At night, the super trees transform into a spectacle of light and sound, creating a garden rhapsody that illuminates the park while showcasing Singapore's commitment to blending ecological consciousness with architectural daring. The sky park atop these structures is more than a vantage point. It is a symbol of what human creativity can achieve when imagination and engineering intersect. The Super Tree Grove proves that construction doesn't always have to defy gravity in the traditional sense. Sometimes, the most impressive engineering feats are those that elevate life itself. turning a park into a living, breathing, and glowing urban monument. Cutting across the Japanese landscape at speeds that once seemed impossible, the Shinkansen redefines what it means to move people efficiently and safely. First introduced in 1964, the Shinkansen was not just a train. It was a statement of technological ambition, linking cities at unprecedented velocities while maintaining an extraordinary record of safety and punctuality. Traveling over 300 kilometers per hour, it slices through mountains, rivers, and urban centers with a precision that leaves spectators in awe. Constructing this high-speed network required overcoming Japan's complex geography, prone to earthquakes, typhoons, and dense urban sprawl. Engineers developed earthquake-resistant tracks, elevated viaducts, and meticulously leveled tunnels to allow trains to glide smoothly even under extreme conditions. The trains themselves employ aerodynamic designs that minimize noise, reduce energy consumption, and ensure passenger comfort at velocities that would challenge ordinary rail vehicles. Beyond technology, the Shinkansen symbolizes Japan's vision of modernity and connectivity. Stations are carefully integrated into city planning, allowing seamless transitions between local transit and high-speed routes. Rising dramatically above the skyline of Macau, the Grand Lisboa is one of the most iconic and visually striking landmarks in the world of luxury and entertainment. A bold architectural statement that reflects both modern ambition and cultural symbolism. Completed in 2007, this towering structure reaches a height of 261 meters and is instantly recognizable for its unique lotus-inspired design, with a gleaming golden exterior that shimmers under the city lights, symbolizing prosperity and wealth in Chinese culture. Developed by the renowned gaming tycoon Stanley Ho, the Grand Lisboa is not just a hotel, but a centerpiece of Macau's global reputation as a leading destination for gaming, tourism, and high-end hospitality. Inside, the complex houses one of the most luxurious casinos in Asia, alongside a five-star hotel offering panoramic views of the city and several Michelin-starred restaurants that elevate it into a world-class culinary destination. The building's intricate facade, composed of reflective glass panels and steel, creates a constantly changing visual effect, making it appear almost alive as it reflects sunlight by day and glows brilliantly at night. Beyond its lavish interiors and entertainment offerings, the Grand Lisboa represents Macau's transformation into a modern global hub, where tradition and innovation intersect in a city that thrives on spectacle and ambition. It stands as a testament to bold design, economic growth, and cultural identity, embodying the spirit of a place where luxury, architecture, and entertainment come together to create an unforgettable experience that continues to captivate visitors from around the world. Perched high above one of the busiest districts in the world, Shibuya Sky offers a breathtaking perspective of Tokyo that transforms the city into a living, moving landscape of light, motion, and energy. Located atop the modern Shibuya Scramble Square in the heart of Tokyo, this open-air observation deck rises approximately 230 meters above ground, providing an uninterrupted 360-degree view that stretches from the dense urban maze of Shibuya Crossing to distant landmarks like Mount Fuji on clear days. Opened in 2019, Shibuya Sky was designed not just as a viewing platform, but as an immersive urban experience where architecture, technology, and atmosphere combine to create a sense of elevation beyond the physical. Visitors can walk freely across the rooftop space, feeling the wind and openness rarely experienced in a megacity, while carefully designed glass barriers maintain safety without obstructing the panoramic skyline. As day transitions into night, the experience becomes even more captivating, with Tokyo's endless sea of neon lights, moving traffic, and illuminated skyscrapers, creating a dynamic visual spectacle that feels almost cinematic. Beyond its views, Shibuya Sky reflects Japan's mastery of blending minimalism with innovation, offering a space that is both serene and exhilarating, where people can pause above the chaos below and take in the vast scale of one of the world's most advanced urban environments. It stands as more than an observation deck. It is a symbol of modern Tokyo itself, where design, technology, and human experience come together to create a moment of awe, perspective, and connection high above the city. Rising proudly above the skyline of New York City, Chrysler Building is more than an iconic skyscraper. It is a symbol of ambition, elegance, and the roaring spirit of the 1920s. Completed in 1930, it briefly held the title of the tallest building in the world, surpassing all expectations with its 319-meter spire that gleams in sunlight like polished metal. Its distinctive Art Deco design, with stainless steel cladding, terrace crown, and automotive-inspired gargoyles, celebrates both industrial progress and architectural artistry. Constructing the Chrysler Building was an engineering triumph. Built in an era without modern computer modeling, engineers and architects had to calculate weight distribution, wind loads, and structural integrity with remarkable precision. The steel frame supports a delicate facade of brick and metal, while the iconic spire was secretly assembled inside the building and then hoisted into place, a daring move that secured its status as the world's tallest structure at the time. Inside, the building was designed with both functionality and luxury in mind. Elevators, lighting, and office spaces were state-of-the-art for the era, while the interiors echoed the Art Deco style that made the skyscraper not just a workplace, but a work of art. Even today, the Chrysler Building continues to inspire awe for its combination of aesthetic vision and structural ingenuity, standing as a testament to a time when ambition reached for the sky, quite literally.
The Guangzhou CTF Finance Center rises like a sleek vertical needle above the Pearl River, immediately signaling modern ambition and architectural precision. Its glass and steel facade reflects sunlight by day and city lights by night, creating a shimmering icon within Guangzhou's rapidly evolving skyline. Standing at 530 meters with 111 floors, the tower accommodates offices, hotels, retail space, and observation decks. Its advanced structural design incorporates tuned mass dampers and high-performance materials to resist wind and seismic forces, while ultra-fast elevators transport occupants smoothly through the building's vertical cityscape. Completed in 2016, the project exemplifies a fusion of engineering innovation and urban planning. The tower's integration into Guangzhou's central business district reflects strategic intent to concentrate commerce, finance, and hospitality within a single landmark, reinforcing the city's position as a global economic hub. From observation platforms and panoramic interiors, visitors feel both awe and perspective, suspended above the urban expanse while witnessing human ingenuity transform concrete, steel, and glass into a monument of ambition, connectivity, and modern design.
The headquarters of Country Garden, one of China's largest and most influential property development companies, stands as a symbol of ambition, innovation, and the country's rapid urban transformation. Headquartered in Shunde, Guangdong Province, this hub serves as the strategic heart of an enterprise that has grown from a regional developer into a global real estate powerhouse since its founding in 1992, now ranking among the Fortune Global 500. The headquarters is more than an administrative center. It is a focal point where vision, planning, and execution converge to shape entire urban landscapes. guiding the creation of township-scale residential complexes, commercial centers, and mixed-use developments across China and abroad. Designed to reflect both corporate prestige and operational efficiency, the complex embodies modern architectural principles while supporting cutting-edge technology, sustainable practices, and large-scale project management, ensuring that innovation drives every decision. Every department within the headquarters, from design and engineering to finance, marketing, and international expansion, is integrated to maintain precision, speed, and coordination across thousands of ongoing projects. Beyond its functional role, the Country Garden headquarters stands as a testament to the transformative power of vision and scale in modern China, representing how strategic planning, architectural excellence, and human ambition come together to build not just structures, but entire communities, shaping the lives of millions and leaving a lasting imprint on the urban fabric of one of the world's fastest-growing nations. Soaring above the skyline of Shanghai, the Shanghai Tower is not only the tallest building in China, but also the second tallest in the world, reaching a staggering height of 632 meters with 128 stories of mixed-use space that includes offices, hotels, retail, and observation decks, making it a symbol of modern urban ambition and engineering excellence. Completed in 2015 after 8 years of construction, Shanghai Tower is a marvel of design, featuring a unique twisting form that reduces wind loads by 24%, enhances energy efficiency, and gives the skyscraper its iconic spiraling silhouette, reflecting both cutting-edge engineering and aesthetic innovation. Designed by Gensler in collaboration with Chinese engineering firms, the tower incorporates multiple sustainable technologies, including double-layered glass facades for temperature control, rainwater collection, and state-of-the-art HVAC systems, making it one of the world's most advanced green skyscrapers. Beyond its structural feats, the tower serves as a hub for business, tourism, and leisure, connecting seamlessly with the sprawling Lujiazui Financial District while offering visitors panoramic views of the Huangpu River, the Bund, and the entire metropolis from its observation decks. With high-speed elevators that whisk visitors to the top in under a minute, Shanghai Tower embodies China's rapid urban growth, technological innovation, and visionary ambition, standing as a monument to what human creativity, precision, and determination can achieve when pushed to the limits in pursuit of architectural and engineering greatness. Rising from the waterfront of Singapore, Gardens by the Bay is a breathtaking fusion of nature, technology, and visionary design, redefining what a modern urban garden can be on a global scale. Spanning over 100 hectares of reclaimed land, this iconic destination was officially opened in 2012 as part of Singapore's ambition to become a city in a garden, blending environmental sustainability with architectural innovation. At the heart of the gardens stand the towering super trees, vertical gardens ranging from 25 to 50 meters tall, that function not only as striking visual landmarks, but also as environmental engines, harnessing solar energy, collecting rainwater, and supporting diverse plant life from around the world. Inside the massive climate-controlled conservatories, including the Flower Dome and Cloud Forest, visitors are transported into entirely different ecosystems, from Mediterranean climates to mist-filled tropical highlands complete with one of the world's tallest indoor waterfalls. Every element of the park is designed with sustainability in mind, integrating energy-efficient systems, water recycling, and cutting-edge environmental engineering to create a space that is both beautiful and ecologically responsible. As day turns to night, the gardens transform into a glowing spectacle, with the super trees illuminated in synchronized light and sound shows that create a magical, almost otherworldly atmosphere. More than just a park, Gardens by the Bay represents a bold vision of the future, where urban development and nature coexist in harmony, serving as a global model for sustainable city planning while offering millions of visitors an unforgettable experience that blends science, art, and the natural world into one extraordinary landscape. Rising from its own artificial island like a sail frozen in motion, the Burj Al Arab stands as one of the most daring symbols of modern engineering and architectural ambition. Positioned just off the coast of Dubai, this structure was never meant to simply exist on land. From the very beginning, it challenged geography itself by being built where no natural foundation was available. Instead of solid ground, engineers faced loose, shifting seabed sand. To make construction possible, hundreds of massive concrete piles were driven deep into the seabed, relying on friction rather than bedrock for stability. This approach demanded precise calculations, because even small errors could have led to uneven settlement or long-term structural instability. The artificial island beneath the tower acts as both a foundation and a buffer, absorbing wave energy from the Arabian Gulf. The building's iconic sail-shaped form is not just a visual statement. Its exterior skin is made from a lightweight, Teflon-coated fiberglass fabric stretched over a steel framework. This material choice reduces wind pressure on the structure while reflecting intense sunlight, an essential adaptation in Dubai's extreme climate. At night, the same surface becomes a glowing canvas, transforming the tower into a landmark visible for kilometers. Inside, the Burj Al Arab emphasizes vertical scale and theatrical space. The central atrium rises dramatically through most of the building's height, creating an interior volume rarely attempted in hospitality architecture. Every accommodation is a duplex suite, reinforcing the building's identity as a symbol of exclusivity rather than efficiency. Even features like the rooftop helipad serve dual purposes, functioning both as infrastructure and as global media spectacle. Yet beneath the luxury lies constant engineering tension. Salt-laden air accelerates corrosion. High humidity stresses materials, and extreme temperature swings cause continual expansion and contraction. Unlike inland skyscrapers, coastal structures require relentless monitoring and maintenance to remain safe and functional. The Burj Al Arab's elegance is therefore sustained not by permanence, but by continuous human intervention. This is what makes the structure truly extraordinary. The Burj Al Arab is not simply a hotel built on water. It is a demonstration of how modern engineering can manufacture stability, prestige, and permanence in an environment that naturally resists all three. Clinging to a sheer cliff face inside the towering sandstone pillars of Zhangjiajie National Forest Park, a transparent structure rises like something from science fiction. This is the Bailong Elevator, the 100 Dragons Elevator, a vertical transport system built where nature never intended machinery to exist. Completed in 2002, it holds the title of the world's tallest outdoor glass elevator, climbing roughly 326 meters along the face of a quartz sandstone cliff. Instead of a winding mountain trek that once took hours, visitors now ascend in under 2 minutes, suspended between sky and rock with nothing but glass separating them from the abyss. Engineering here wasn't about height alone, it was about survival against terrain. Massive steel anchors were drilled deep into the cliff to stabilize the structure, while vibration and load distribution had to be carefully managed to protect both passengers and the fragile geological formations surrounding it. The elevator operates in 3 double-deck cabins, capable of carrying thousands of passengers per hour, a logistical necessity in one of China's busiest scenic parks. Designers had to account for high winds, humidity, temperature shifts, and the seismic sensitivity of the region, all while ensuring the structure blended visually into a protected natural landscape. But beyond engineering numbers, the experience defines it. As the cabin glides upward, forests shrink beneath your feet and stone towers rise around you. A perspective that transforms transportation into spectacle. The Bailong elevator isn't just infrastructure. It's humanity inserting precision engineering into a vertical wilderness, redefining access to landscapes once reserved only for the most determined climbers. Suspended high above a roaring river in the Himalayan foothills, the Gasa hanging bridge sways gently in the mountain wind, a narrow lifeline connecting isolated communities in one of the world's most rugged landscapes. Stretching across a deep gorge near the village of Gasa, this slender suspension bridge appears almost fragile against the vastness of the surrounding cliffs. Steel cables hold it in place, but as you step onto its wooden planks, every movement sends a ripple through the structure, reminding you just how exposed you are. Below, a powerful river rushes through the canyon, its echoing against the rock walls, while above, the towering peaks of the Himalayas rise into the clouds. The bridge becomes a thin line between two worlds, solid ground behind you, uncertainty ahead. For locals, this isn't an adventure, it's a necessity. Every day, people cross with livestock, supplies, and goods, balancing carefully as the bridge sways beneath their feet. What feels like a test of courage to visitors is simply part of life here, where geography demands resilience. Crossing it is an experience you don't forget. The wind grows stronger in the middle span, the valley opens beneath you, and the sense of height becomes impossible to ignore. Each step requires focus. Each glance downward reminds you of the distance to the river far below. And yet, there's beauty in the danger. Prayer flags flutter along the cables, adding color and movement to the stark mountain scenery, while the air carries the crisp chill of high altitude. It's a place where nature, culture, and survival meet in a delicate balance. The Gasa Hanging Bridge is more than a crossing. It's a symbol of human adaptation, a simple structure built in a place where nothing is easy, yet essential for life to continue in the shadows of the Himalayas. Carved into the raw, unforgiving mountains of northeastern Turkey, the Baybird Road twists through the highlands like a dangerous thread between sky and stone. Remote, narrow, and relentlessly steep, it stands as one of the region's most challenging routes, where every turn demands precision, and every mistake carries consequences. Winding through the rugged landscapes of Baybird, the road climbs into elevations where weather changes without warning. One moment, clear skies stretch across the horizon. Next, thick fog rolls in, swallowing visibility and turning the path ahead into uncertainty. Unlike modern highways built for speed and comfort, this road remains raw and exposed. Sharp hairpin bends cling to cliffs with little margin for error. Guardrails are minimal, and the drop-offs are unforgiving, plunging into deep valleys carved by centuries of wind and water. Driving here is not just a journey. It's a test of control and awareness. Tires grip loose gravel, engines strain on steep inclines, and every curve feels like a negotiation with gravity itself. In winter, snow and ice transform the road into a frozen challenge, where even experienced drivers must move with extreme caution. Yet despite its danger, the Baybird Road holds a quiet, almost haunting beauty. Rolling hills stretch into the distance, untouched and silent, while the vast sky above creates a sense of isolation rarely found in the modern world. For those who dare to cross it, the reward is not just reaching the other side. It's experiencing a place where nature still dominates, where human engineering adapts rather than conquers, and where every kilometer tells a story of risk, resilience, and survival. Carved into the towering limestone mountains of northern Vietnam, the Ma Pai Lung Pass winds like a fragile ribbon along the edge of the sky. Perched high above deep valleys and sheer cliffs, it is not just a road. It's a breathtaking confrontation between human determination and raw nature. Located in the remote province of Ha Giang, this legendary pass forms part of the Ha Giang Loop, a route known for its extreme beauty and equally extreme. The road clings to the mountainside, often with nothing but open air separating travelers from the abyss below. Far beneath the cliffs, the emerald waters of the No K River carve their way through the canyon, creating one of the most dramatic landscapes in all of Southeast Asia. From above, the river appears calm and distant, but the height reminds you just how exposed you truly are. Built in the 1960s by thousands of workers using mostly hand tools, the road stands as a testament to human endurance. For years, laborers carved through solid rock, suspended on ropes, facing constant danger to create a path through terrain that once seemed impossible to cross. Driving along Ma Pai Lung is both awe-inspiring and intense. The curves are sharp, the cliffs unforgiving, and the changing weather adds another layer of unpredictability. Mist can roll in within minutes, turning a clear view into a wall of white, where the road disappears into uncertainty. And yet, there's a strange calm in the danger. Wind moves softly through the mountains, clouds drift at eye level, and the silence of the highlands creates a feeling of isolation rarely found in the modern world. Ma Pai Lung Pass is more than a road. It's a journey through extremes, a place where beauty and danger exist side by side, and where every turn reminds you just how small you are in the face of nature's vast power. There are places on this planet where logic should say stop, where wind tears at steel, oceans swallow foundations, and gravity itself feels like an enemy. Yet humanity doesn't step back, it builds. Across deserts, oceans, frozen tundras, and crowded megacities, colossal structures rise where survival alone is difficult, let alone construction. These aren't ordinary buildings or bridges. They are experiments pushed to the edge of physics, projects so complex and risky that even seasoned engineers pause in disbelief. Some stretch across miles of open water. Some pierce the sky beyond the clouds. Others harness forces powerful enough to reshape landscapes or control entire rivers. Today, you're not just watching architecture. You're witnessing ambition at its most extreme. Join us as we explore impossible mega-projects, the most dangerous constructions on Earth, and uncover how human ingenuity turns the unbuildable into reality. Suspended high above the forests of the Czech Republic, the Sky Bridge 721 is not just a crossing. It is an adrenaline-fueled experience that challenges both perception and engineering. Stretching an astonishing 721 meters, it claims the title of the longest pedestrian suspension bridge in the world, hovering over deep valleys and rolling hills where even the strongest gusts can make the structure sway. Constructing a bridge of this scale required meticulous planning. Engineers had to balance extreme length with minimal weight. ensuring the steel cables, tension anchors, and deck could withstand not only the weight of visitors, but also the relentless wind currents that sweep through the mountains. The bridge is anchored into solid rock, but even so, its slight movement is intentional, creating a sensation of walking on air while maintaining structural integrity. Access points are carefully integrated with the surrounding landscape, allowing hikers and thrill seekers to ascend safely to the suspension start. The deck itself combines lightweight materials with reinforced steel to provide stability without sacrificing transparency or the feeling of openness. At night, subtle lighting transforms the bridge into a glowing ribbon across the valley, highlighting its engineering brilliance and the natural beauty below. Sky Bridge 721 is more than a walkway. It is a daring statement of human creativity and precision. It turns what could be an ordinary observation into a visceral encounter with height, wind, and perspective. A reminder that the most breathtaking constructions often exist at the edge of fear and engineering mastery. Perched on the edge of Norway's Geirangerfjord, the wave, Bolgen, rises like a frozen tidal wave, daring gravity to defy it. This residential structure is as dramatic as the natural landscape around it, its sweeping, undulating facade mirroring the fjord's glacial curves while testing the limits of modern architecture. Every floor follows a precise curvature, creating apartments with spectacular views, but challenging engineers with complex load distribution and cantilevered sections that extend over the cliffside. Construction required meticulous planning and innovative engineering. Reinforced concrete and high-strength steel were used to support the building's overhanging forms, while each apartment had to be aligned perfectly to maintain both structural integrity and the intended aesthetic. The site itself presented additional hazards: steep slopes, potential landslides, and harsh Nordic weather, which meant that foundation work and material handling had to account for both safety and long-term durability. But the wave is more than an engineering challenge. It is a marriage of nature and human creativity. Its design transforms a residential complex into a sculptural landmark, proving that functional living spaces can also be monumental works of art. Walking along its terraces, one cannot help but feel the tension between permanence and the raw, dynamic forces of nature surrounding it. The wave, Bolgen, is a statement that architecture can do more than occupy space. It can mimic nature, challenge expectations, and transform the edge of a fjord into a symbol of audacious human vision. Stretching gracefully across the Gardon River in southern France, the Pont du Gard stands as a testament to the ingenuity of ancient engineers. Built nearly 2,000 years ago by the Romans, this three-tiered stone aqueduct was designed to carry water over 50 kilometers from springs near Uzes to the city of Nîmes, supplying a growing population with a reliable source of life. Its elegance is matched only by its precision. The gradient is so slight, roughly 34 centimeters per kilometer, that water flowed steadily without modern pumps. Constructing Pont du Gard demanded mastery of geometry, materials, and human labor. Massive limestone blocks were quarried and carefully shaped, then lifted into place without the aid of cranes or machinery. Each arch had to distribute weight evenly, allowing the structure to withstand both the river's seasonal floods and the centuries of erosion that would eventually challenge it. The engineers' understanding of load, tension, and balance ensured the aqueduct could endure in a landscape prone to shifting soils and heavy rainfall. Beyond its function, Pont du Gard is a cultural and architectural marvel. Its harmonious proportions and monumental scale convey not only utility, but also the Romans' vision of permanence and civic pride. Walking across it today, visitors experience both the engineering genius of antiquity and the aesthetic sophistication that made the aqueduct more than a conduit. It became a symbol of civilization itself. Pont du Gard proves that some of humanity's most impressive constructions are not only about power or height, but about precision, foresight, and the ability to turn necessity into enduring beauty. Rising along the Reykjavik waterfront, the Harpa Concert Hall is a stunning fusion of art, architecture, and engineering. Its crystalline facade, composed of hundreds of geometric glass panels, reflects sunlight in a northern sky, creating a kaleidoscope of colors that changes with every hour and weather condition. The building was designed not only to host world-class performances, but also to integrate seamlessly with Iceland's dramatic natural environment, blending the urban shoreline with the volcanic landscape beyond. Constructing Harpa demanded precision and innovation. The unique glass panels were custom engineered, requiring exact calculations for thermal expansion, wind loads, and light refraction. Behind the seemingly delicate exterior lies a robust steel frame capable of supporting multiple performance halls and exhibition spaces, while withstanding Reykjavik's harsh coastal winds and cold temperatures. The building also incorporates advanced acoustic engineering, ensuring that each concert, from symphony to contemporary performance, reaches audiences with perfect clarity and resonance. Harpa is more than a functional space. It is a living piece of art. At night, the facade illuminates with dynamic LED displays, turning the hall into a glowing beacon visible across the harbor. The combination of structural ingenuity, aesthetic brilliance, and cultural purpose makes it a landmark that embodies Iceland's commitment to creativity, innovation, and the fusion of human artistry with environmental context. Reaching skyward with ambitions that stretch beyond Earth itself, the Starship is not just a rocket. It is humanity's next step toward interplanetary travel. Designed by SpaceX, Starship aims to carry dozens of passengers and tons of cargo to destinations ranging from low Earth orbit to Mars. Standing at 120 meters tall, when stacked with its booster, it dwarfs nearly every rocket that came before, a gleaming symbol of audacious engineering and technological innovation. Building Starship presented challenges unlike any conventional construction project. The stainless steel exterior must withstand extreme temperatures during atmospheric reentry, while the rocket's engines generate immense thrust that test the limits of material strength and precision engineering. Every weld, every plate, every joint is engineered to tolerate repeated launches and landings, transforming what was once disposable aerospace hardware into a reusable spacecraft capable of multiple missions. Rising dramatically above the historic skyline of St. Petersburg, Lochta Center. The Lochta Center is not just the tallest building in Russia. At 462 meters, it is the tallest in all of Europe, but a towering testament to human ambition and engineering mastery. From afar, its twisting spire appears to spiral into the heavens, a frozen flame of steel and glass reflecting the shifting northern light. The sleek, aerodynamic design is not purely for visual drama. It is a carefully calculated solution to reduce wind pressure on the tower, ensuring stability against fierce gusts and extreme weather, necessity in the Gulf of Finland's harsh climate. Each pane of its ultra-clear glass facade was meticulously engineered to balance transparency, thermal efficiency, and resilience against ice and snow, creating a shimmering exterior that both complements and dominates the surrounding cityscape. Constructing the Lochta Center was a feat of ingenuity that challenged the boundaries of modern engineering. The tower rests on a complex foundation of deep piles driven into soft and uneven soils near the bay, with precise load distribution to prevent long-term settlement. The reinforced concrete core, coupled with a high-strength steel frame, supports the twisting structure while allowing it to sway slightly under wind stress. A subtle movement designed to prevent damage rather than compromise stability. High-speed elevators, intelligent HVAC systems, and advanced safety mechanisms transform the skyscraper into a self-contained vertical city, with office spaces, observation decks, and public areas integrated seamlessly into one structure. The tower's spiral form is more than aesthetic elegance. It is an engineering strategy. By gradually rotating as it ascends, the design reduces wind vortex effects that could otherwise exert immense lateral forces, allowing the Loch Center to stand tall and unshaken where a conventional vertical tower might falter. At night, the spire glows like a beacon, visible from kilometers away, turning the building into a landmark and a symbol of St. Petersburg's modern era while paying homage to its rich architectural heritage. Loch Center is not just a skyscraper. It is a bold statement about human capability. It demonstrates how careful planning, innovative materials, and visionary design can overcome environmental and geological challenges to create a structure that is simultaneously functional, sustainable, and visually stunning. Standing beneath its soaring spire, visitors and engineers alike feel both awe and inspiration, reminded that with ambition, precision, and creativity, humanity can reach heights that were once unimaginable, crafting a marvel that will dominate the skyline for generations to come. Rising in the heart of the Guangdong Kongmacao Greater Bay Area on Hengqin Island, Chimelong Ocean Kingdom stands as one of the world's most ambitious and immersive ocean-themed entertainment destinations, a flagship park developed by the Chimelong Group that has continually pushed the boundaries of what a marine adventure experience can be since it opened in March 2014. As part of the larger Chimelong International Ocean Resort, the park integrates rare marine animal exhibits, cutting-edge amusement technology, themed entertainment, and sweeping educational experiences under one monumental umbrella, earning international recognition with multiple awards from the Themed Entertainment Association and setting several world records for its marine displays. Chimelong Ocean Kingdom is divided into 8 themed zones that transport visitors from dolphin sanctuaries and rainforest-inspired realms to polar habitats and high-thrill adventure areas, with one of its most iconic features being the record-breaking Ocean Wonders Aquarium, home to whale sharks, manta rays, and tens of thousands of fish visible through the world's largest acrylic viewing panels. Features that have become global benchmarks in aquarium design. Alongside its animal encounters, the park delivers an array of experiences from thrilling coasters like the Parrot Coaster, the first wing coaster in Asia, to immersive 5D castle cinema shows, spectacular parades, and nighttime firework and light spectaculars that draw millions of visitors each year and make the park an essential stop on China's tourism map, beyond entertainment. Ocean Kingdom also plays a growing role in marine conservation education, fostering awareness of ocean ecosystems and species protection while blending spectacle with science, imagination, and jaw-dropping scale. Stretching across the southwestern coast of the Netherlands, the Delta Works stands as one of the most monumental achievements in human engineering and climate adaptation ever realized. Born from necessity, shaped by tragedy, and perfected through decades of innovation to protect a nation where nearly 1/3 of the land lies below sea level. The story of the Delta Works begins with the catastrophic North Sea flood of 1953, a devastating storm surge that struck on the night of January 31st. And February 1st, breaching dikes across Zeeland, South Holland, and North Brabant, killing more than 1,800 people, destroying entire villages, and exposing the vulnerability of a people long accustomed to living in the shadow of water. In the aftermath, the Dutch government made a historic decision not merely to rebuild what was lost, but to rethink the very relationship between land and sea, launching what would become the Delta Works in 1958, a comprehensive system of dams, storm surge barriers, locks, levees, and floodgates engineered to control the water of the North Sea itself rather than simply resisting it. At its core is the Oosterscheldekering, a 9-kilometer movable storm surge barrier made of massive steel gates that can be lowered during extreme high tides and storms to block destructive waves, yet remain open under normal conditions to preserve tidal flow and marine ecosystems, embodying a philosophy of coexistence with nature rather than domination. Around the Oosterscheldekering, other monumental structures, including the Haringvlietdam, Hesterback, and Grevelingen Dam, work in concert to shorten the length of coastline exposed to the sea, regulate water levels in estuarine environments, and protect fertile agricultural lands, urban centers, and critical infrastructure that together support millions of lives and billions in economic activity. The engineering challenges were immense. Designers and builders had to invent new techniques for underwater construction, advanced hydraulic modeling, and materials capable of withstanding some of the world's strongest tidal forces, while planners worked to balance safety with environmental stewardship so that wetlands, fisheries, and natural habitats could survive and even thrive under a managed system of water control. As each phase was completed over the following decades, the Delta Works reduced the risk of flooding to levels previously unimaginable and became a living laboratory for climate resilience, with continuous monitoring, upgrades, and innovations that adapt the system to rising sea levels and changing weather patterns driven by global climate change. Beyond its technical achievements, the Delta Works represents a cultural ethos in the Netherlands. Water is not merely an external threat, but an ever-present partner in daily life, shaping agriculture, transportation, urban planning, and even leisure. And the nation's approach to water management has inspired flood defense projects on every continent as countries grapple with similar challenges. Today, the Delta Works stands not only as a safeguard for Dutch lives and livelihoods, but also as an educational and research landmark, drawing engineers, policymakers, and environmental scientists from around the world to study its design, operations, and integrated approach to risk management. In every sense, the Delta Works is more than a series of physical barriers. It is a testament to human resolve in the face of natural forces, a symbol of collective will shaped by history and driven by the need to protect future generations, and a powerful reminder that with vision, collaboration, and innovation, even the most daunting challenges posed by nature can be met with solutions that endure, evolve, and inspire. Clinging to a sheer cliff face inside the towering sandstone pillars of Zhangjiajie National Forest Park, a transparent structure rises like something from science fiction. This is the Bailong Elevator, the 100 Dragons Elevator, a vertical transport system built where nature never intended machinery to exist. Completed in 2002, it holds the title of the world's tallest outdoor glass elevator, climbing roughly 326 meters along the face of a quartz sandstone cliff. Instead of a winding mountain trek that once took hours, visitors now ascend in under 2 minutes, suspended between sky and rock with nothing but glass separating them from the abyss. Engineering here wasn't about height alone, it was about survival against terrain. Massive steel anchors were drilled deep into the cliff to stabilize the structure, while vibration and load distribution had to be carefully managed to protect both passengers and the fragile geological formations surrounding it. The elevator operates in 3 double-deck cabins, capable of carrying thousands of passengers per hour, a logistical necessity in one of China's busiest scenic parks. Designers had to account for high winds, humidity, temperature shifts, and the seismic sensitivity of the region, all while ensuring the structure blended visually into a protected natural landscape. But beyond engineering numbers, the experience defines it. As the cabin glides upward, forests shrink beneath your feet and stone towers rise around you, a perspective that transforms transportation into spectacle. The Bailong Elevator isn't just infrastructure. It's humanity inserting precision engineering into a vertical wilderness, redefining access to landscapes once reserved only for the most determined climbers.
places on Earth where logic should have drawn the line, where gravity, terrain, and risk said stop, and yet humans built there anyway. We're talking about structures hanging over abyss-deep valleys, carved into mountains that constantly move, or holding back forces powerful enough to reshape continents. Projects so extreme that a few centimeters of error could mean catastrophe. And sometimes nearly did it. These aren't just impressive buildings. They are calculated gambles with physics, tests of ambition, proof that engineering often walks a razor's edge between brilliance and disaster. In the next few minutes, you'll see constructions pushed into locations most people wouldn't even dare to stand, let alone build on. Some solved impossible problems. Others rewrote what we thought was achievable. So stay with me, because by the end of this journey, you may look at the modern world very differently. Let's begin.
Spanning the entrance to San Francisco Bay, the Golden Gate Bridge is not merely an iconic landmark, but one of the most ambitious engineering feats of the 20th century, a symbol of human ingenuity, perseverance, and the relentless drive to connect communities across formidable natural obstacles. When it opened in 1937, the bridge transformed the relationship between San Francisco and Marin County, replacing the time-consuming ferry crossings with a sweeping 2.7-kilometer, 1.7-mile span that quickly became essential for commerce, daily life, and tourism, while also earning its place as one of the most photographed and recognized structures in the world. Its distinctive international orange color was carefully chosen not just for aesthetics, but for visibility in the frequent fog that shrouds the Golden Gate Strait, a narrow channel known for powerful currents, deep waters, and strong winds, which made the bridge's construction uniquely challenging. Designed by Chief Engineer Joseph Strauss, along with contributions from visionary engineers such as Leon Moisseiff and Charles Ellis, the bridge pioneered techniques in suspension bridge design, using massive cables composed of tens of thousands of steel wires and enormous anchorages to hold the roadway high above turbulent waters, while allowing the structure to flex and sway safely with wind and seismic activity. The construction itself was an extraordinary feat of human courage and coordination, involving thousands of workers who risked extreme heights, treacherous winds, and cold, foggy conditions. Despite these dangers, innovative safety measures, including the first use of a movable safety net, saved the lives of many workers and set new standards for industrial safety at the time. Beyond its technical and aesthetic achievements, the Golden Gate Bridge has become a cultural icon, representing both the ambition of the American West and the human capacity to overcome natural barriers, inspiring artists, filmmakers, and engineers worldwide, while drawing millions of visitors annually who walk, bike, and drive across its majestic span. Over the decades, the bridge has undergone continuous maintenance, retrofitting, and seismic strengthening to ensure that it withstands the test of time, earthquakes, and relentless environmental conditions, demonstrating an ongoing commitment to innovation and preservation. From dawn until dusk, the interplay of fog, sunlight, and the bridge's striking silhouette creates a dramatic and ever-changing visual experience that has cemented its place in the global imagination, a blend of utility, beauty, and engineering brilliance that continues to connect not only land and water, but also history, culture, and human aspiration. The Golden Gate Bridge stands as a testament to vision, resilience, and the power of collaboration, a living monument where architecture, nature, and human determination converge, reminding the world that even the most imposing obstacles can be transformed into symbols of unity, progress, and enduring inspiration.
In the heart of Bangkok's jungle of skyscrapers, stands a tower that looks like the city itself, glitching into 3 dimensions. This is MaxKoMusic, a structure so striking that at first glance it feels less like a building and more like a digital fragment frozen in steel and glass. At approximately 314 meters tall with 77 floors, MaxKoMusic was the tallest building in Thailand when it opened in 2016, piercing the skyline and redefining what a tower could look like in Southeast Asia. But its height isn't what makes it unforgettable. It's the facade. Instead of clean vertical planes, the tower side appears to have been carved with a swirling ribbon of staggered cubes that seem to peel away from the building's core. The effect is so unusual that from certain angles, it looks like a massive slice of the city was scooped out by some invisible force. That pixelated band isn't merely ornamental. It creates cantilevered terraces, skyboxes, and panoramic glass balconies, offering views both exhilarating and vertigo-inducing, while breaking wind loads and redistributing weight in ways no traditional tower ever attempted. Inside the structure, luxury meets engineering, upscale residences, high-end retail, and 2 premium hotels fill its floors, while a skywalk observation deck perched near the top gives visitors a 360-degree panorama of Bangkok's sprawling metropolis below. The Three Gorges Dam stretches across the Yangtze River with commanding presence, immediately conveying monumental scale and human ambition as mountains and water merge with engineering mastery. Its massive concrete walls and stepped spillways rise against the river's flow, creating a landscape transformed by design and determination. Spanning over 2 kilometers and standing more than 180 meters tall, the dam integrates hydroelectric turbines, navigational locks, and flood control systems, forming the world's largest power-generating facility by installed capacity. Each component reflects advanced structural engineering, precise calculations, and decades of coordinated construction efforts, completed in the early 21st century. The project reshaped the region's geography, enabling renewable energy production, controlling seasonal floods, and improving navigation for inland shipping. At the same time, it required large-scale relocation of communities and careful management of ecological impact, demonstrating the complex balance between human progress and environmental stewardship. Standing on observation platforms above the surging waters, visitors feel both awe and introspection, sensing the immense power of flowing rivers harnessed by human ingenuity, and understanding how engineering can transform nature while leaving an indelible mark on civilization.
Perched high above the city of Cusco in Peru, Sacsayhuaman is a fortress that continues to baffle historians and engineers alike. Constructed by the Inca around the 15th century, its massive stone walls are made of gigantic, irregularly shaped blocks, some weighing over 100 tons, perfectly fitted together without mortar. The precision of the stonework is so exact that even a razor blade cannot be inserted between the stones, a testament to the extraordinary skill and ingenuity of Inca engineers. Moving and assembling these monolithic stones on the steep hillsides of the Andes posed immense challenges. There are no cranes, no pulleys, no modern machinery, only ingenuity, manpower, and a deep understanding of leverage and geometry. The walls are designed to resist seismic activity, a necessity in this earthquake-prone region, with slightly inclined blocks and interlocking stones that allow the fortress to absorb shocks rather than crumble under them. Sacsayhuaman is more than a military structure. It is a symbol of Inca mastery over both material and terrain. Its terraces, ramparts, and ceremonial platforms demonstrate an understanding of space, defense, and aesthetics rarely seen in ancient construction. Standing among the massive stones today, visitors can sense the ingenuity, planning, and ambition that allowed a civilization to create something both functional and awe-inspiring. enduring for centuries despite the harsh mountain environment. The Yashi Expressway, stretching about 240 kilometers through the rugged mountains of southwestern Sichuan province, is a masterpiece of modern civil engineering that challenges both gravity and geography as it climbs from the basin at Yun toward Xichang like a sky-high ribbon through the clouds, earning it nicknames such as the ladder-like Sky Road for its remarkable ascent and sweeping route through the Hengduan mountain range. This crucial section of the Beijing-Kunming Expressway was built over 5 years with an investment of roughly 20.6 billion yuan, overcoming extraordinary natural obstacles such as steep gradients, seismic zones, and complex geological hazards, from gas and water intrusions to rock bursts, and incorporating more than 270 viaducts and 25 tunnels that together dramatically shorten travel times and improve regional connectivity. With an average climb of about 7.5 meters per kilometer, the road not only supports efficient transport between southern and northern China, but also fosters economic development in previously isolated areas, linking ethnic and rural communities and facilitating tourism through breathtaking mountain landscapes that range from terraced rice fields and thermal springs to ancient forests and river valleys. Its innovative design, which minimizes environmental impact through spiral tunnels and strategic routing, reflects China's broader ambition to build infrastructure that adapts to nature rather than dominates it, setting new standards for high-altitude expressway construction while symbolizing how ambitious engineering can reshape a region's economic prospects, social integration, and access to opportunity. Built in the heart of the futuristic smart city of Songdo Central Park is a striking example of how urban design, technology, and nature can merge into a single, visionary landscape. Spanning over 100 acres and inspired by iconic green spaces like Central Park while reimagining them for the 21st century. Unlike traditional parks, this space is seamlessly integrated into a fully planned international business district, where glass skyscrapers, advanced infrastructure, and eco-friendly systems surround a carefully engineered natural environment that includes seawater canals, walking trails, open lawns, and lush gardens. One of its most unique features is the man-made canal system that brings seawater directly into the park, allowing visitors to experience water taxis, kayaking, and scenic boat rides right in the middle of a modern city, creating a rare balance between urban life and natural relaxation. Beyond its beauty, the park is also a symbol of sustainability, designed with green technologies such as efficient irrigation, energy-conscious lighting, and environmentally sensitive landscaping that reduce its ecological footprint while enhancing livability. It serves not only as a recreational space, but also as a social and cultural hub, hosting events, festivals, and daily activities that bring together residents, business professionals, and tourists alike. Songdo Central Park reflects a broader vision of future cities, where smart infrastructure, environmental responsibility, and human-centered design coexist in harmony, and stands as a powerful example of how cities can evolve beyond concrete and steel into spaces that prioritize both innovation and quality of life, redefining what it means to live, work, and connect in a modern urban environment. Rising along the shores of the Caspian Sea in Baku Crystal Hall stands as a dazzling symbol of modern architecture and national ambition, a venue that transformed Azerbaijan's global image almost overnight when it was constructed in just 8 months to host the Eurovision Song Contest 2012. With a seating capacity of around 25,000 spectators, the arena was designed not just as a performance space, but as a visual spectacle, featuring a crystalline, faceted exterior that comes alive at night through a sophisticated LED lighting system capable of displaying dynamic colors and patterns across its entire surface. This striking design gives the building its iconic identity, making it appear like a glowing jewel on the waterfront, visible from miles away and instantly recognizable on the global stage. Beyond its rapid construction and bold aesthetics, Baku Crystal Hall represents a fusion of engineering, efficiency, and cultural expression, combining large-scale structural design with advanced acoustics and event technology to host concerts, international competitions, and major sporting events. Inside, the vast interior is engineered for flexibility, allowing the space to transform seamlessly between different types of performances, from high-energy music shows to large-scale ceremonies, all while maintaining an immersive experience for audiences. More than just an arena, Baku Crystal Hall reflects Azerbaijan's desire to position itself as a modern, forward-looking nation, using architecture as a tool to showcase innovation, creativity, and global connectivity. It stands as a testament to what can be achieved when vision meets urgency, where design, technology, and ambition converge to create a landmark that is not only functional, but also symbolic, capturing the spirit of a country eager to make its mark on the world stage. Rising majestically over the mighty Yangtze River in Wuhan, Hubei Province, the Yangtze Suspension Bridge is a groundbreaking achievement in modern bridge engineering that redefines scale, capacity, and connectivity in China and the world. Opened to traffic on October 8, 2019 after 4 years of intensive construction. This double-deck suspension bridge spans approximately 1,700 meters between its main towers, making it the longest-spanning double-deck suspension bridge on Earth and one of the longest suspension spans overall, while its total length reaches about 4.13 kilometers as it links the Hanyang and Wuchang districts across one of Asia's most vital waterways. Designed to carry heavy traffic with 12 lanes of roadway split between upper and lower decks, the bridge also accommodates pedestrians, cycling paths, and non-motorized vehicles, balancing colossal transport capacity with public access and leisure use. Beyond its sheer size, the Yangtze Suspension Bridge symbolizes a new era of infrastructure integration, easing regional congestion, improving connectivity across Wuhan's urban core, and promoting more balanced economic growth in one of China's fastest developing metropolitan areas. Its record-setting engineering reflects both technical innovation and the ambition driving China's modern megaprojects, where functionality and landmark status converge in structures that connect people, transform cities, and push the boundaries of what is possible in civil engineering. Soaring above the skyline of Guangzhou, the Guangzhou CTF Finance Center stands as one of the tallest and most advanced skyscrapers in the world, rising to an impressive height of 530 meters with 111 floors that redefine vertical urban living and engineering excellence. Completed in 2016, this mixed-use super tall tower is a masterpiece of modern design, developed as part of the dynamic Zhujiang New Town District, where it serves as a hub for business, luxury living, and global commerce. Designed by Cohn Peterson Fox Associates, the tower features a sleek, elegant form with a facade composed of ceramic panels and glass that not only enhance its visual appeal, but also improve durability and energy efficiency in the region's humid climate. Inside, the building seamlessly integrates premium office spaces, high-end residences, and a luxurious Rosewood Guangzhou, which occupies the upper levels and offers some of the highest hotel rooms in the world, delivering breathtaking panoramic views of the Pearl River and the surrounding metropolis. One of its most remarkable features is its ultra-high-speed elevator system, capable of reaching speeds of up to 20 meters per second, making it among the fastest in the world and dramatically reducing travel time within the tower's immense vertical space. Beyond its height and speed, the Guangzhou CTF Finance Center reflects a deep commitment to sustainability and innovation, incorporating energy-efficient systems, advanced structural engineering, and smart building technologies that reduce environmental impact while maximizing performance. More than just a skyscraper, it is a symbol of Guangzhou's transformation into a global economic powerhouse, representing ambition, precision, and the relentless drive to push architectural boundaries, standing as a landmark where cutting-edge design meets functionality, and where the future of urban development rises into the sky. Soaring over the futuristic heart of the Binhai area in Tianjin, the Tianjin CTF Finance Center stands as one of the most remarkable skyscrapers in China and the world, rising to 530 meters with 97 floors of mixed-use space that includes offices, luxury service departments, and a five-star hotel, and earning recognition as the tallest building in northern China and among the tallest globally since its completion in 2019. Designed by the renowned architectural firm Skidmore, Owings and Merrill in collaboration with Ronald Liu and Partners. Its gently tapering form and undulating glass facade not only give the tower a distinctive presence on the skyline, but also enhance structural performance against wind and seismic forces, reflecting a harmony between aesthetic daring and engineering precision. More than just a super tall building, the CTF Finance Center anchors a dynamic urban hub in one of China's fastest developing metropolitan areas, symbolizing economic ambition and urban transformation while setting new standards for sustainable, high-performance skyscraper design that blends commercial vitality, residential comfort, and global prestige. Located in the vibrant Chaoyang district of Beijing, the place is one of the city's most iconic commercial and entertainment destinations, best known for its breathtaking sky screen, a massive LED canopy that stretches across the open-air plaza and transforms the space into a glowing digital spectacle unlike anything else in the world. Spanning over 250 meters in length and 30 meters in width, this enormous screen is often compared to a digital sky, displaying vivid animations, cultural visuals, and immersive light shows that captivate visitors both day and night, turning an ordinary urban square into an unforgettable sensory experience. Opened in 2007, the place was designed as a fusion of shopping, dining, and entertainment, bringing together international brands, restaurants, and social spaces into one dynamic environment that attracts tourists, locals, and business professionals alike. More than just a retail complex, it has become a cultural landmark where technology meets urban lifestyle, hosting public events, celebrations, and seasonal displays that create a constantly evolving atmosphere. The surrounding architecture complements this futuristic centerpiece with modern glass facades and open layouts that encourage movement, interaction, and exploration, making it a hub of activity in one of Beijing's busiest districts. Beyond its visual appeal, the place reflects China's rapid embrace of digital innovation and experiential urban design, demonstrating how technology can redefine public spaces and transform them into immersive environments that engage people on a deeper level. It stands as a symbol of modern Beijing, fast-paced, innovative, and visually striking, where commerce, culture, and cutting-edge technology converge to create a destination that is not only functional, but also inspiring, offering a glimpse into the future of urban entertainment and social interaction. Stretching along the shimmering coastline of the Red Sea in Jeddah, the Jeddah Corniche Circuit is one of the fastest and most thrilling street circuits ever built, a modern motorsport marvel that redefines the limits of urban racing and engineering precision. Introduced in 2021 as part of the Formula One calendar, this high-speed track spans approximately 6.17 kilometers, making it one of the longest circuits in Formula One. while its sweeping corners and long straights allow drivers to reach average speeds exceeding 250 kilometers per hour, an astonishing figure for a street-based track. Designed with both spectacle and safety in mind, the circuit features over 27 corners, advanced barrier systems, and cutting-edge lighting that enables dramatic night races against the backdrop of the Red Sea, creating a visually stunning and adrenaline-fueled experience for millions of fans worldwide. Built in record time, the Jeddah Corniche circuit reflects Saudi Arabia's growing investment in global sports and entertainment, positioning the country as a major destination for international events while showcasing its modern infrastructure and ambition on the world stage. Beyond the race itself, the surrounding Corniche area offers a vibrant mix of waterfront promenades, public spaces, and cultural attractions, turning the circuit into more than just a racing venue. It becomes a dynamic urban experience where speed, technology, and lifestyle converge. The Jeddah Corniche circuit stands as a symbol of innovation and ambition, where engineering excellence meets high-performance sport, pushing both machines and human skill to the absolute limit in one of the most exhilarating racing environments on the planet. Rising as a symbol of modern design and cultural expression in Hangzhou, the Hangzhou Sports Center, anchored by the iconic Hangzhou Sports Park Stadium, is one of China's most visually striking and technologically advanced sporting complexes, created to host major international events, including the 2022 Asian Games. Often referred to as the Big Lotus, due to its elegant petal-like structure, the stadium draws inspiration from the natural beauty of lotus flowers, blending organic design with cutting-edge engineering to create a form that appears both delicate and monumental at the same time. With a seating capacity of around 80,000 spectators, it stands among the largest stadiums in China, designed not only for athletics, but also for ceremonies, concerts, and large-scale cultural events. The structure incorporates advanced materials and sustainable technologies, including energy-efficient lighting systems, rainwater collection, and environmentally conscious construction methods, reflecting a commitment to green development while maintaining world-class performance standards. Surrounding the stadium, the broader sports park integrates training facilities, public spaces, and landscaped areas that encourage community engagement and daily use, transforming it from a single-purpose venue into a vibrant urban hub. Beyond its architectural beauty and scale, the Hangzhou Sports Center represents the city's ambition to position itself as a global destination for sports, culture, and innovation, showcasing how thoughtful design and engineering can create spaces that inspire, connect, and endure, while leaving a lasting legacy for both local communities and international audiences. Rising from Manhattan's west side, Hudson Yards is more than just a cluster of towers. It is a testament to modern urban ambition and architectural audacity. As the largest private real estate development in U.S. history, Hudson Yards transforms a once-overlooked stretch of the city into a vertical city within a city, blending residential, commercial, and cultural spaces into a seamless, soaring metropolis. At its heart, the development combines skyscrapers, plazas, and public art installations in a design that simultaneously dazzles the eye and pushes the limits of urban engineering. Constructing Hudson Yards required feats of precision and innovation. The entire district is built atop a complex platform above active rail yards, demanding enormous support structures and careful weight distribution to ensure safety without disrupting the busy transit lines below. Massive steel trusses, reinforced concrete slabs, and vibration dampening systems work together to maintain stability, while the towers themselves are engineered to withstand wind loads, shifting soil, and the dynamic stresses of one of the world's busiest cities. Every corner, from the glass facades to the public spaces, had to balance structural integrity with aesthetic appeal, creating a cohesive skyline that feels both futuristic and grounded. Central to the development is the vessel, an intricate honeycomb-like sculpture and observation structure that draws the eye upward and invites exploration. Its interconnecting staircases, reaching multiple levels, create a sense of vertical movement while testing the limits of cantilever construction. Meanwhile, the Edge, a sky-high observation deck, juts out from one of the towers, giving visitors the sensation of walking on air over Manhattan, a thrilling reminder of what modern engineering can achieve. Stretching elegantly across the Tarn Valley in southern France, Millau Viaduct is not merely a bridge. It is a monumental statement of engineering audacity and aesthetic brilliance. Completed in 2004, it holds the title of the tallest bridge in the world, with its highest mast soaring 343 meters, surpassing even the height of the Eiffel Tower. From a distance, it appears almost afloat above the valley, a slender line of steel and concrete connecting two rugged cliffs while leaving the natural beauty of the landscape almost untouched. Its design harmonizes with the environment rather than dominating it, creating a visual experience as breathtaking as the engineering achievement itself. Constructing the Millau Viaduct demanded innovation on a scale rarely seen in modern civil engineering. Instead of building from the valley floor, a method that would have been impractical and environmentally intrusive, engineers assembled massive segments of the bridge deck on level ground at both ends and then used synchronized hydraulic jacks to inch the structure forward over the chasm, advancing just centimeters at a time. Each of these massive sections, weighing hundreds of tons, had to be perfectly aligned and balanced, while the cable-stayed masts absorbed both vertical loads and lateral stresses caused by wind and potential seismic activity. The steel deck, concrete pylons, and tension cables form a symphony of structural harmony, each component meticulously designed to maintain stability while giving the illusion of lightness and elegance. The Millau Viaduct is also a triumph of human foresight and logistics. Transporting materials to such a remote and rugged location required precision planning and creative problem-solving. Every crane placement, every cable installation, and every section of concrete poured had to account for the challenging winds that sweep through the valley and the tight construction timelines imposed by seasonal weather conditions. Safety and precision were paramount, as even the smallest miscalculation could have compromised the entire structure. Beyond its technical achievements, the Millau Viaduct is a cultural and aesthetic icon. Drivers crossing it experience a sense of awe and vertigo as they soar hundreds of meters above the valley floor, the surrounding mountains stretching endlessly into the horizon. Tourists, photographers, and engineering enthusiasts from around the world flock to witness not only the scale, but also the grace of this bridge, a place where functionality and beauty coexist seamlessly. It stands as a testament to the power of human ingenuity, proving that with ambition, innovation, and meticulous planning, engineers can bend the forces of gravity and nature into structures that inspire awe and endure for generations.
In the megacity of Wuhan, engineers didn't just build another rail line. They flipped the idea of a train on its head. Instead of running on tracks like every subway or elevated railway you know, the Optics Valley suspended monorail hangs from them. Passengers glide through the air with nothing beneath their wheels but open space and skyline. A rail car suspended from an overhead beam, giving a surreal perspective of the city below. This system, nicknamed the Optics Valley Photon, isn't a prototype. It's China's first commercial suspended monorail line, officially opened in late September 2023. Phase 1 stretches about 10.5 kilometers and serves 6 stations, weaving through the high-tech Optics Valley corridor between Jufengshan and Longquansha. What sets this apart isn't just its aerial nature, it's the experience. The trains run at up to 60 kilometers per hour, fully driverless and automated, departing at regular intervals throughout the day. Beneath your feet, transparent floor panels that turn every commute into a 270-degree aerial tour of urban forests, parks, and cityscapes. Beyond the futuristic thrill, the suspended monorail represents a leap in urban transit thinking, integrating sightseeing, technology, and everyday movement into one system. It demonstrates how cities are reimagining public transport, not just for efficiency, but for spectacle. Here in Wuhan, transit isn't just about getting from A to B, it's about redefining what rail travel feels like above the ground. Long before modern skyscrapers and meta projects, one city built defenses so formidable they held for over 1,000 years. The walls of Constantinople weren't just stone barriers, they were the embodiment of strategy, ingenuity, and sheer human determination. Constructed under Emperor Theodosius II in the 5th century, these walls stretched roughly 6.5 kilometers, consisting of a triple-layered system, a moat, an outer wall, and a massive inner wall that reached up to 12 meters thick and 12 to 20 meters high. Engineers faced a unique challenge. The city sat on a peninsula, surrounded by the sea on 3 sides, but vulnerable to sieges from the land. Their solution was a layered fortification with over 90 towers spaced at intervals, allowing defenders to rain arrows and pour boiling oil on attackers, creating a barrier that seemed insurmountable. Over centuries, the walls survived countless sieges, including attempts by the Arabs, Bulgars, and Rus. Even in 1453, when the Ottoman forces finally breached the city, it wasn't because of weak walls. It was the result of artillery, strategy, and relentless determination, not poor engineering. The construction combined local limestone, bricks, and massive mortar layers, forming a structure that modern engineers still admire for its durability. Portions of the walls remain standing today, a testament to the ingenuity and foresight of the Byzantine architects who envisioned a defense capable of lasting centuries. At the heart of Rome, where history, faith, and sheer ambition collide, stands St. Peter's Basilica, a structure so monumental it seems to defy both time and gravity. Completed in 1626, after more than a century of design and construction, it covers roughly 23,000 square meters and is one of the largest churches in the world. Its central dome, designed by Michelangelo, soars over 136 meters above the floor, dominating the skyline and inspiring awe from miles away. Building it wasn't just architecture, it was a feat of engineering. Engineers and artists had to solve unprecedented challenges, supporting a massive dome on a square base, constructing enormous columns and arches that could carry tens of thousands of tons of stone, and designing the interior so that every line, sculpture, and fresco created both spiritual and visual harmony. The basilica incorporates millions of bricks, travertine stone, and marble, all arranged with precision that modern engineers still study today. Even the famed baldachin of Bernini, the towering bronze canopy over the main altar, required clever structural solutions to stand atop the columns without compromising stability. And yet, what makes St. Peter's Basilica truly extraordinary isn't just its size or materials. It's the vision of generations of artists and engineers collaborating to create something that has lasted over 400 years, surviving earthquakes, wars, and centuries of human activity. A structure where ambition, faith, and ingenuity converge in physical form. Every step inside the basilica reminds visitors, this isn't just a building. It's a declaration of human creativity, an icon that shows what's possible when bold vision meets extraordinary skill. Imagine a road carved out of the most hostile terrain on Earth. A ribbon of asphalt gripping sheer mountain walls, clinging to cliff edges, and vanishing into the clouds above 4,700 meters. This is the Karakoram Highway, a lifeline between Pakistan and China and one of the most astonishing feats of civil engineering ever attempted. Stretching nearly 1,300 kilometers from Hassan Abdul in Pakistan's Punjab province all the way to Kashgar in China's Xinjiang, this highway doesn't just link two countries. It stitches together ancient Silk Road culture with modern global trade. Along the way, it threads through some of the planet's most rugged landscapes. Gigantic glaciers, plunging valleys, roaring rivers, and peaks that tower above 8,000 meters. Mountains that dwarf most skyscrapers. At its highest point near Kunjarat Pass, the road climbs to approximately 4,700 meters above sea level, making it one of the highest paved international border crossings in the world. Building it was anything but simple. The Karakoram Range is notorious for avalanches, rockfalls, and landslides, natural hazards that forced crews to work in extreme cold, oxygen-thin air, and unstable geology. Despite this, Pakistani and Chinese engineers completed the colossal route in the late 1970s, opening a passage where none had existed. This is more than a road. It's a strategic artery for trade, a gateway for tourism, and a testament to human tenacity against nature's most unforgiving theaters. But that tenacity came at a cost. Harsh conditions and unpredictable terrain make travel here both breathtaking and perilous. Driving the Karakoram Highway isn't just sport. It's a journey across history, culture, and geography, where every hairpin turn reveals landscapes that seem almost too dramatic to be real. On the glittering waterfront of Baku, where the Caspian Sea meets the skyline of a rising metropolis, a building is taking shape that feels like architecture rewriting geometry itself. This is the Crescent Development, a collection of towers and an iconic crescent-shaped structure designed not just to be tall, but unmistakable. Part of a visionary mixed-use complex along the Caspian coast, the project includes a curved crescent-shaped hotel built on an artificial island, an office skyscraper known as Crescent City rising roughly 210 meters high, and a residential tower with retail space, all arranged to form a silhouette that echoes the crescent moon on Azerbaijan's flag. This isn't simple vertical construction. To create the crescent form of the main hotel, engineers had to first reclaim land from the sea, driving hundreds of reinforced concrete piles up to 76 meters deep into the seabed to anchor the foundations where none existed before. Then came another technical marvel, the dramatic curved span that arches between the offshore hotel's twin supporting towers was pre-assembled on the ground and lifted into place with precision cable systems, a feat rarely attempted on such a scale. The effect is unmistakable at sunset. Glass and steel reflect the shifting light over Baku Bay, turning the complex into a luminous crescent floating above the water. For engineers and architects, this project wasn't just about height. It was a test of structural ingenuity, material performance against strong seaside winds, and coordination across land and water.
In the heart of London's Paddington Basin, there's a bridge that doesn't behave like any bridge you've ever seen. This is the Rolling Bridge, an engineering marvel that curls into itself like a living organism, challenging every notion of what a bridge can do. Instead of spanning the water in a conventional way, the bridge folds up into an octagon to allow boats to pass beneath. At first glance, it looks like a static piece of art, but at the push of a single button, hydraulic mechanisms fold the 8 triangular sections, lifting the bridge off the canal and creating a dramatic, spiraling motion that feels almost magical. Designed by Thomas Heatherwick, the Rolling Bridge wasn't just about function. It's a fusion of art, architecture, and engineering. Its structure uses precision steel links, carefully balanced hydraulics, and tension cables so every movement is smooth, reliable, and visually hypnotic. At just 12 meters long, it's compact, but its mechanism is intricate. Each fold redistributes weight, each hinge bears enormous tension, and the bridge transforms from a walkway to a sculpture in seconds. A kinetic masterpiece that proves even small-scale structures can defy expectation. For pedestrians, it's a simple crossing. For engineers, it's a marvel of creativity and precision. The Rolling Bridge isn't just infrastructure. It's a reminder that engineering can surprise, delight, and challenge the very idea of possibility.
Rising from the banks of the mighty Yangtze River, the Three Gorges Dam isn't just a hydroelectric project, it's a leviathan of engineering, a structure so massive it reshaped both the landscape and the flow of history itself. Stretching 2.3 kilometers across and standing 185 meters tall, this dam holds back a reservoir containing approximately 39.3 billion cubic meters of water, enough to fill 11,000 Olympic swimming pools. Its hydroelectric plant generates around 22,500 megawatts of power, supplying roughly 10% of China's electricity demand. The turbines themselves are colossal, each the size of a small building, capable of producing more energy than most entire power stations worldwide. But the Three Gorges Dam is more than electricity. It tames floods that historically devastated millions, manages water transport, and even reshaped shipping routes. Ships now pass through the world's largest ship lifts, rising 113 meters in under 40 minutes. The scale of the project is staggering. Construction required 27 million cubic meters of concrete, enough to cover the island of Manhattan, and involved relocating over 1.3 million people from the flooded reservoir area. Engineers had to balance immense water pressure, seismic risks, and environmental impacts, making this one of the most complex infrastructure projects in human history. The dam's effects are global. Scientists calculated that the mass of water has slightly altered the Earth's rotation and shifted its poles by centimeters. In other words, humanity's reach extended literally to the movement of the planet. Here, engineering doesn't just bend nature. It negotiates with it, shaping rivers, mountains, and lives on a scale almost impossible to fathom. The Hong Kong-Zhuhai-Macau Bridge stretches across the South China Sea like a silver artery, immediately conveying ambition, scale, and the mastery of marine engineering. Spanning nearly 55 kilometers, the bridge connects three major cities, uniting islands, coastlines, and economic zones through a continuous ribbon of road and tunnel. Its design combines long-span bridges, artificial islands, and an undersea tunnel, engineered to resist typhoons, strong currents, and seismic activity. High-performance materials, aerodynamic forms, and advanced construction techniques ensure stability and durability across open water, when allowing for heavy traffic flow and logistical efficiency. Completed in 2018, after nearly a decade of coordinated construction, the project demonstrates China's ability to integrate architecture, engineering, and strategic infrastructure to reshape regional connectivity. It has reduced travel time between Hong Kong, Macau, and Zhuhai for hours to minutes, strengthening trade, tourism, and cross-border exchange. Traveling along the bridge, drivers and passengers experience a sense of vast openness, with the sea stretching in every direction and the cityscapes appearing both distant and intimately connected. The Hong Kong-Zhuhai-Macau Bridge is more than a transportation link. It is a bold testament to human ingenuity, ambition, and the power of engineering to unite land, water, and people.
Rising from the heart of the desert like a spear piercing the sky, the Burj Khalifa is more than a skyscraper. It is the ultimate statement of human ambition. At a staggering 828 meters tall with 163 floors, it has held the title of the world's tallest building since 2010, dominating the Dubai skyline and redefining what's possible in vertical construction. But height alone doesn't tell the story. Burj Khalifa's Y-shaped floor plan isn't just aesthetic. It enhances stability, reducing wind sway at extreme altitudes. Its hexagonal central core combined with three radiating wings allows engineers to resist torsion and lateral bending, ensuring the tower remains steadfast even under desert storms. Construction required ingenuity on a scale never seen before. 330,000 cubic meters of concrete, 103,000 square meters of glass, and over 39,000 tons of steel rebar, all fused to create a vertical monument to engineering. Tower cranes climbed higher than any before, and the elevator system, the fastest in the world, propels occupants at 10 meters per second. Burj Khalifa isn't just a building. It's a vertical city. Luxury residences, offices, hotels, and observation decks all exist within a structure that pushes the limits of materials, design, and human ambition. Even the cladding had to withstand extreme desert temperatures while reflecting sunlight to reduce energy demands. It stands as a symbol of boldness and precision, proving that with the right vision, humans can reach heights once thought impossible. In Dubai, the Burj Khalifa doesn't just touch the clouds, it challenges them. At the heart of Singapore's Jewel Changi Airport, water doesn't just flow. It falls in a spectacle that seems almost otherworldly. This is the rain vortex, the world's tallest indoor waterfall, plunging 40 meters from a glass-domed ceiling into the lush indoor forest below. But this isn't just a waterfall, it's a marvel of engineering and environmental design. The water circulates through a recycled rainwater system, flowing through precision-engineered channels and misting systems to create a constantly moving cascade while conserving every drop. At night, a choreographed light and mist show transforms the vortex into a living sculpture of water, glass, and illumination. Surrounding the waterfall is a multi-level forest of over 2,000 trees and thousands of shrubs, connected by suspended bridges and spiraling walkways, creating the sensation of walking through a vertical rainforest. Engineers had to calculate air circulation, humidity, and acoustics to maintain comfort, while supporting the immense weight of both water and vegetation. The rain vortex isn't just architecture, it's an immersive experience, blending nature, technology, and human creativity. Here, every droplet tells a story of precision, imagination, and the ability to turn a functional space into a world-class spectacle. In Singapore, water doesn't just fall. It performs, mesmerizes, and defines the skyline from the inside out. Deep in the hills outside Nanjing lies one of the most extraordinary abandoned projects in world history. Not a bridge or a tower, but a stone monument so colossal it was impossible to move. This is the Yangshan Stele, a monumental slab of rock carved from the mountainside during China's Ming Dynasty, and then abandoned forever. In the early 1400s, the Yongle Emperor, the same ruler who built the Forbidden City in Beijing and sponsored Admiral Zhang Yi's treasure fleets, ordered a stele of unprecedented size to commemorate his father's mausoleum. Engineers and craftsmen chiseled 3 separate sections out of Yangshan Mountain: the base, the body, and the crown. Each so massive it dwarfs most ancient monuments. Had the pieces been assembled as intended, the stele would have soared over 70 meters tall, weighing tens of thousands of tons, a stone monolith of imperial power and monumental scale. But then reality struck. The stones were simply too big to transport or erect. The terrain was brutal, and no practical method existed to haul these megaton slabs through the mountains down to the mausoleum site. Rather than complete the impossible, the project was abandoned in place, leaving the colossal remnants frozen in time. Across the frozen wilderness of Alaska, a river of steel snakes through mountains, tundra, and permafrost. This is the Trans-Alaska Pipeline System, one of the most audacious feats of industrial engineering on Earth, stretching 287 kilometers, 800 miles. From Prudhoe Bay in the Arctic north to Valdez on the southern coast, it carries crude oil from the oil fields to the shipping ports, defying extremes that would stop almost any other infrastructure project. The pipeline isn't just long. It's a masterclass in engineering adaptation. Much of it is elevated above the ground to preserve permafrost and prevent melting from the heat of the oil, while certain sections dive beneath rivers, roads, and earthquake-prone terrain. Its 800-plus pumping stations support structures, and over 1 million valves work in unison to maintain a flow of nearly 2 million barrels of oil per day at peak operation. Engineers faced extremes, temperatures dropping below 50 degrees Celsius, 58 degrees Fahrenheit, violent winds, rugged mountains, and seismic zones. To combat earthquakes, special sliding supports allow the pipeline to move safely without breaking, while insulated sections prevent permafrost thaw that could destabilize the entire route. TAPS was completed in 1977. taking just 4 years despite the harshest environmental conditions imaginable. Its construction required over 70,000 workers, nearly 1.2 million tons of steel, and innovative techniques to overcome a landscape that seemed almost designed to defeat human ambition. Imagine stepping into a world where the sky meets the ocean, where palm trees sway above crystalline waters, and every building seems to float between heaven and sea. This is the Tropical Island Resort, a marvel of human design in harmony with nature, where luxury meets imagination. From aerial view, the resort stretches across artificial lagoons, coral-shaped islands, and interconnected waterways, each villa designed for privacy, comfort, and breathtaking views. Architects and engineers have carefully sculpted the land to withstand tides, storms, and erosion, blending structural resilience with visual perfection. Many of these resorts are built on reclaimed land or tiny islands, which means every foundation is a feat of engineering. Piles driven deep into the seabed stabilize bungalows and bridges, while sophisticated drainage and water circulation systems maintain the delicate ecosystem that surrounds them. Archdaily.com. But it's not just about engineering, it's about experience. Infinity pools seem to spill into the ocean. Glass floors reveal coral reefs below, and walkways curve like natural rivers, guiding guests on a journey of awe and serenity. Designers leverage natural airflow, solar orientation, and shade structures to create comfort without harming the environment. The result is a place that feels almost surreal, floating paradise where human ingenuity meets tropical splendor, and every corner invites visitors to lose themselves in beauty, adventure, and tranquility.
The Beijing-Hangzhou Grand Canal stretches across the heart of China like a ribbon of history, immediately conveying scale, ingenuity, and the enduring power of human ambition. Flowing over 1,000 miles from the northern capital to the southern heartland, its waters link cities, rivers, and cultures, shaping landscapes and civilizations along the way. Constructed over centuries, the canal integrates locks, levees, and waterways engineered with precision to manage elevation changes, seasonal flooding, and long-distance navigation. It stands as the world's longest man-made waterway, reflecting ancient expertise in hydraulic engineering, urban planning, and resource management. Throughout history, the Grand Canal has facilitated trade, agriculture, and cultural exchange, enabling the movement of grain, goods, and people across vast distances. Its continuing function in modern times demonstrates the adaptability of historic infrastructure in supporting contemporary economic and urban development. Traveling along its flowing path, visitors sense continuity between past and present, the gentle ripple of water, the sight of historic bridges, and the rhythm of commerce, all evoking a living artery of civilization. The Beijing-Hangzhou Grand Canal is more than a waterway. It is a testament to human creativity, endurance, and the ability to shape nature in service of society. China's mega projects emerge as bold expressions of vision, precision, and immense scale. Across sweeping deserts, rugged mountain ranges, and demanding terrain, monumental structures rise where natural limits once shaped possibility. These achievements of engineering engage directly with the forces of landscape, reshaping harsh environments into arenas of innovation and forward movement. Guided by long-term planning and advanced technology, vast developments redefine the boundaries of modern construction and infrastructure. From expansive transportation corridors to sophisticated technological networks, each accomplishment reflects relentless momentum toward expansion and capability. Together, these undertakings illustrate how design, coordination, and determination transform challenge into permanence, leaving behind landmarks that embody resilience, creativity, and the trajectory of the future. Oppo's Research and Development Center rises within China's technology landscape as a hub of experimentation and digital innovation, immediately conveying precision and forward momentum where architecture and engineering meet the future of consumer electronics. Located in Dongguan, the expansive campus spans multiple interconnected towers and collaborative spaces designed to host thousands of engineers, designers, and researchers working across telecommunications, imaging systems, and mobile device technologies. Glass facades, linked walkways, and integrated work environments create a setting structured for constant exchange of ideas and rapid prototyping. Developed during the country's accelerated push into high-tech manufacturing and independent innovation, the facility reflects strategic investment in artificial intelligence, chip optimization, and next-generation connectivity research. Advanced laboratories and testing zones support iterative development cycles, allowing concepts to evolve into market-ready products used by global audiences. Moving through its open atriums and quiet research corridors, visitors sense focused energy and disciplined creativity, experiencing how collaboration, architecture, and technical ambition converge to shape the devices that quietly influence everyday communication and digital life. Chongqing Grand Theater rises along the banks of the Yangtze River as a striking cultural landmark, immediately capturing attention with its faceted glass and steel form, reflecting city lights and flowing water. Set against Chongqing's layered skyline, the structure presents itself as both architectural sculpture and performance space within one of China's most dynamic urban landscapes. Located in the Jiangbei district, the theater complex houses a large opera hall and multi-purpose performance venues designed for acoustics, visibility, and immersive audience experience. Its angular exterior panels and crystalline geometry are engineered to balance aesthetics with structural stability, while expanse interior volumes support orchestral productions, theatrical performances, and large cultural events. Completed in the early 21st century as part of Chongqing's broader urban modernization and cultural investment, the project represents the integration of artistic identity within rapid metropolitan expansion. Materials, lighting systems, and spatial planning were developed to position the venue as a regional hub for performing arts and international exchange. As evening falls and reflections ripple across the surrounding plaza, visitors experience more than architecture alone. They encounter atmosphere where music, light, and urban motion merge, sensing how cultural infrastructure transforms public space into a living stage shaped by creativity and collective expression. Yunnan Grand Theater rises gracefully amid Kunming's urban landscape, immediately capturing attention with its flowing lines, glass facades, and dynamic interplay of light and shadow. The building serves as both a cultural landmark and a hub for performing arts, reflecting the region's artistic ambition and modern architectural vision. The complex houses multiple performance halls, rehearsal spaces, and public areas designed for optimal acoustics and audience experience. Its sweeping roof lines and fluid structural forms are engineered to harmonize with the surrounding terrain, while state-of-the-art materials ensure durability, energy efficiency, and aesthetic impact. Completed in the early 21st century, Yunnan Grand Theater embodies a fusion of contemporary design and local cultural identity. The project demonstrates how architecture can celebrate heritage while advancing technological innovation, creating spaces where performance, community, and visual art converge. Walking through its expansive foyers and auditoriums, visitors sense both grandeur and intimacy, the echo of footsteps, the quiet hum of anticipation, and the interplay of natural light enhancing every detail. Yunnan Grand Theater is more than a building. It is a living stage where human creativity, culture, and engineering merge into a lasting expression of regional pride and artistic vision. Qingdao Bay Bridge stretches across open water like a sweeping ribbon of steel and concrete, immediately conveying scale and continuity as it links urban districts across the vast expanse of Jiuzhou Bay. Suspended above shifting tides and coastal winds, the structure stands as a defining example of long-distance marine engineering. Extending more than 40 kilometers in total route length, the bridge integrates multiple spans, reinforced pylons, and deep foundation supports engineered to withstand salt corrosion, seismic movement, and seasonal storms. Designed for heavy traffic capacity, its multi-lane roadway forms a critical transport corridor connecting Qingdao with surrounding economic zones, while reducing travel time across the bay. Completed in the early 21st century, after years of planning and large-scale coordinated construction, the project reflects advances in offshore surveying, materials technology, and modular assembly techniques. Thousands of workers and engineers contributed to building one of the longest sea-crossing bridges of its kind, illustrating the logistical complexity behind modern coastal infrastructure. Driving along its elevated path, travelers experience horizon in every direction, water, sky, and distant skyline blending together, creating a sense of motion through open space, while revealing how engineering can transform geographic separation into seamless connection. Shanghai Tower spirals skyward in the heart of Lujiazui, immediately commanding attention as a twisting testament to ambition, sustainability, and engineering prowess. Its glass-clad exterior captures the city's light, reflecting the bustling skyline below while signaling China's drive toward vertical urban innovation. Standing at 632 meters with 128 floors, it is China's tallest building and the second tallest in the world. Its distinctive double-skin facade reduces wind load, conserves energy, and supports state-of-the-art elevators capable of traveling more than 20 meters per second, transporting occupants through the building's vertical cityscape with fluid efficiency. Completed in 2015, after a decade of construction, the tower embodies advanced structural design, wide engineering, and integrated smart systems, combining office space, observation decks, retail zones, and cultural venues within a single vertical ecosystem. Its spiraling form is inspired by traditional Chinese symbolism, blending modern technology with aesthetic elegance. Ascending its heights, visitors feel suspended between sky and city, a sensation of awe amplified by panoramic views of the Huangpu River and surrounding skyline. Shanghai Tower exemplifies how ambition, innovation, and architectural vision converge, transforming a simple tower into a landmark of human ingenuity and urban aspiration. The Marisfro Pavilion rises like a sleek sculpture of glass and steel, immediately drawing the eye with its modern elegance and flowing architectural lines. Its facade glimmers under city lights, reflecting both ambition and the refined aesthetic of one of China's premier fashion brands. Inside, the pavilion showcases flagship boutiques, exhibition spaces, and immersive brand experiences designed to combine luxury retail with architectural drama. Curved walls, open atriums, and precise lighting create a sense of movement and sophistication, while high-performance materials ensure structural integrity and visual impact. Completed in the 21st century, the pavilion embodies the fusion of design innovation, engineering excellence, and cultural identity. Every detail, from the sweeping staircases to the expansive glass panels, communicates the brand's vision of modernity, elegance, and ambition. Walking through the space, visitors feel both intimacy and grandeur, the rhythm of footsteps echoing across polished floors, the interplay of light and reflection enhancing the sense of luxury. The Marisfrold Pavilion is more than a building. It is a living statement of creativity, technical mastery, and the power of architecture to express identity and aspiration. Raffles City, Chongqing rises like a cluster of glass and steel towers suspended above the confluence of the Yangtze and Jialing rivers, immediately commanding attention with its sky bridges and interconnected design. The development merges architecture, engineering, and urban planning, creating a vertical city where commerce, culture, and connectivity intersect. The complex consists of 8 towers, including office, residential, and hotel spaces, linked by a horizontal sky bridge that stretches across the upper levels, providing panoramic views of the rivers and surrounding cityscape. Its structural design incorporates wind-resistant engineering, seismic stability, and advanced load distribution to support the ambitious suspended sky deck. Completed in 2019, Raffles City embodies integrated urban development, combining luxury living, commercial activity, and public spaces within a single footprint. The project reflects collaboration between global architects and local engineers, merging aesthetic daring with practical resilience. Walking through its sky bridge or along the riverfront podium, visitors sense both elevation and connection, a feeling of floating above the city while remaining immersed in urban life. Raffles City, Chongqing demonstrates how architecture can redefine a skyline, harmonizing human ambition, natural geography, and urban experience into a singular landmark. The Fuxing high-speed train surges across China's vast landscape as a symbol of velocity, precision, and modern mobility, gliding between cities with a quiet authority that reflects the country's commitment to advanced transportation. From dense urban hubs to distant regions, its streamlined form cuts across distance, redefining how quickly people and economies connect. Operating on an expanding network of dedicated high-speed rail lines, the train reaches commercial speeds of around 350 kilometers per hour, supported by aerodynamic engineering, intelligent control systems, and reinforced track infrastructure designed for stability and safety. Its interiors balance efficiency with comfort, integrating digital monitoring, energy-optimized components, and vibration reduction technologies to sustain reliability over long distances. Introduced during the 21st century as part of a broader national rail modernization effort, the Fuxing series represents domestically developed high-speed technology aimed at improving capacity, reducing travel times, and strengthening regional integration. Continuous upgrades in materials, signaling systems, and operational coordination reflect an ongoing evolution in transport engineering. As passengers watch cities blur into countryside through panoramic windows, the experience becomes more than transit. It is a moment suspended between departure and arrival, where acceleration and stillness coexist, revealing how innovation can reshape perception of distance while carrying millions toward opportunity, connection, and motion. The Guangzhou CTF Finance Center rises like a sleek vertical needle above the Pearl River, immediately signaling modern ambition and architectural precision. Its glass and steel facade reflects sunlight by day and city lights by night, creating a shimmering icon within Guangzhou's rapidly evolving skyline. Standing at 530 meters with 111 floors, the tower accommodates offices, hotels, retail space, and observation decks. Its advanced structural design incorporates tuned mass dampers and high-performance materials to resist wind and seismic forces, while ultra-fast elevators transport occupants smoothly through the building's vertical cityscape. Completed in 2016, the project exemplifies a fusion of engineering innovation and urban planning. The tower's integration into Guangzhou's central business district reflects strategic intent to concentrate commerce, finance, and hospitality within a single landmark, reinforcing the city's position as a global economic hub. From observation platforms and panoramic interiors, visitors feel both awe and perspective, suspended above the urban expanse while witnessing human ingenuity transform concrete, steel, and glass into a monument of ambition, connectivity, and modern design.
Spanning the turbulent waters of the Akashi Strait, the Akashi Kaikyo Bridge stands as a pinnacle of engineering daring and precision, connecting the city of Kobe on Honshu with Owaya on Awaji Island. This suspension bridge boasts the longest central span of any in the world at 1,991 meters, with a total length exceeding 3,900 meters. Completed in 1998 after a decade of construction, it was designed not merely to carry vehicles, but to withstand some of the most extreme environmental challenges imaginable, including powerful typhoons, earthquakes, and intense marine currents. The bridge's design incorporates unprecedented engineering innovations. Each of the two massive towers rises over 300 meters above sea level, anchored deep into the seabed using giant caissons filled with concrete. The main cables, each composed of 36,830 high-strength steel wires, stretch for nearly 4 kilometers and are capable of supporting incredible tensile forces, ensuring stability against relentless winds and shifting tides. Engineers also had to account for seismic activity. The bridge sits near a major fault line, which required sophisticated shock absorption systems and flexibility to prevent catastrophic failure during earthquakes. Even thermal expansion and contraction of the steel over long distances were calculated with extreme precision, illustrating the meticulous attention to detail demanded by such a megastructure. Beyond its technical triumphs, the Akashi Kaikyo Bridge is a symbol of human perseverance and vision. Its construction transformed regional connectivity, reducing travel time between Honshu and Shikoku and facilitating commerce, tourism, and social exchange. Each vehicle that crosses is a testament to the hundreds of engineers, designers, and laborers who worked under harsh marine conditions, balancing ambition with safety. Standing before this immense span, one cannot help but marvel at how human ingenuity can overcome nature's most imposing challenges, turning a chaotic stretch of sea into a conduit of progress, resilience, and global engineering excellence. Xiaolangdi Dam is a massive flood control and hydroelectric project built on the Yellow River in China. Completed in the early 2000s, it's best known not just for generating power, but for managing one of the world's muddiest rivers. The Yellow River carries enormous sediment loads, historically a major cause of devastating floods. So the dam periodically releases controlled torrents of water to flush silt downstream. A dramatic engineering spectacle sometimes called sand washing. The structure stands about 154 meters tall and stretches over 1.6 kilometers across the valley, combining flood control, irrigation support, water supply, and electricity generation. It's a good example of modern large-scale river management. Useful economically, but also debated because such megaprojects can reshape ecosystems, alter sediment flows, and require resettlement of local communities. Hudson Yards stands as one of the boldest urban transformations of the modern era, a place where engineering ambition reshaped land that once seemed unusable. Built above a sprawling network of active rail yards in New York City, this development represents one of the most complex construction undertakings ever attempted in an urban environment. Instead of building on solid ground, engineers created an enormous platform supported by massive steel trusses and reinforced concrete, proving that even the busiest transportation infrastructure beneath could coexist with towering skyscrapers and public spaces above. The challenges were immense. Designing foundations capable of distributing weight without disrupting the rail lines required precision engineering and meticulous planning. Temperature fluctuations, vibration from trains, and wind loads on high-rise towers had to be accounted for long before construction began. Glass-clad skyscrapers now rise confidently from this artificial base, housing offices, residences, and observation decks, each relying on structural systems built to absorb motion and resist stress in one of the densest urban environments on Earth. At the center of the development sits its most visually striking attraction, Vessel, a honeycomb-like network of staircases that spirals upward in geometric symmetry. While artistic in purpose, its construction demanded careful load calculations and material precision, as thousands of visitors climb its interwoven pathways daily. Nearby, the dramatic sky deck, extending from a tower, offers sweeping views high above the city, reinforcing the idea that Hudson Yards is not just architecture, but an experience engineered to challenge perspective and scale. Hudson Yards ultimately represents more than real estate or skyline aesthetics. It demonstrates how modern engineering can reclaim and redefine space, once considered impractical, transforming industrial infrastructure into a thriving vertical neighborhood. Walking through it, one witnesses the convergence of planning, design, and structural innovation, a reminder that even in cities where space is scarce, human ingenuity continues to expand what is possible. Yashi Expressway is often described as a highway that defies geography itself, stretching across the mountainous region between Yunnan and Sichuan. This extraordinary route transforms a once dangerous journey into a breathtaking engineering spectacle. Suspended across valleys, threading through tunnels carved deep into rock, and weaving along sheer cliffs, the expressway appears less like a road and more like a ribbon of concrete floating above the clouds. Constructing the Yashi Expressway demanded solutions to extreme environmental, geological challenges. Engineers faced unstable slopes, high seismic risk, landslides, and heavy seasonal fog that drastically reduces visibility. To overcome this, they built hundreds of bridges and tunnels, carefully balancing structural loads while stabilizing surrounding rock and soil. Advanced monitoring systems track weather conditions and traffic flow, while protective barriers and drainage solutions mitigate hazards from falling debris and sudden rainfall. Every kilometer required precision planning, ensuring safety and durability in terrain where traditional road construction would have been nearly impossible. Beyond its technical complexity, the expressway reshaped connectivity, for entire regions, dramatically reducing travel time while opening economic and cultural links between communities once isolated by mountains. Yet for travelers, the experience remains unforgettable. Sweeping curves revealing vast landscapes, elevated spans offering dizzying views, and tunnels that plunge briefly into darkness before emerging again into open sky. It is a journey that constantly reminds one of the thin line between human ingenuity and the raw power of nature. The Yashi Expressway stands as a symbol of modern engineering's ability to conquer natural barriers without erasing them. Rather than flattening mountains, it adapts to their contours, merging infrastructure with landscape in a display of bold vision and technical mastery. It proves that even in the most daunting environments, ambition and innovation can carve pathways where none seem possible, turning impossible terrain into a lifeline of movement and progress. International Space Station is one of humanity's most extraordinary engineering achievements, not because it sits on land or spans a river, but because it orbits roughly 400 kilometers above Earth at about 28,000 kilometers per hour. Built through an unprecedented partnership led by agencies including NASA, Roscosmos, European Space Agency, JAXA, and Canadian Space Agency, the station represents decades of international cooperation in science, technology, and exploration. Since the first modules were launched in 1998, astronauts and cosmonauts have continuously lived and worked aboard it, making it the longest-running human presence in space. The station itself is a modular structure assembled piece by piece in orbit, a process requiring dozens of missions and countless spacewalks. Solar arrays stretching wider than a football field generate electricity, while interconnected pressurized modules house laboratories, living quarters, and observation windows. Inside microgravity conditions, researchers conduct experiments impossible on Earth, studying everything from fluid physics and combustion to human bone density loss and advanced materials manufacturing. These experiments aren't just academic. They inform medicine, engineering, and long-duration mission planning for future travel beyond low Earth orbit. Operating the ISS is a constant balancing act between innovation and risk. Crews must manage radiation exposure, extreme temperature shifts outside the hull, and the ever-present threat of orbital debris traveling at hypersonic speeds. Regular maintenance and periodic boosts for visiting spacecraft keep the station stable in orbit, highlighting how sustaining life in space requires relentless technical oversight. Despite these challenges, the ISS has served as a testing ground for technologies that could one day support missions to the Moon, Mars, and beyond. More than just a laboratory, the International Space Station stands as a symbol of what global collaboration can achieve when political and scientific interests align. It demonstrates that mega-projects are not confined to Earth's surface. Some of the most complex structures humanity has built circle the planet itself, quietly advancing knowledge while visible only as a bright moving point of light crossing the night sky. Stretching across the Detroit River, the Gordie Howe International Bridge represents far more than a transportation link. It's a modern symbol of economic integration between Detroit and Windsor, and by extension between United States and Canada. Named after hockey legend Gordie Howe, the bridge is designed to relieve congestion at one of North America's busiest commercial border crossings, where billions of dollars in goods move annually. When fully operational, it is expected to significantly streamline trade routes that are critical to automotive manufacturing, agriculture, and industrial supply chains on both sides of the border. From an engineering standpoint, the structure stands out as one of the longest cable-stayed bridges in the region, with a main span exceeding 850 meters. Its twin pylons rise dramatically above the river, supporting a deck built to carry multiple lanes of traffic, pedestrian pathways, and customs-linked infrastructure integrated into the approach systems. Constructing such a crossing required careful coordination of binational regulations, environmental assessments, and river navigation concerns, highlighting how mega-projects often face as much diplomatic and logistical complexity as technical challenge. Materials, wind loading tolerances, and ice flow considerations were all factored into the design, reflecting the harsh seasonal conditions common to the Great Lakes corridor. Beyond the physical structure, the bridge's strategic importance lies in resilience and redundancy. Previously, cross-border commercial traffic in this corridor relied heavily on a single aging link, creating a potential bottleneck with measurable economic risk. Diversifying crossing capacity reduces vulnerability to disruptions and strengthens continental logistics networks. A real-world reminder that infrastructure isn't just about moving vehicles, but about safeguarding supply chains that support millions of jobs and trillions in trade value. In that sense, the Gordie Howe International Bridge isn't simply another span of steel and concrete. It's an investment in stability, cooperation, and long-term economic continuity across one of the world's most interconnected borders. Deep inside a frozen mountain on a remote Arctic island lies one of humanity's quietest yet most critical insurance policies, the Svalbard Global Seed Vault. Located on the Norwegian archipelago of Svalbard and operated in partnership with the government of Norway and organizations like the Crop Trust, this facility was designed as a global backup for the world's agricultural biodiversity. Opened in 2008, it stores duplicates of seeds from gene banks worldwide. Not for immediate use, but as a last resort safeguard against disasters ranging from war and climate collapse to crop disease or systemic food failure. The vault's engineering is deceptively simple yet highly strategic. Carved deep into permafrost, it sits hundreds of kilometers from major population centers and well above sea level to protect it from flooding, even under worst-case climate projections. Thick concrete walls, blast-proof doors, and naturally low Arctic temperatures keep the interior stable at around minus 18 degrees Celsius, the ideal environment for preserving seeds for decades or even centuries. Even if mechanical cooling systems fail, the surrounding frozen ground slows temperature changes, creating passive resilience rarely matched by other storage infrastructures. Inside, more than 1 million seed samples representing thousands of crop species are sealed in packages and stored on metal shelving. Each deposit comes from national or regional seed banks, meaning ownership stays with the depositing country while the vault functions purely as secure storage. Its purpose became tangible when the International Center for Agricultural Research in the dry areas withdrew seeds after conflict damaged its Middle Eastern facilities, demonstrating that the system isn't symbolic, it's operational and necessary. Genetic diversity preserved here underpins global food security, enabling scientists and farmers to restore crops lost to changing climates, pests, or catastrophe. What makes the Svalbard Global Seed Vault remarkable isn't its scale or visual spectacle, but its long-term perspective. Many megaprojects solve immediate needs, yet this one anticipates threats that may unfold over centuries. It reflects an acknowledgement backed by data that global agriculture depends on a narrow genetic base and that biodiversity loss increases systemic risk. In that sense, this Arctic repository is less a monument and more a contingency plan for civilization itself, quietly protecting the biological foundation of human survival beneath the ice. Crossing some of the harshest terrain on Earth, the Qinghai-Tibet Railway is often cited as one of the boldest rail engineering projects ever attempted. Extending from Xining to Lhasa, the line climbs onto the vast Tibetan Plateau, a region frequently called the roof of the world. Built under the direction of China Railway Engineering Corporation and completed in stages before opening fully in 2006, the railway connects remote high-altitude regions to national transport networks, reshaping accessibility and economic development across Western China. The challenge wasn't distance alone, it was altitude, climate, and geology. Large portions of the route sit above 4,000 meters, with the highest track at over 5,000 meters near the Tangula Pass. Oxygen levels here can drop to roughly 50 to 60% of those at sea level, affecting both workers during construction and passengers afterward. To mitigate this, trains include pressurized cabins and onboard oxygen systems, while stations along the route were designed with medical and acclimatization considerations in mind. Another major obstacle was permafrost. Thawing ground could destabilize tracks. Engineers developed elevated track beds, heat-reflective materials, and cooling ducts to maintain ground stability. Innovations that pushed railway design into new territory. Environmentally and politically, the railway remains debated, reflecting the complex trade-offs often tied to megaprojects. Supporters highlight improved mobility, tourism, and logistics, citing measurable increases in regional connectivity and economic integration. Critics raise concerns about ecological disruption and cultural impact, emphasizing that infrastructure of this scale inevitably reshapes landscapes and societies. Objectively, both views rest on observable outcomes. Infrastructure expands opportunity, but also alters local dynamics, making the railway an instructive case study in how engineering decisions ripple far beyond technical achievement. Today, the Qinghai-Tibet Railway stands not just as a transportation link, but as a demonstration of human capability to build under extreme environmental constraints. It illustrates how megaprojects can redefine what's physically possible while simultaneously forcing broader conversations about sustainability, adaptation, and the long-term consequences of connecting previously isolated regions. Rising from the sands of the Egyptian desert with an aura of timeless mystery, the Great Pyramid of Giza stands as one of humanity's most extraordinary and enduring architectural achievements. Constructed over 4,500 years ago during the reign of Pharaoh Khufu, it was originally intended as a tomb, yet it transcends its funerary purpose, symbolizing the ingenuity, ambition, and organizational skill of ancient civilizations. Composed of roughly 2.3 million limestone and granite blocks, each weighing between 2.5 to 3 tons, the pyramid rises to approximately 146 meters and was the tallest human-made structure on Earth for millennia, a feat that still inspires awe in engineers and archaeologists alike. The construction techniques remain a subject of debate and fascination. Without modern machinery, workers transported massive stones using sledges, ramps, levers, and ropes, while sophisticated surveying methods ensured precise alignment with the cardinal points. Scholars estimate that tens of thousands of laborers, carefully organized into teams, worked for decades to complete the project. The interior passages, chambers, and shafts reflect an advanced understanding of geometry and structural load management, allowing the pyramid to remain stable despite its immense weight and the passage of time. Its construction challenged not only human stamina, but also the limits of ancient engineering knowledge. Beyond its technical brilliance, the Great Pyramid of Giza serves as a testament to the societal and cultural organization of the Old Kingdom. The ability to mobilize resources, coordinate labor, and sustain supply chains on this scale suggests a level of planning and administrative sophistication that rivals modern projects. Additionally, the pyramid's alignment with celestial bodies, including the North Star and specific solar events, highlights a deep understanding of astronomy, reinforcing the idea that its creators sought harmony between the terrestrial and the cosmic. Even today, the Great Pyramid captivates the imagination, drawing millions of visitors and inspiring countless studies. It is not only a marvel of ancient engineering, but also a symbol of human ambition, a reminder that creativity, organization, and determination can overcome enormous challenges. Standing before it, one cannot help but feel the weight of history and the extraordinary achievement of a civilization that dared to reach for the heavens, leaving a structure that has endured as both a monument and a mystery for thousands of years.
The Three Gorges Dam stretches across the Yangtze River with commanding presence, immediately conveying monumental scale and human ambition as mountains and water merge with engineering mastery. Its massive concrete walls and stepped spillways rise against the river's flow, creating a landscape transformed by design and determination. Spanning over 2 kilometers and standing more than 180 meters tall, the dam integrates hydroelectric turbines, navigational locks, and flood control systems, forming the world's largest power-generating facility by installed capacity. Each component reflects advanced structural engineering, precise calculations, and decades of coordinated construction efforts completed in the early 21st century. The project reshaped the region's geography, enabling renewable energy production, controlling seasonal floods, and improving navigation for inland shipping. At the same time, it required large-scale relocation of communities and careful management of ecological impact, demonstrating the complex balance between human progress and environmental stewardship. Standing on observation platforms above the surging waters, visitors feel both awe and introspection, sensing the immense power of flowing rivers harnessed by human ingenuity, and understanding how engineering can transform nature while leaving an indelible mark on civilization. The Country Garden headquarters rises like a gleaming emblem of ambition in Shanghai, immediately commanding attention with its modern glass and steel design and bold architectural presence. The building serves as the nerve center for one of China's leading real estate developers, reflecting both corporate vision and engineering sophistication. Housing offices, meeting spaces, and innovation hubs, the headquarters is designed for efficiency, collaboration, and environmental sustainability. Its structural framework integrates high-performance materials, energy-saving systems, and expansive open interiors, creating a workspace that balances functionality with striking visual identity. Completed in the 21st century, the headquarters embodies the growth story of Country Garden from its founding in 1992 to a Fortune Global 500 enterprise. The architecture communicates progress, resilience, and modernity, establishing the building as both a corporate landmark and a symbol of urban development. Walking through its luminous lobbies, glass corridors, and landscaped surroundings, visitors sense a fusion of ambition and design. The soft reflections, quiet hum of activity, and interplay of light and space, creating an environment that feels alive with purpose. The Country Garden headquarters is more than an office. It is a monument to human creativity, organizational vision, and the transformative power of architecture. Stretching nearly 8 kilometers across open water, the Mackinac Bridge doesn't just connect two land masses. It connects two worlds. Here, in the rugged straits between Lake Michigan and Lake Huron, engineers had to tame nature's raw forces to bind America's upper and lower peninsulas together with steel, cable, and rock. Known locally as the Mighty Mac, this suspension bridge was completed in 1957 after years of planning and construction under conditions that would unsettle even seasoned builders. Designed by David B. Steinman, it became a testbed for aerodynamic stability, incorporating an open-load grid deck and deep stiffening trusses specifically to withstand the punishing winds that roar through the straits. At middle-span, the roadway hangs roughly 200 feet above the water, supported by massive towers that rise over 550 feet high. steel giants anchored deep into the cold lake bed. Yet the drama isn't just vertical. In severe wind conditions, the center of the suspended deck can shift as much as 35 feet sideways, a controlled dance between structure and storm. When it opened, the Mackinac Bridge became the longest suspension bridge between anchorages in the Western Hemisphere, a title it still holds decades later. For decades before, ferries were the only way to cross. Now, whether it's freight trucks rumbling across or families driving into vacation country, this singular span has redefined connectivity in a place that once seemed divided by geography itself. It isn't just a bridge, it's a testament to what happens when courage, design, and engineering confront elements that refuse to cooperate. Stretching beyond the horizon like a ribbon laid across the sea, the Vasco da Gama Bridge doesn't just cross a river. It challenges the limits of scale itself. Spanning roughly 17 kilometers across the Tagus estuary, it ranks among the longest bridges in Europe. So long that much of the journey feels less like crossing a structure and more like driving over open water. Completed in 1998, after about 4 years of construction, this colossal megaproject was built to ease traffic congestion around Lisbon and coincide with the World Exposition of that year. But the real story lies beneath the asphalt. Engineers had to anchor massive foundation piles up to 95 meters into the ground to stabilize the bridge in soft estuary conditions, while also preparing it to withstand winds near 250 kilometers per hour and major earthquakes. At its core sits a cable-stayed section with pylons rising around 150 to 155 meters high and a main span of 420 meters, balancing enormous forces through tension rather than sheer mass. Even the deck itself isn't rigidly fixed. It can shift sideways and lengthwise, allowing the structure to absorb vibrations and seismic shocks instead of resisting them outright. And then there's the scale of logistics. 6 lanes of traffic, suspended over a protected natural reserve, requiring environmental safeguards, and even relocation of nearby residents during construction. This isn't just a bridge. It's a reminder that modern engineering sometimes doesn't fight nature. It adapts to it, bends with it, and survives because of it. Imagine building an entire neighborhood, not on land, but floating above one of the busiest rail yards in the United States. Hudson Yards isn't just another construction project. It's the largest private real estate development ever undertaken in U.S. history. A staggering $25 billion mega project spread across 28 acres on Manhattan's west side. Instead of clearing the site, engineers faced a harsher reality. Dozens of active train tracks carrying commuter and intercity rail traffic beneath them every day. Shutting them down wasn't an option, so they did something audacious. They built a massive steel platform over the rails and constructed the city on top of it. This artificial foundation now supports more than 11 million square feet of apartments, offices, and retail space, effectively suspending skyscrapers over moving trains and underground tunnels. Across roughly 18 million square feet of development, the complex includes residential towers, offices, cultural venues, retail centers, and public spaces designed to host tens of thousands of workers and residents. The tallest building, 30 Hudson Yards, rises about 1,296 feet, placing it among the highest office towers in New York. But the engineering challenge wasn't only structural. Constructing over live infrastructure demanded precise load distribution, vibration control, and ventilation solutions to dissipate heat and exhaust from trains below, a level of complexity that dramatically increased costs and technical risk. Love it or criticize it, and many urban planners do both. Hudson Yards represents a new urban experiment. A self-contained city within a city combining housing, workplaces, shopping, culture, and open space into a single engineered platform. It's proof that modern construction no longer just reshapes skylines. It creates entirely new ground where none existed before. In China's Sichuan province, There is a highway many drivers describe as something out of a dream or a nightmare. It's called the Yangtze Expressway, often nicknamed the road in the clouds, and once you see where it runs, you'll understand why. Stretching roughly 240 kilometers between Ya'an and Xichang, this route isn't carved through gentle countryside. It climbs through some of the most unforgiving mountain terrain engineers could face. A landscape so hostile it forced them to build not just a road, but an aerial maze of structures. Instead of hugging the ground, the highway leaps across valleys and burrows through rock. Along its path are about 270 viaducts and 25 tunnels, stitched together into a continuous transport corridor. The tunnels alone span roughly 41 kilometers, a reminder that much of the journey happens inside mountains rather than around them. Driving here isn't just travel, it's elevation. The route rises from about 1,970 feet to more than 10,500 feet above sea level, meaning vehicles can literally pass through cloud layers while crossing unstable terrain that includes multiple seismic fault zones. That combination of altitude, geology, and exposure is one reason it's been described as among the most difficult motorway projects ever attempted. And then there are the structures that carry the road itself. Take the Ganhaizi Bridge. Perched over 2,500 meters high, one of the first reinforced concrete truss bridges of its kind, stretching nearly 1.8 kilometers across open air. Or the towering piers along the route, some reaching heights above 180 meters, built simply to keep the roadway level enough for safe driving. Construction lasted from 2007 to 2012 and cost around 20.6 billion yuan, a price that reflects the brutal logistical reality of building infrastructure, where gravity, weather, and geology constantly fight back. Today, the Yangtze Expressway stands as proof that modern engineering doesn't just conquer distance. It negotiates with nature. Rising above Shanghai's skyline like something pulled from science fiction, the Oriental Pearl Tower isn't just a broadcast mast. It's a structural balancing act wrapped in steel and concrete. Completed in 1994 and standing about 468 meters tall, it was once the tallest structure in China and remains one of the city's most recognizable landmarks. Its design is unmistakable. 11 spherical structures connected by columns and beams, stacked along a slender vertical shaft. But behind the futuristic appearance lies a demanding engineering challenge. Supporting those massive spheres, including two primary observation decks suspended high above the ground, required a stable base formed by 3 enormous inclined columns anchored into deep foundations built to handle the soft river delta soils of Shanghai. The tower was designed to withstand extreme environmental forces as well. Engineers calculated resistance against powerful typhoon winds and seismic events common to the region, ensuring the structure could flex safely rather than rigidly oppose stress, a principle essential for very tall towers exposed to lateral loads. Inside, the tower functions as far more than infrastructure. It houses rotating restaurants, exhibition spaces, and viewing platforms that attract millions of visitors each year, blending telecommunications, tourism, and urban identity into a single vertical complex. What makes the Oriental Pearl remarkable isn't just its height or unusual geometry. It's the idea that architecture can become symbolism, turning a technical broadcast facility into a defining icon of a global megacity.
Straddling the Colorado River between Nevada and Arizona, the Hoover Dam is more than concrete and steel. It's a testament to human daring and ingenuity. Completed in 1936 during the Great Depression, this colossal structure stands 221 meters tall, stretches 379 meters across, and was the tallest dam in the world at the time of its completion. Constructing it was an immense challenge. Workers carved through rugged canyons, diverted the mighty Colorado River, and poured over 4.4 million cubic meters of concrete, enough to pave a road from San Francisco to New York. To prevent the massive concrete from cracking, engineers embedded 582 miles of 1-inch steel pipes and circulated chilled water through them, cooling the structure block by block. Hoover Dam's reservoir, Lake Mead, stores up to 35 billion cubic meters of water, controlling floods, providing irrigation, and generating 2,080 megawatts of hydroelectric power for millions of people across Nevada, Arizona, and California. Its impact is both functional and symbolic, an emblem of progress, resilience, and human mastery over nature. The dam's arch-gravity design channels immense water pressure into the canyon walls, balancing colossal forces with precision. Even today, engineers marvel at the foresight and meticulous calculations that turned a rugged desert gorge into one of the most iconic engineering landmarks on Earth. Hoover Dam isn't just infrastructure, it's a monument to ambition, where human determination overcame geography, physics, and the hardships of its era to create something that continues to awe the world nearly a century later. Straddling the Colorado River between Nevada and Arizona, the Hoover Dam is more than concrete and steel. It's a testament to human daring and ingenuity. Completed in 1936 during the Great Depression, this colossal structure stands 221 meters tall, stretches 379 meters across, and was the tallest dam in the world at the time of its completion. Constructing it was an immense challenge. Workers carved through rugged canyons, diverted the mighty Colorado River, and poured over 4.4 million cubic meters of concrete, enough to pave a road from San Francisco to New York. To prevent the massive concrete from cracking, engineers embedded 582 miles of 1-inch steel pipes and circulated chilled water through them, cooling the structure block by block. Hoover Dam's reservoir, Lake Mead, stores up to 35 billion cubic meters of water, controlling floods, providing irrigation, and generating 2,080 megawatts of hydroelectric power for millions of people across Nevada, Arizona, and California. Its impact is both functional and symbolic, an emblem of progress, resilience, and human mastery over nature. The dam's arch-gravity design channels immense water pressure into the canyon walls, balancing colossal forces with precision. Even today, engineers marvel at the foresight and meticulous calculations that turned a rugged desert gorge into one of the most iconic engineering landmarks on Earth. Hoover Dam isn't just infrastructure, it's a monument to ambition, where human determination overcame geography, physics, and the hardships of its era to create something that continues to awe the world nearly a century later. Out over the shimmering waters of the Yellow Sea lies a structure so immense it feels like humanity trying to stretch the horizon itself. This is the Jiaozhou Bay Bridge, a colossal roadway slicing straight across Jiaozhou Bay in eastern China, at roughly 26.7 kilometers long, with more than 25 kilometers of it spanning open water. This isn't just a bridge, it's one of the longest sea bridges ever built. A continuous corridor linking the urban heart of Qingdao with the industrial and airport districts across the bay. Construction took 4 years and tens of thousands of workers, using 450,000 tons of steel and over 2.3 million cubic meters of concrete, enough to rival the mass of dozens of Eiffel Towers. More than 5,000 concrete piles anchor the bridge to the bay floor, engineered to withstand earthquakes, typhoons, and even the impact of large vessels navigating the busy waters below. The road deck carries a 6-lane highway, cutting travel time across the bay by up to 30 minutes compared to the long coastal route. This T-shaped megastructure has multiple navigable sections, each spanning channels that are crucial for shipping traffic, and a design that blends pre-stressed concrete with cable and estate engineering on key spans. For engineers, Jiaozhou Bay Bridge wasn't just about being long. It was about mastering marine conditions, dynamic loads, and climatic extremes in one of the world's busiest coastal regions. When you drive across it, you're not just crossing water, you're traversing a continuous testament to scale, ambition, and precision, where human design meets the relentless expanse of the sea itself. Rising like a twisting spiral into the clouds, the Shanghai Tower redefines what a skyscraper can be. At 632 meters tall with 128 floors, it is China's tallest building and the second tallest in the world. A shimmering beacon of ambition in the heart of Shanghai's financial district. What makes it extraordinary isn't just height, it's the twist. The tower rotates 120 degrees from base to top, reducing wind loads by 24%. And stabilizing the structure without massive additional materials. Engineers used a reinforced concrete core surrounded by a glass facade double-layered to improve insulation, ventilation, and energy efficiency. Inside, the Shanghai Tower is a vertical city. Office spaces, luxury hotels, observation decks, and retail zones are stacked with sky gardens every 14 floors, creating green oases that naturally circulate air and reduce energy use. High-speed elevators whisk passengers at up to 20.5 meters per second, making it one of the fastest in the world. Construction required cutting-edge techniques, over 200,000 tons of steel, 79,000 cubic meters of concrete for the core, and precise engineering to handle Shanghai's typhoon winds and seismic activity. The twisting design isn't just aesthetic. It's a functional innovation that marries beauty with performance. From street level, it dominates the skyline. From above, it spirals gracefully, a symbol of China's technological prowess and unrelenting ambition. The Shanghai Tower isn't merely a building, it's a statement. Humanity can reach higher, twist bolder, and build smarter than ever before. Connecting the Atlantic and Pacific Oceans, the Panama Canal is more than a waterway. It is a colossal artery of global commerce, a monument to human determination carved across the Isthmus of Panama. Since its opening in 1914, it has transformed trade, enabling ships to save thousands of kilometers of travel around South America's Cape Horn. The canal is an engineering marvel. A system of locks, dams, and artificial lakes lifts ships over 26 meters above sea level, guiding them safely through narrow channels and dense rainforest. Each lock chamber is enormous, as tall as an 11-story building and capable of handling vessels weighing up to 4,000 tons. In the 2016 expansion, new locks were added to accommodate Neo-Panamax ships, some of the largest ever built. Each massive gate rolls on rails, requiring only a fraction of its weight and force to move, and water-saving basins recycle millions of liters with every transit. The project demonstrates not just scale, but precision, efficiency, and foresight. The Panama Canal is more than infrastructure. It's a bridge across continents, a bold manipulation of geography, and a reminder that with ingenuity, humans can reshape the flow of water and the flow of the world. Every ship that passes through is a testament to a century of vision, labor, and relentless engineering excellence.
In the heart of Singapore, where dense urban skyline meets the sea, an entirely different kind of landscape rises, not steel towers, but engineered nature shaped by technology. This is Gardens by the Bay, a futuristic park stretching across roughly 101 hectares along the Marina waterfront, designed to redefine how cities coexist with ecology. But the icons here aren't ordinary trees. They're the super trees, towering vertical gardens standing between about 25 and 50 meters tall, combining architecture, botany, and renewable systems into one structure. Look closer, and you'll realize these giants aren't decorative sculptures. They harvest solar energy through photovoltaic cells, channel rainwater for irrigation, provide ventilation for nearby conservatories, and support thousands of living plants, orchids, ferns, and tropical climbers growing directly on their steel frame. By day, they cast shade across the gardens. By night, they transform into glowing beacons during choreographed light and music shows, turning sustainability infrastructure into spectacle. Suspended between two of these structures is the elevated skyway, a narrow aerial walkway offering panoramic views across Marina Bay and the surrounding skyline, reinforcing the sense that this place sits halfway between science fiction and ecological engineering. And beyond the super trees lies an even broader vision: climate-controlled domes and artificial ecosystems built to simulate distant environments. prove that modern urban design is increasingly about constructing nature as much as preserving it. Rising from the desert landscape of Dhahran, Saudi Arabia, stands a structure that looks less like a building and more like a cluster of giant polished stones frozen in motion. This is ITHRA, officially the King Abdulaziz Center for World Culture, a place designed not just to be seen, but to reshape how culture and knowledge are experienced. Opened to the public in 2018 after more than a decade of development, the complex spans roughly 100,000 square meters and was built by Saudi Aramco as a cultural initiative focused on education, creativity, and global exchange. Its architecture, designed by Norwegian firm Snøhetta, is wrapped in hundreds of kilometers of bent steel tubing, giving the exterior its shimmering, organic texture. Inside, it's not just galleries. It's an entire ecosystem: a library, museum spaces, cinemas, theaters, labs, and exhibition halls, all intended to connect heritage, science, and art in one environment. The centerpiece tower rises 18 stories above a cluster of sculptural volumes, symbolizing the project's goal of elevating ideas and creativity. Since opening, the center has drawn millions of visitors and hosted tens of thousands of programs and cultural activities, positioning itself as one of the region's most ambitious cultural hubs. In a nation globally associated with energy resources, ITHRA represents something different: an investment in intellectual capital. Not a monument to extraction, but to imagination. Where most bridges simply cross water, this one disappears beneath it. Stretching between Denmark and Sweden, the Øresund connection isn't just a bridge. It's a hybrid engineering system that shifts form mid-journey, transforming from highway in the sky to tunnel under the sea. From the Swedish coast, drivers race across nearly 8 kilometers of elevated roadway suspended over open water, a structure carrying both cars and trains on the same span. But halfway across, something unexpected happened. The bridge touches down on an artificial island, and the route plunges into a roughly 4-kilometer underwater tunnel heading toward Denmark. Altogether, this coast-to-coast link stretches about 15.8 kilometers and combines multiple elements: bridge, island, and immersed tunnel into a single continuous transport corridor. The central cable-stayed section spans a busy shipping channel with about 57 meters of clearance, allowing major vessels to pass beneath without disruption. This unusual design wasn't just for spectacle. The tunnel portion prevents interference with aircraft operating near Copenhagen Airport, maintains shipping access, and protects the crossing from ice and harsh weather, constraints that shaped every engineering decision. Opened in 2000, the link physically connected the Scandinavian peninsula with mainland Europe's transport networks, reshaping regional travel and trade flows in ways ferries never could. Because sometimes mega projects aren't about building bigger. They're about solving problems so complex the solution has to exist above, on, and below the sea at the same time. Deep within Siberia's remote wilderness stands a wall of concrete, so immense it feels less like infrastructure and more like a barrier between worlds. The Sayano-Shushenskaya Dam rises over the Yenisei River, Russia's largest hydroelectric power station, a structure built to tame one of Asia's most powerful waterways. Towering more than 240 meters high, its curved concrete arch presses against the surrounding mountains with staggering force, holding back a reservoir that stretches hundreds of kilometers into the wilderness. But size alone doesn't define danger. This is engineering operating under relentless pressure, literally. Millions of tons of water push constantly against the structure, and inside the power station below, turbines convert that force into electricity for entire regions of Siberia. In 2009, the world saw just how unforgiving this environment could be. A turbine failure triggered a catastrophic accident inside the plant, unleashing a violent surge of water that tore through the turbine hull and killed 75 people. Investigations later pointed to mechanical fatigue and long-term vibration issues, a stark reminder that even the most massive infrastructure depends on microscopic tolerances holding together under extreme stress. Today, the facility has been rebuilt and modernized, yet the lesson remains carved into its legacy. When you harness nature at this scale, the margin between control and chaos becomes razor thin. Here, deep in Siberia, engineering doesn't just generate power, it negotiates daily with forces capable of overwhelming it. Tianlong Mountain Bridge soars above rugged peaks and deep valleys, immediately conveying both engineering daring and the delicate balance between structure and landscape. Its sweeping spans stretch across precipitous cliffs, creating a modern passage where once only steep trails and clouds marked the horizon. Located in a region of dramatic elevation changes and unstable geology, the bridge incorporates reinforced concrete pylons, high-tensile steel cables, and aerodynamic design to resist strong winds, seismic activity, and seasonal fog. Its curves and inclines are precisely calculated to ensure stability, safety, and smooth transit across the mountainous terrain. Completed in the 21st century as part of China's ambitious infrastructure expansion, Tianlong Mountain Bridge exemplifies the integration of advanced construction techniques with natural geography. Engineers leveraged state-of-the-art surveying, modular assembly, and continuous monitoring to overcome extreme environmental challenges. Traveling along its elevated roadway, visitors experience a sense of suspension above the valley floor, glimpsing cloud-shrouded peaks and distant horizons. The bridge reveals how human determination and technical ingenuity can tame extreme landscapes, turning obstacles into enduring pathways of connection and possibility. The South-North War Transfer Project stretches across China's vast heartland like a lifeline, immediately conveying scale, ambition, and the transformative power of infrastructure. Canals, tunnels, and aqueducts snake across plains, hills, and rivers, moving water from the abundant south to the arid north, reshaping landscapes and livelihoods along the way. Spanning thousands of kilometers, the project integrates massive pumping stations, underground tunnels, and open channel systems engineered to withstand geological complexity, seasonal flooding, and long-term maintenance challenges. Its design balances efficiency with environmental management, ensuring that water reaches major cities, industrial hubs, and agricultural regions while minimizing ecological disruption. Completed in stages during the early 21st century, the project reflects decades of planning, advanced hydraulic engineering, and national coordination. It exemplifies China's commitment to solving regional resource disparities through technical innovation, large-scale labor coordination, and strategic foresight. Traveling along its engineered corridors or observing water flow through expansive aqueducts, visitors sense both human ingenuity and the vast patience of nature. The South-North War Transfer Project stands as a monument to engineering vision, demonstrating how infrastructure can bridge scarcity, connect communities, and sustain life across one of the world's most populous nations. The Tianjin Finance Center rises like a sleek needle of steel and glass, immediately conveying ambition, precision, and the city's drive toward global economic prominence. Its soaring facade reflects sunlight by day and shimmers with city lights by night, establishing a landmark presence within Tianjin's modern skyline. The building houses corporate offices, conference halls, and high-tech operational spaces, designed to accommodate the fast-paced demands of finance and commerce. Advanced structural engineering, energy-efficient systems, and earthquake-resistant design ensure stability, functionality, and longevity in one of China's major economic hubs. Completed in the 21st century, the Tianjin Finance Center represents both technological achievement and strategic urban planning. Its architecture communicates confidence, modernity, and the city's role in connecting regional finance with global markets. Walking through its expansive atriums, polished lobbies, and glass-walled corridors, visitors feel the rhythm of commerce, the hum of activity, the reflection of light across surfaces, and the subtle interplay of scale and space evoke both awe and inspiration. The Tianjin Finance Center is more than a skyscraper. It is a symbol of human ambition, architectural mastery, and the dynamic pulse of modern China. The Shenzhen-Zhongshan link rises across the Pearl River Delta like a sweeping steel ribbon, immediately signaling scale, precision, and transformative connectivity. Stretching over dozens of kilometers, it unites two of China's fastest-growing urban centers, turning the waters and islands of the Delta into a seamless corridor for commerce and travel. The bridge tunnel complex combines long-span bridges, artificial islands, and undersea passages engineered to withstand typhoons, tidal currents, and seismic activity. Advanced materials, aerodynamic design, and precision construction techniques ensure structural resilience while accommodating high-volume traffic and heavy logistics across one of the world's busiest coastal regions. Planned and executed as part of the Greater Bay Area Initiative, the project reflects strategic integration of transportation, economic planning, and urban expansion. By shortening travel times and linking major industrial and financial hubs, it strengthens regional cohesion while supporting China's ambitions for global trade and innovation. Traveling along the elevated spans or glimpsing the undersea section, commuters and visitors experience a sensation of motion over water, with the delta's islands, rivers, and urban clusters unfolding below. The Shenzhen-Zhongshan link stands as a monument to engineering ambition, where human ingenuity transforms natural waterways into arteries of progress and connection. The Qinghai Tibet Railway stretches across the Tibetan Plateau like a steel ribbon suspended above the clouds, immediately conveying ambition, engineering precision, and the power of human determination. Crossing some of the highest and most remote terrain on Earth, the railway links Qinghai Province with Lhasa, transforming travel and connectivity across vast, challenging landscapes. Spanning over 1,200 miles, the line traverses permafrost, mountain ranges, and high-altitude deserts, incorporating advanced bridge structures, tunnels, and elevated tracks. Specialized engineering solutions, including oxygen-supplied carriages, reinforced track beds, and real-time monitoring systems ensure stability, passenger safety, and resilience in extreme conditions. Completed in the early 21st century, the Qinghai Tibet Railway exemplifies China's ability to integrate geotechnical innovation, large-scale logistics, and environmental management. It not only supports economic and cultural exchange, but also demonstrates how human ingenuity can overcome the harshest natural challenges. Traveling along the railway, passengers experience a breathtaking panorama, snow-capped peaks, endless plateaus, and cloud-filled valleys unfold in every direction. The Qinghai Tibet Railway is more than a transportation route. It is a testament to human ambition, technological mastery, and the enduring spirit of connection across the world's highest lands. Xiaolangdi Dam rises across the Yellow River like a colossal barrier, immediately conveying human ambition and engineering mastery over one of China's most powerful waterways. Its massive concrete walls stretch across the valley, controlling seasonal floods while harnessing the river's energy to generate power and regulate water flow. Standing over 100 meters tall and spanning nearly a kilometer, the dam integrates hydroelectric turbines, spillways, and sediment control systems. Its design reflects advanced hydraulic engineering, structural resilience, and careful attention to the dynamic behavior of the Yellow River, notorious for its shifting sediment and flood potential. Completed in the late 20th century, Xiaolangdi Dam exemplifies China's commitment to water management, energy generation, and regional development. The project required extensive geological surveys, coordinated construction efforts, and long-term planning to ensure safety, efficiency, and environmental balance. Walking along observation platforms or viewing the torrent below, visitors feel the sheer power of the river harnessed through human ingenuity. Xiaolangdi Dam stands as a monument to determination, illustrating how engineering can transform natural force into a controlled, life-sustaining resource. The Three Gorges dam ship locks on the left bank rise like monumental gateways, immediately capturing the scale and ambition required to navigate one of the world's mightiest rivers. Massive steel gates, deep chambers, and engineered channels allow ships to ascend and descend hundreds of meters, transforming the Yangtze into a continuous artery for commerce. Designed to handle vessels of all sizes, the locks integrate advanced hydraulic control systems, reinforced concrete walls, and precise water level management. Each chamber is calculated to balance immense pressure, flow, and timing, ensuring safe passage while maintaining the river's ecological and navigational integrity. Completed alongside the main dam, the left bank ship locks exemplify the integration of transportation, energy, and flood control. They reflect decades of engineering innovation, where meticulous planning, advanced construction techniques, and real-time monitoring converge to move goods and people efficiently across the region. Passing through the locks, travelers and crews experience the river's power firsthand. Water rising and falling with controlled precision, walls towering overhead, and a sense of suspended motion that blends awe with appreciation for human ingenuity. The Three Gorges dam ship locks stand as a testament to how engineering can tame natural forces, creating pathways of connection and progress across immense landscapes. The Taklamakan Desert Highway stretches across one of Earth's most unforgiving landscapes like a ribbon of asphalt etched into endless golden sands, immediately conveying human determination and engineering audacity. Spanning over 500 kilometers, the highway links remote desert towns, providing vital connectivity across the vast arid expanse of the Taklamakan. Engineered to withstand extreme temperatures, shifting dunes, and harsh desert winds, the route integrates reinforced roadbeds, sand control barriers, and strategically planted green belts to prevent erosion and maintain stability. Advanced materials and construction techniques ensure durability, while preserving the delicate desert ecosystem. Completed in the late 20th century, the highway represents a triumph of logistics, planning, and perseverance, transforming an inhospitable terrain into a functional corridor for transport, trade, and human mobility. It reflects China's broader ambition to connect remote regions with modern infrastructure. Driving along the highway, travelers experience solitude and vastness, golden dunes stretching to the horizon, mirages shimmering under the sun, and the hum of engines against silence. The Taklamakan Desert Highway is more than a road. It is a testament to human ingenuity, resilience, and the courage to carve progress across one of the planet's most extreme environments. Chimelong Ocean Kingdom rises like a vibrant microcosm of the ocean, immediately capturing the imagination with its expansive aquariums, themed zones, and sweeping architectural design. Located in Hengqin, Zhuhai, the park combines entertainment, education, and cutting-edge engineering to create one of the world's largest marine-themed resorts, covering more than 12 million square feet. The park features massive aquariums holding tens of millions of liters of water, roller coasters that twist above waves, and immersive exhibits showcasing marine biodiversity from coral reefs to polar ecosystems. Advanced life support systems, structural engineering, and water filtration technology ensure that habitats remain safe, sustainable, and visually spectacular. Opened in 2014, Chimelong Ocean Kingdom has earned multiple Guinness World Records for its aquariums and themed rides, attracting millions of visitors annually. It exemplifies China's ability to merge large-scale entertainment with technological innovation, providing experiences that blend thrill, wonder, and environmental awareness. Walking through its immersive environments, visitors feel transported beneath the sea. The sound of waves, glimpses of whale sharks, and cascading water creating a sense of awe and connection. Chimelong Ocean Kingdom is more than a theme park. It is a living celebration of human creativity, engineering ambition, and the beauty of the natural world. Harbin Opera House rises from the snowy plains of Heilongjiang like a sculpted wave frozen in motion, immediately commanding attention with its flowing, organic forms that echo the surrounding mountains and rivers. The building blends seamlessly with its environment, creating a visual dialogue between architecture and nature. The complex houses multiple performance halls, rehearsal spaces, and public areas, designed with world-class acoustics and cutting-edge technology. Its sweeping curves, glass facades, and steel frameworks are engineered to withstand harsh winter temperatures, heavy snowfall, and seasonal winds while maintaining aesthetic elegance and structural resilience. Completed in 2015, Harbin Opera House exemplifies the fusion of contemporary design, cultural expression, and advanced engineering. It serves as both a cultural landmark and a symbol of the city's ambition to integrate art, architecture, and environment into a single harmonious experience. Walking through its flowing corridors and expansive auditoriums, visitors feel a sense of movement and inspiration, the quiet reverberation of footsteps, the interplay of light across curved surfaces, and the anticipation of performance creating an immersive experience. Harbin Opera House is more than a building. It is a testament to human creativity, technical mastery, and the enduring power of art to shape space and emotion. The Shenzhen Bay Sports Center rises like a futuristic wave along the southern coast, immediately capturing attention with its flowing rooflines, expansive glass facades, and integration with the surrounding waterfront. The complex embodies ambition, innovation, and the city's commitment to sports, culture, and public engagement. Inside, the center houses multiple stadiums, arenas, swimming complexes, and training facilities, all designed with state-of-the-art technology, energy-efficient systems, and architectural precision. Its sweeping forms and open layouts create a sense of motion and fluidity, reflecting both the dynamic nature of sport and the elegance of modern design. Completed in the 21st century, the Shenzhen Bay Sports Center exemplifies the fusion of engineering, urban planning, and cultural vision. It serves as a hub for international competitions, community activities, and large-scale events, symbolizing China's dedication to excellence and public participation. Walking through its airy concourses and stadium seating, visitors feel both energy and inspiration, the hum of activity, sunlight filtering through curved roofs, and the interplay of space and structure evoke excitement and awe. The Shenzhen Bay Sports Center is more than a venue. It is a testament to human creativity, technical mastery, and the ambition to shape spaces that celebrate athleticism, community, and modern urban life.
Ponce Aqueduct appears less like infrastructure and more like a surreal illusion, a narrow ribbon of water carried across the sky. Completed in 1805, this remarkable structure channels boats instead of vehicles, forming the highest navigable aqueduct in Britain. Stretching across the River Dee on slender cast-iron arches, it lifts canal traffic roughly 38 meters above the valley floor, offering travelers the uncanny sensation of floating at the edge of the horizon with nothing but open air beside them. Constructing such a structure more than 2 centuries ago demanded extraordinary ingenuity. Engineers faced the challenge of containing water, heavy, unpredictable, and unforgiving, within a long elevated trough that could neither leak nor collapse. The solution was revolutionary for its time: a watertight cast-iron channel supported by masonry piers and iron ribs, combining traditional materials with emerging industrial techniques. The aqueduct's narrow design minimized weight, while careful calculations ensured that both the load of the water and passing boats could be distributed evenly along its span. Beyond its technical brilliance, the aqueduct embodies the ambition of an era that sought to connect industries and communities through waterways. It stands as a testament to early industrial engineering, demonstrating how creativity and precision allowed builders to overcome the limitations of their time. Even today, crossing it remains a breathtaking experience, whether by boat gliding across its reflective surface or on foot along its towpath, reminding visitors that innovation often begins with daring ideas carried out against daunting odds. Ponce Aqueduct is not simply a historical artifact. It is a living example of how engineering vision can endure for generations. Its elegant arches and suspended canal continue to inspire awe, proving that even centuries-old structures can challenge perception and redefine what humans believe possible, transforming water itself into a pathway through the sky. Linking the mainland of Canada to the island province of Prince Edward Island, the Confederation Bridge is one of the longest bridges in the world to span ice-covered waters. Stretching roughly 12.9 kilometers across the Northumberland Strait, the structure permanently connected communities that once depended on ferries vulnerable to harsh winters and shifting sea ice. Opened in 1997, the bridge transformed regional mobility, allowing uninterrupted year-round travel and strengthening economic links that support tourism, agriculture, and trade in Atlantic Canada. Engineering a bridge in this environment demanded solutions rarely required elsewhere. The strait regularly freezes, and drifting ice sheets exert massive lateral forces capable of damaging conventional piers. Designers responded by shaping each pier with conical bases that break and deflect ice, reducing stress on the structure. Precast concrete segments, fabricated onshore, were transported and assembled with extreme precision, accelerating construction while maintaining durability standards suited to corrosive marine conditions. The gently curved deck also accounts for Earth's curvature and improves driver visibility, an often overlooked detail that reflects the interplay between safety and large-scale design. Beyond the technical achievement, the Confederation Bridge carries political and symbolic weight. Its name references the union that formed modern Canada, and its existence reshaped life on Prince Edward Island by removing geographic isolation that once limited development. While large infrastructure projects always spark debate, including concerns over environmental impact and financial cost, Measurable outcomes show increased connectivity and economic stability in the decades since completion. Today, the bridge stands as a reminder that megaprojects are not only feats of engineering, but also catalysts that redefine how regions interact, grow, and sustain themselves in challenging natural environments. Stretching across a dramatic canyon in the mountainous province of Hubei, the Siju Bridge stands as one of the most astonishing feats of modern bridge engineering. Completed in 2009 along the G50 Shanghai-Chongqing Expressway, the bridge spans an immense gorge carved by the Sidu River, with its deck suspended roughly 496 meters above the valley floor, making it among the highest bridges in the world by deck height. At this altitude, the structure doesn't simply cross terrain, it floats above it, transforming a once treacherous mountain journey into a seamless highway link. Constructing the bridge presented challenges that bordered on the surreal. The canyon was so deep and steep that conventional methods of stringing support cables were impossible. Engineers resorted to an unusual solution. Rockets were used to fire pilot lines across the gorge, allowing heavier cables to be pulled into place afterward. Massive towers anchor the suspension system on either side, and the main cables, composed of thousands of steel strands, support the roadway against powerful winds, seismic activity, and temperature fluctuations common to the region. Every element of the structure had to account for altitude, inaccessibility, and environmental stress, turning the project into a masterclass in adaptive engineering. Beyond its technical spectacle, the Siju Bridge dramatically reshaped regional connectivity. Travel that once required hours of winding through mountainous terrain was reduced to minutes, boosting economic integration and mobility throughout central China. Yet for drivers crossing its length, the experience remains breathtaking. An expansive horizon framed by steel cables and distant cliffs, a reminder of how human ingenuity can span even the most intimidating landscapes. The Siju Bridge is more than infrastructure. It is a testament to the relentless pursuit of solutions in extreme environments. Suspended high above a chasm once considered impassable, it demonstrates that with creativity, precision, and boldness, engineers can redefine the limits of geography itself, turning obstacles into pathways and impossibility into reality. Rising as a monument to human resilience against the relentless forces of the sea, the Delta Works stretches across the southwestern coast of the Netherlands, safeguarding a nation historically vulnerable to flooding. Born from tragedy, the devastating North Sea storm of 1953, which claimed over 1,800 lives and submerged vast stretches of farmland. The Delta Works is not a single structure, but a massive network of dams, sluices, locks, dikes, and movable storm barriers designed to control the flow of water from the sea into the low-lying delta region. Over decades, it has transformed the Dutch coastline, effectively shortening vulnerable stretches from hundreds of kilometers to a fraction of their former length, all while maintaining navigable waterways for commerce and transportation. The engineering feats involved in the Delta Works are nothing short of extraordinary. Movable barriers like the Maaslandkering can swing into place to protect against storm surges, while massive sluice gates control water levels with precision across interconnected estuaries. Each component had to be carefully modeled and tested, considering extreme tides, storm frequency, soil subsidence, and the long-term impact of climate change. Advanced hydraulic systems, reinforced concrete, and innovative construction techniques allowed engineers to build structures that could withstand immense pressure from the North Sea, while also being adaptable to future environmental conditions. A rare blend of strength, flexibility, and foresight. Beyond the technical accomplishment, the Delta Works represents a national commitment to living with water rather than simply fighting it. The project integrates ecological considerations, allowing tidal flows in certain areas to sustain wetlands and marine habitats, while also ensuring safety for millions of residents and protecting economic infrastructure. It has become a model for coastal engineering worldwide, demonstrating how science, planning, and human ingenuity can transform a landscape once considered perilously unstable into one of security and sustainability. Standing before the Delta Works today, one sees more than concrete and steel. It is a testament to the Dutch mastery of water, the ability to plan for centuries ahead, and the enduring spirit to protect life and livelihood from one of nature's most persistent threats. It reminds us that the most ambitious megaprojects are not always about vertical height or record-breaking spans. Sometimes, their greatest impact is measured in the lives they save and the landscapes they preserve. Spanning thousands of kilometers across western China, the Taklamakan Desert is often called the Sea of Death, a vast expanse of shifting sand dunes, brutal heat, and arid plains that have challenged travelers for centuries. Stretching roughly 1,000 kilometers east to west and covering an area of about 337,000 square kilometers, it is one of the largest sandy deserts in the world, and its inhospitable conditions have made every crossing a formidable feat of endurance and planning. Yet despite its harshness, modern engineering has transformed human interaction with this forbidding landscape, connecting settlements, trade routes, and resources that were once isolated by the sheer scale of nature. Historically, the desert was a barrier along the ancient Silk Road, with caravans risking dehydration, sandstorms, and extreme temperature fluctuations to move goods between east and west. Today, modern highways, railways, and pipelines traverse this vast terrain, including sections of the Taklamakan Desert Highway, which required innovative construction techniques to prevent roads from being buried by shifting sands. Engineers used stabilizing sand barriers, gravel layers, and carefully designed embankments to ensure that infrastructure could endure the relentless wind and moving dunes. Water scarcity, extreme summer heat exceeding 40 degrees Celsius, and freezing winter temperatures demanded durable materials and constant maintenance. A true testament to human ingenuity confronting nature at its most extreme. The Taklamakan Desert is more than a natural obstacle. It is a laboratory for adaptation, planning, and survival. Modern projects in the region, from transport corridors to energy pipelines, illustrate how careful engineering can turn seemingly impossible terrain into functional space. Yet the desert retains its wild majesty. Sand seas shift overnight, mirages appear on the horizon, and ancient trade routes whisper the stories of travelers who dared to cross it centuries ago. In a world dominated by urban megastructures and towering bridges, the Taklamakan reminds us that even landscapes, not just steel and concrete, can present engineering challenges that test the limits of human ambition. It is a place where survival, innovation, and the raw power of nature converge, offering a humbling perspective on the scale of our environment and the audacity required to tame it. Perched on the sun-drenched coast of Chile, San Alfonso del Mar is a striking example of human ambition transforming leisure into a feat of engineering. Opened in 2006 in the seaside town of Algarrobo, the resort is home to the world's largest man-made swimming pool, stretching over 1,013 meters and covering nearly 20 hectares, holding more than 250 million liters of crystal-clear seawater. Beyond sheer scale, the pool represents a marriage of cutting-edge technology, environmental management, and aesthetic vision, making it one of the most visually stunning and technically impressive leisure facilities ever constructed. Engineering the pool required solving challenges rarely encountered in conventional construction. To maintain its enormous volume of water, Engineers devised a filtration and circulation system capable of moving 66 million gallons daily, ensuring the water remained clean, clear, and safe for swimmers. The design also accounts for ocean water replacement and temperature regulation, while preventing structural stress and leaks over such unprecedented distances. Surrounding the pool, high-end residential towers, landscape gardens, and recreational facilities were strategically integrated to offer both panoramic ocean views and seamless access to the aquatic centerpiece, demonstrating meticulous urban planning at resort scale. San Alfonso del Mar is more than a pool. It's a destination that reshapes expectations of human interaction with natural landscapes. The lagoon allows kayaking, sailing, and other water sports in a controlled environment, while preserving the aesthetics of the coastal terrain. Its success reflects both technological mastery and visionary design, illustrating how ambition and innovation can turn a natural resource, the sea, into a monumental recreational experience without entirely replacing the environment it inhabits. Today, the resort stands as a symbol of bold thinking in civil and leisure engineering, where human creativity transforms scale into spectacle. It reminds us that mega projects need not only serve utility or industry. Some are built purely to inspire awe, providing a glimpse of how far design, technology, and imagination can push the boundaries of possibility. The Avenue high-speed rail is Spain's crowning achievement in modern rail travel, connecting major cities like Madrid, Barcelona, and Seville at speeds exceeding 300 kilometers per hour. Launched in 1992, the Avenue transformed transportation across the Iberian Peninsula, drastically reducing travel times and linking regions once separated by long, arduous journeys. Its sleek, aerodynamic trains glide along dedicated tracks, crossing rivers, plains, and mountains with precision and efficiency, demonstrating how high-speed rail can combine speed, comfort, and environmental sustainability. Beyond its performance, the Avenue network represents a feat of engineering. Bridges, tunnels, and viaducts were constructed to maintain straight, level tracks required for such high speeds, while advanced signaling and control systems ensure safety even at full velocity. The network has reduced reliance on cars and short-haul flights, lowering carbon emissions and promoting regional connectivity. The Avenue is more than a train. It's a symbol of how modern infrastructure can reshape mobility, economy, and lifestyle, proving that even in sprawling landscapes, distance can be conquered with precision, planning, and technology.
The Beilong elevator rises like a ribbon of glass and steel against the sheer cliffs of Zhangjiajie, immediately conveying awe, ambition, and the marriage of engineering with nature. Suspended over 330 meters above the valley floor, it offers visitors a breathtaking ascent through mist, forest canopies, and towering sandstone pillars embedded directly into the quartz sandstone cliffs. The elevator is designed to withstand wind, seismic activity, and the dramatic temperature variations of the region. Its glass cabins provide panoramic views, turning the journey into both a transport experience and a visual spectacle of the surrounding surreal landscape. Completed in 2002, the Beilong elevator exemplifies China's ability to merge tourism infrastructure with delicate natural environments. Years of geological surveys, structural reinforcements, and precision construction ensure safety while preserving the dramatic cliffs and fragile ecosystem. Ascending in near silence, visitors feel suspended between earth and sky, clouds drifting below, sandstone towers looming, and a sense of exhilaration tempered by humility before nature's grandeur. The Beilong elevator is more than a ride. It is a testament to human courage, technological mastery, and the enduring desire to reach new heights amidst the majesty of the natural world. Guangzhou Shopping Center rises like a modern urban jewel, immediately capturing attention with its sleek glass facade, dynamic geometry, and bustling energy. Designed as a hub for commerce, leisure, and social gathering, it reflects both the city's economic ambition and contemporary architectural vision. Inside, the center houses retail outlets, entertainment zones, restaurants, and public plazas, all arranged to create fluid movement and immersive experiences for visitors. Advanced structural engineering, climate control systems, and open atriums ensure comfort, safety, and a sense of spaciousness despite the high foot traffic. Completed in the 21st century, the Guangzhou Shopping Center embodies the fusion of economic vitality, modern design, and urban planning. Its architecture communicates energy, accessibility, and the city's role as a regional commercial powerhouse. Walking through its lively corridors and open spaces, visitors feel the rhythm of urban life, the hum of activity, the reflection of lights on polished floors, and the constant motion of people creating a living, breathing environment. The Guangzhou Shopping Center is more than a mall. It is a testament to human ingenuity, architectural mastery, and the vibrant pulse of modern Chinese cities. The intercontinental Changsha Wonderland rises like a fantastical vision embedded into the cliffs of Changsha, immediately captivating with its daring integration of luxury architecture and natural terrain. The hotel appears to emerge from the mountainside itself, blending seamlessly with waterfalls, valleys, and lush greenery. Designed as a luxury resort, the complex houses guest rooms, restaurants, observation decks, and immersive leisure spaces, all engineered to harmonize with the steep cliffs and flowing streams below. Advanced structural supports, reinforced materials, and precise geological planning ensure safety while preserving the dramatic beauty of the landscape. Completed in the 21st century, the resort exemplifies China's ability to merge architecture, engineering, and environmental design into a singularly breathtaking experience. Every terrace, glass balcony, and cascading pathway celebrates both human ingenuity and the surrounding natural wonder. Walking through the hotel, visitors feel suspended between earth and sky. Waterfalls cascading beside walkways, panoramic views opening from every corner, and a sense of awe at the seamless fusion of luxury and nature. Intercontinental Changsha Wonderland is more than a hotel. It is a testament to creativity, technical mastery, and the bold ambition to transform imagination into tangible, immersive experience. The Guangzhou Low Carbon Museum rises like a beacon of sustainability in the heart of the city, immediately conveying innovation, environmental consciousness, and modern architectural elegance. Its sleek lines, glass facades, and green terraces reflect a commitment to ecological design and the city's ambition to lead in sustainable development. Inside, the museum houses exhibition halls, interactive installations, and research spaces dedicated to renewable energy, green technology, and climate awareness. Advanced energy-saving systems, solar integration, and natural ventilation ensure the building itself demonstrates the principles it teaches, blending functionality with ecological responsibility. Completed in the 21st century, the Guangzhou Low Carbon Museum embodies a fusion of architectural innovation, environmental engineering, and educational purpose. Every detail, from sustainable materials to fluid spatial layouts, communicates a vision of progress that harmonizes human activity with nature. Walking through its illuminated halls and open terraces, visitors feel both inspiration and responsibility. The gentle hum of technology, the interplay of natural light, and the immersive exhibits evoke reflection, curiosity, and appreciation for a greener future. The Guangzhou Low Carbon Museum is more than a building. It is a living testament to human ingenuity, environmental stewardship, and the ambition to shape a sustainable world. The Sanya International Duty-Free Complex rises along the tropical coastline like a shimmering gateway to global commerce, immediately capturing attention with its expansive glass facades, flowing forms, and modern elegance. Its design conveys ambition, luxury, and China's growing role in international retail. Inside, the complex houses hundreds of premium retail outlets, dining experiences, and leisure spaces, all arranged to create a seamless flow of exploration and discovery. Advanced climate control, sustainable materials, and structural innovations ensure comfort, safety, and durability in the tropical environment. Completed in the 21st century, the complex embodies the fusion of architectural innovation, commercial ambition, and visitor experience. Every corridor, atrium, and observation deck reflects a balance of luxury, accessibility, and visual drama. Walking through the bustling halls, visitors feel both excitement and awe. Sunlight glinting off polished surfaces, the hum of shoppers blending with curated sounds, and the expansive spatial design creating a sense of grandeur. The Sanya International Duty-Free Complex is more than a shopping center. It is a testament to human creativity, engineering precision, and the ability to craft immersive, world-class experiences in modern China. From soaring skyscrapers to engineering marvels, from vast highways to serene cultural landmarks, China's mega-projects reveal a nation where ambition meets innovation and creativity confronts the extremes of nature. Each structure, bridge, and cultural space stands as a testament to human ingenuity, resilience, and the relentless pursuit of progress. Traveling across deserts, mountains, rivers, and cities, we witness how engineering transforms landscapes, how architecture shapes experience, and how vision becomes reality on a monumental scale. These projects are not just feats of construction. They are symbols of determination, courage, and the imagination of a nation striving to connect people, culture, and the future. As we step back from these wonders, the rhythm of progress, the dialogue between nature and technology, and the harmony of past and future become clear. China's mega projects remind us that human potential knows no bounds, and that every challenge, no matter how vast, can be met with creativity, precision, and vision. This is more than infrastructure. This is a story of ambition, endurance, and the remarkable journey of a civilization building its future, one monumental project at a time.
In a world where imagination refuses to stay grounded, humanity continues to build in places where construction should be impossible. Across oceans, deserts, mountains, and crowded skylines, engineers push beyond logic, gravity, and sometimes even safety itself. These are not ordinary buildings or bridges. They are bold experiments in steel, glass, and concrete, standing at the razor's edge between brilliance and catastrophe. From structures that pierce the clouds to projects that reshape entire coastlines, every one of them represents thousands of calculations, sleepless nights, and risks that could have ended in failure. A single miscalculation can mean collapse, chaos, or billions lost. Yet against those odds, these mega projects rise, rewriting the limits of what humanity can create. Today, join us as we journey across the planet to uncover engineering feats so ambitious, so daring, and so breathtaking that even seasoned experts pause in disbelief. From towering icons to hidden technical wonders, this episode explores the next chapter of impossible construction, projects that challenge nature, redefine cities, and prove that ambition is often the strongest foundation of all. Glowing like a digital planet rising from the desert skyline, Sphere has become one of the most striking architectural experiments of the modern era in Los Las Vegas. Completed in 2023, the structure towers roughly 112 meters high and 157 meters wide, making it the largest spherical building ever constructed. Its exterior, known as the exosphere, is wrapped in millions of programmable LED lights that transform the entire surface into a living display, capable of showing hyper-realistic animations visible across the city. Rather than blending into the skyline, the sphere dominates it, functioning as both architecture and broadcast medium, redefining what urban landmarks can communicate visually and culturally. Constructing such a structure pushed engineers into unfamiliar territory. A perfect sphere is inherently difficult to build because conventional buildings rely on vertical and horizontal repetition, while this project required complex curvature in every direction. Thousands of steel components were fabricated with millimeter precision to form the geodesic framework supporting the outer shell. The LED system itself had to account for heat dissipation, power distribution, and maintenance accessibility, all while maintaining flawless image continuity across the curved surface. Inside, the venue houses a massive, immersive auditorium equipped with a wraparound screen exceeding 16K resolution, advanced beam-forming audio that directs sound to specific seats, and environmental effects such as vibration and scene integration, blending structural engineering with entertainment technology at a scale rarely attempted before. Operational challenges were equally demanding. Managing tens of thousands of visitors requires carefully engineered circulation paths, climate control, and acoustic isolation to prevent distortion within the spherical interior. Engineers incorporated vibration damping and structural reinforcement to maintain stability during large events, ensuring both safety and performance quality. The sphere demonstrates how modern megaprojects increasingly intersect multiple disciplines: architecture, digital media, electronics, and experiential design, creating environments that are simultaneously buildings and interactive platforms. More broadly, the sphere represents a philosophical shift in how cities create identity. Rather than serving only functional or symbolic roles, landmarks now compete for attention in a global media ecosystem. This structure turns itself into content, constantly changing, engaging audiences both physically and remotely, and reshaping expectations for entertainment venues worldwide. Standing before it, one realizes that it is less a building and more an evolving interface between technology and urban life. A glimpse into how architecture may operate in the decades ahead, where imagination and engineering merge to produce experiences as memorable as the structures themselves. Soaring above the banks of the Mississippi River, the Gateway Arch stands presence transformed the St. Louis skyline, attracting millions of visitors from around the world who marvel at its scale, design, and the breathtaking panoramic views of the Mississippi River and cityscape from its observation deck. The Gateway Arch is more than steel and concrete. It is a triumph of visionary design, technical precision, and the enduring human desire to create monuments that inspire, commemorate, and endure across generations. Rising sharply from the skyline of Chicago, the Willis Tower, formerly known as the Sears Tower, is an enduring icon of architectural ambition and engineering mastery. Completed in 1973, this 108-story marvel stood as the tallest building in the world for over 2 decades, reaching a staggering height of 442 meters to its roof, or 527 meters, including its antennas. Beyond its sheer vertical scale, the Willis Tower represents a triumph of structural innovation, where bold design and practical engineering merged to redefine what was possible in urban construction. The tower's distinctive bundled tube design, conceived by structural engineer Fazlur Rahman Khan, allows for both strength and flexibility, enabling the building to withstand fierce winds and the seasonal thermal stresses of the Midwest. Each of the 9 interconnected tubes rises to varying heights, distributing weight and reducing swaying at extreme elevations, while advanced elevators zip visitors from street level to sky-high observation decks in seconds. The sky deck on the 103rd floor, including the glass-floored ledge, offers panoramic views of Chicago and Lake Michigan, giving millions a literal and metaphorical perspective on human ambition towering above the cityscape. Constructing the Willis Tower demanded meticulous planning, precision, and innovation. From fabricating high-strength steel components to managing complex logistics in a dense urban environment, engineers and builders overcame immense challenges. Its impact goes beyond architecture. The tower transformed Chicago's global identity, inspiring both urban development and public fascination with skyscrapers. Today, the Willis Tower is more than a building. It's a symbol of human ingenuity, resilience, and the audacity to reach ever higher, reminding us that the skyline is not just a backdrop, but a testament to the dreams and determination of those who dared to build it. Rising like a vision pulled straight from tomorrow's imagination, the Museum of the Future dominates the skyline of Dubai as one of the most unconventional structures of modern architecture. Opened in 2022, the building's torus-shaped form, a gleaming oval ring with a hollow center, symbolizes humanity's continuous pursuit of knowledge and innovation. Its stainless steel facade is etched with flowing Arabic calligraphy, illuminated at night, blending cultural identity with futuristic design and turning the structure itself into a living statement about progress and imagination. Constructing this landmark pushed engineering far beyond traditional methods. Unlike typical towers built on repeating floor plates, nearly every panel of the building's outer shell is unique, requiring advanced parametric design and robotic fabrication. More than 1,000 precisely manufactured steel and composite panels form the curved envelope, demanding digital modeling tools capable of translating complex geometry into buildable reality. Inside, column-free exhibition spaces were achieved through a sophisticated structural frame that distributes loads through the ring, allowing immersive installations without obstruction. Even the facade functions as more than decoration. It manages heat, light, and energy efficiency in the harsh desert climate, integrating sustainability into spectacle. Yet the museum's significance extends beyond its engineering triumph. dedicated to exploring emerging technologies, climate solutions, and future societies. It reflects the ambition of Dubai to position itself at the forefront of innovation and global dialogue about tomorrow's challenges. Visitors move through interactive experiences designed to provoke thought about space exploration, artificial intelligence, and environmental resilience, transforming architecture into narrative, a place where structure and storytelling merge seamlessly. Standing before the Museum of the Future, you witness more than a building. You encounter a statement about possibility. It demonstrates how architecture can transcend function, becoming both symbol and laboratory, reminding us that the boldest megaprojects are those that challenge us not just to build bigger, but to imagine further. Suspended high above the lush valleys of Zhangjiajie National Forest Park, the Zhangjiajie Glass Bridge redefines both thrill and engineering. Opened in 2016, this breathtaking structure stretches 430 meters across a deep canyon and hangs 300 meters above the forest floor, offering visitors an unparalleled view of the towering sandstone pillars that inspired the landscapes in movies like Avatar. More than a tourist attraction, the bridge is a masterclass in precision engineering, demonstrating how human ingenuity can create safe yet heart-stopping experiences in extreme natural environments. The construction of the bridge required extraordinary innovation. Engineers had to design a deck capable of supporting thousands of visitors simultaneously while remaining transparent and visually seamless. The steel frame, combined with multiple layers of tempered glass panels, ensures both strength and resilience against wind, temperature fluctuations, and seismic activity. Each glass panel is engineered to withstand several tons of weight, giving visitors the sensation of walking on air without compromising safety. Vibration dampers, high-tension cables, and reinforced anchor points were meticulously calibrated to keep the bridge stable despite the forces of gravity and the natural sway caused by human traffic. Beyond its technical achievements, the Zhangjiajie Glass Bridge represents a bold vision for tourism and architectural spectacle. It allows visitors to intimately experience the dramatic verticality of the park, bridging extreme natural beauty with human creativity. The bridge has not only become a global icon of design, but also a symbol of how modern engineering can transform a landscape into an unforgettable experience, blending safety, innovation, and sheer awe-inspiring scale. Walking across it, one cannot help but feel both the fragility and the power of human ambition suspended high above the earth. Carved silently beneath the restless waters of the English Channel, the Channel Tunnel stands as one of the most ambitious infrastructure projects ever attempted between the United Kingdom and France. Stretching roughly 50 kilometers, with about 37 kilometers running underwater, is the longest undersea rail tunnel in the world. Opened in 1994 after years of planning and construction, the tunnel permanently connected the British Isles to mainland Europe by rail, transforming trade, travel, and cultural exchange. What once required ferries or flights could now be traversed in minutes beneath the seabed, a triumph that many once considered impractical or even impossible. Constructing this passage demanded precision on a historic scale. Teams bored from both sides simultaneously using giant tunnel boring machines, navigating through chalk marl rock chosen for its stability and low permeability. Meeting beneath the seabed required alignment accuracy measured in centimeters, a testament to advanced surveying and engineering coordination. The project ultimately created 3 parallel tunnels, 2 rail tunnels, and a central service tunnel used for maintenance and emergency access. Engineers also had to address ventilation, fire safety, and pressure control in an enclosed environment carrying high-speed trains, integrating redundant safety systems that continue to set standards for modern tunnel infrastructure. Beyond its engineering complexity, the Channel Tunnel reshaped economic and social connections across Europe. Freight flows became faster and more efficient, tourism surged, and the psychological barrier of sea separation diminished. Yet its creation was not without controversy. Financial overruns, political negotiations, and technical challenges tested both governments and contractors. Still, its successful completion demonstrated how cooperation and technological innovation can overcome geographic obstacles once thought insurmountable. Today, the Channel Tunnel is more than a transportation corridor. It is a symbol of persistence, collaboration, and engineering confidence. It reminds us that megaprojects are not only about conquering nature's barriers, but also about redefining how societies connect. Beneath layers of rock and ocean water, steel rails carry millions of passengers and tons of goods each year, quietly proving that some of humanity's boldest achievements remain hidden from view, yet profoundly shape the world above.